All right. Good morning, everyone here live in South Korea, and good morning, afternoon, or evening to everyone watching on the live stream or watching the live stream after. Today, I'm going to give a workshop on IBC, how to get started with it. But first, a little bit about myself. I am Thomas de Keyser. I work as an IBC DevRels at Interchain GmbH. Started doing that in February this year, so only like 6 months. So pretty new to the ecosystem, but very excited about interoperability in IBC. And hopefully I can share some of that excitement with you today. So before we start the workshop, let's look at the goals of the workshop. So what we'll be doing today is first and foremost get a high-level understanding of IBC to make sure that you can go and visit the docs yourself and know where to go and how to read them and follow and understand them. Then we also have the demo itself from the workshop. I already sent the people who are here a link. We'll see the link in a minute for those watching via the live stream. So for the workshop, if you feel comfortable following along with the commands, that's perfectly fine. If you're not and you don't want to multitask, you can just follow along with me. The most important thing is that you follow and understand what I'm doing rather than simply like copy pasting the commands so that you can do it on your own yourself later. Another important point that I want to mention is that in the Cosmos ecosystem, like development is always ongoing. So I think it's kind of important that you learn to manage different versions of the software, and in this particular case on the IBC demo, the relayer software. And this is particularly important because right now we're actually at a time when both major relayers, the Golang relayer and the Hermes relayer, are going to have a new major release soon. V2 for the Golang relayer, V1 for the Hermes relayer. So the versions that are specified in the demo, you can use them, and then everything should work fine. But feel free if you revisit the demo at a later time to try it out with your own version that is the latest at this time. And I think it's also important to look at what we're not going to do in this workshop. IBC is the inter-blockchain protocol, so you need 2 blockchains running to work with IBC. But it's out of the scope of this workshop to really look at how you build your own chains or your modules. We're not going to look too deeply at the code. And also custom configuration of your chain configs and the Genesis files. This is not something that we'll handle in this demo. You can, of course, always visit the docs or look at other workshops or the documentation. All right, so hopefully I will get your attention after this talk. And if you want to go further along the path of developing in Cosmos with IBC or with the Cosmos SDK or with Tendermint, I want to promote a little bit the Interchain Academy, Interchain Developer Academy that is. So this is essentially a program that we started in collaboration with B9 Labs that wants to train, it is 5,000 developers in the next 3 years, and this is free of cost. So this is a program that is self-paced, 6 weeks, and the intention is to train Web 2 developers into Web 3 developers or blockchain developers because we believe we need a lot of people to join us to make sure that we get the Cosmos ecosystem flourishing. So there are some next cohorts starting in September and December. So what you will be doing there is you will be building with the Cosmos SDK. You will also learn about Ignite CLI. You will learn about CosmJS to build your interfaces. You will learn how to run a validator node. And finally, you will also learn to run a relayer that enables IBC. And the idea is that if you follow this program and you finish it, you might get a better chance of getting hired at one of the core contributors in Cosmos. So actually the content that you have in the Interchain Developer Academy is exactly the same as the one that you will have in the Cosmos Developer Portal, so you can follow that with the link that is over there. It's tutorials.cosmos.network. So once again, we have all of the content that is there on the SDK, Ignite CLI, IBC, and CosmJS. We have some tutorials there, blog posts, and it's continuously in development. An important point is that probably if you're new to Cosmos and you're new to developing with the Cosmos stack, you might first want to go to the Cosmos developer portal, and this will make you ready to then go into the GitHub repos and into the documentation on your own. All right, so now about IBC. I think it's always important when you start learning about something new that you understand why you're doing it. And so IBC, as you can see, is the Interchain's universal general purpose interoperability protocol. And when you think about why do I use IBC, I think it kind of like splits into two parts. The first one is why do we want to use interoperability in the first place? And I think it's pretty clear at the state of blockchain industry right now that we won't have like one chain to rule them all, and that interoperability is actually quite important. A little anecdote from myself, I wanted to get into blockchain development since a long time already, I think 2017, 2018. And I didn't have any development experience back then, so I was really like looking at all the different languages, all the different ecosystems, and I found it quite hard to pick my particular ecosystem, because I thought like back then there was no interoperability, or at least less. I mean, Cosmos was there, but mainnet hadn't been launched. And so a choice for one particular ecosystem would be like quite a big choice in terms of energy and investment. And I think interoperability really helps the developers here, because if you build an application, you know that through interoperability, this application might be spreading out to all of the other ecosystems, and yeah, your application might be used to the full extent. And the second thing is, why would we pick IBC over competitors? Competitors, for example, being simple token bridges that use some multisig. Well, it's because IBC is secure. It works with a light client mechanism that we will look into a little bit more detail later. So basically, we don't need to trust the middleman, which in this case is the relayer. So we have two blockchains, and in between we have the relayer. We don't actually have to trust the relayer. Anyone can spin it up, and we're actually going to do that in this workshop. And we don't have to trust the relayer to make sure that yeah, our assets are secure. And so this is the permissionless aspect. And third, IBC also supports generalized message passing. So it's not just that we're able to send tokens from one chain to another, it's really that we can send any packet of arbitrary data over the relayer from chain A to chain B. All right, so this is a diagram about the Cosmos stack. Maybe many of you are already familiar with it, but still it's good to have a resume. So we have the Cosmos SDK, Tendermint Consensus core, and IBC. So Tendermint Consensus is at the bottom, so it takes care of the consensus and networking layer. Then we have the Cosmos SDK, which is the application building layer. And then we have IBC that takes care of interoperability. So right now in IBC, I think this may be already a little bit outdated. 45 chains are connected and some additional data. And even though IBC originated from the Cosmos stack, it's important to realize that it's not like limited to the Cosmos ecosystem. So we really have the aim of expanding IBC really to pretty much any chain that is out there. And some of the projects that you see there, Composable Finance has been working on bringing IBC to substrate-based chains, so in the Polkadot ecosystem, and this is almost finished. And then we also have the Near blockchain, which they are building a bridge towards. All right, so a first slide of IBC. I think you can look at the diagram first. So there we have our two blockchains, chain A on the left, chain B on the right. We have multiple relayers in between. So the relayers are the parties that are responsible for transferring the packets over to the other chain. And like we mentioned, this is permissionless. Everyone can simply spin up a relayer. So this is why we have the multiple relayers to really make sure that you understand that it's not just 1 or 2 relayers. Pretty much anyone can do this. And so also in the diagram we see the light client that is over there, but this we will look at in more detail. And what we also see is that we have kind of the split between the IBC tau, or transportation layer, and tau stands for transportation, authentication, and ordering. And so what this does is, this is the layer, the core layer, that is responsible for simply making sure that packets can be transported, authenticated, and ordered, if necessary, from one chain to the next. And then on top of that, we have the application layer. And this is really the layer that makes sure that we can encode, decode, and interpret the packets that are being sent. So for the transport layer, the packet data is pretty much opaque. We don't need to know what is in the packet. We just make sure that it gets sent. And then the application layer takes care of the packet data. This is, I guess, the diagram that if you understand it, you probably understand IBC on a high level. Don't be afraid of it. We're going to go through. I'm not sure if you can see my mouse here, but basically the top part of this diagram is the application layer. And most of you will probably be building IBC applications. So this top part is actually the one that you'll be mostly concerned with. So there we have, for example, a user that initiates some kind of transaction on an application. Then it will interact with IBC. And here we see the clients, connections, and the channels. We'll look into that in more detail. We also have some proofs, standardized key paths. And I think here it's very small, but we also have the relayer. And basically, when we have the IBC Go repo, which is the reference implementation of IBC that our team at Interchain maintains, pretty much we take care of all of this. So the clients, the connections, the channels, and everything around it, which is the transport layer, as I said. And then it's up to other developers to develop some applications, even though the IBC Go repo also contains some applications, 2 of which we will see in the workshop later. All right, so as I mentioned, we kind of have like 3 main layers of abstraction inside the IBC protocol. And I'm actually going to go from the bottom up to the top. First, we have clients. So clients track the consensus state of counterparty chains. So we can imagine that if we have 2 blockchains and we want them to communicate, we need to make sure that they understand how to interpret the state of the other blockchain so that they can really know that a packet was indeed sent. And this is what the client, or the light client, is responsible of. So essentially, when we send a packet on one chain, we will send or submit a commitment proof, and this will be recorded into the state. Then a relayer will construct the packet and add a proof that this was submitted into state, and then submit this on the receiving chain, which can then verify it using the light client of chain A that they have stored on chain B. And important to realize here is also that we have a different light client per consensus type. So like I said, the light client tracks the consensus state of the counterparty chains. So it's kind of logical that if you have a different type of consensus, that you need a different type of light client. And so for a long time, IBC was in fact limited to Cosmos chains, and more particularly to Tendermint consensus type chains. But now with the work that Composable has been doing, we can also go, for example, to Substrate, and hopefully many more will follow. Yeah, sorry. Then on top of clients, we have connections. So connections essentially, establish the connection between 2 blockchains once we have the clients set up. And what happens in the connections is basically kind of a double identity verification. So you must imagine when 2 blockchains want to connect with each other, that they kind of have a picture of the blockchain that they want to connect to, and the other blockchain also has a picture of the blockchain that they expect to connect to. And so what happens in the connection handshake, because both channels and connections will be set up by handshakes, what happens in the handshake is basically we're going to look, okay, are you who you say you are? So is the blockchain that wants to connect to me effectively the blockchain that they pretend to be? And is the picture that they have of me really me? All right, so it's kind of a double identity verification. And if that checks out, we set up the connection. And then we can have the last layer of abstraction, which is channels. And channels also get set up with a handshake. And channels actually identify, in combination with the port, they identify the application. So for example, if we have a fungible token transfer over IBC, this could be transfer slash channel 0, which is the channel. Transfer here would be the port name. So sometimes this is kind of misunderstood. People think a port should be like a number, like 8080, like we have in traditional web development. But in Cosmos development and IBC, it designates like the application. So for example, transfer, or for contracts with CosmWasm, this would be the contract address. And then here we have the base denom. An important point is, of course, the relay operators, because if we have two blockchains but no relay operators, then ultimately we cannot do communication. We've mentioned already a few times that relaying is permissionless. It's potentially incentivized. We are actually close to releasing the final version of IBC v4, which will include fee middleware. So fee middleware is an on-chain protocol that allows users to add fees to directly incentivize the relayers. It can be either the end user or chains could decide to do this themselves. Of course, up until now, relayers also got incentivized for the work that they do, but this was happening in a hybrid of ways. And if you click through this Medium blog post, it's called Relaying the Message, a deep dive into IBC relaying operations. We go into a little bit more detail on what relaying is, how you start it, and the different ways that relayers get rewarded. And then this is going to be important for today. So there's different implementations of relayer software. You can use any one of them, and actually in this workshop we will be using two different ones. So we have Hermes, which is written in Rust and developed by Informal Systems. And then we have the Go relayer, which is obviously written in Go, which is developed by Strangelove Ventures. Security is an important value of IBC. So it's good to look at the main two security principles that we have. The first is we need to trust the chains that we connect with. So this is different than, for example, a bridge that has a multisig, so a limited amount of parties that we trust to verify the transactions. In IBC, we don't have that. We have the Light client implementation. And ultimately, in IBC, we assume that the chains that we interact with are trusted. And if that is the case, then IBC will not falter. And the second one is fault isolation. So if anything were to happen, either through some kind of error or misbehavior of any party, if that were to happen, IBC and actually Cosmos as a whole has the idea of fault isolation, so that anything happens to, for example, one particular chain, if you have an interoperable ecosystem, it's quite important that you can isolate the faults and make sure that not the entire interchain will be affected. So for developers and people who want to build a chain with IBC, this is also kind of important. So what is needed to connect your chain with IBC? So first of all, you need to have a chain. This is obvious. But still, if you don't have a chain, so first you can build it, for example, with the Cosmos SDK, or even with Substrate. Now that Substrate can also be connected via IBC. The second thing you need is core IBC, which is a transport layer. As you see below in IBC, IBC Go, that is, we have this out of the box, the transportation layer, and then we need a light client on our own chain that is able to track the state of the counterparty, and we also need to make sure that the counterparty that we want to connect to also has a light client available that understands the consensus of our chain. And so in the best case scenario, for example, when you're using Cosmos SDK and this has a Tendermint consensus, this will be ready out of the box. If you have another type of consensus or another type of application framework than Cosmos SDK that you're using, it could involve a little bit more development work. And then there's also like an asterisk, which means that they're also like solo machine, which is, as the name implies, just one machine that we can also interact with IBC. And this happens instead of a light client, we have there some simple key verification method that enables you to interact with IBC. All right, so let's take a closer look at an IBC packet lifecycle. So this is the example of ICS-20, which is fungible token transfer over IBC. So on the left, we have our tokens that are being locked up on chain A by a user because they want to send over the tokens to chain B. In the middle, we see that after they have been locked up, this packet is indeed being sent. And as I mentioned before, on the chain B, what will happen then is the line client verification algorithm will check if indeed we did this locking up of the tokens on chain A. And if we have verified that this is indeed the case, we can then mint IBC vouchers representing the tokens of chain A on chain B. And this is another way of looking at this. So once again, we have the user here. This is a more generalized packet flow, by the way. So we can do this for tokens, but we can just as easily follow this for a regular packet that has any kind of data. So we have a user that wants to send over a packet. We go to app A. App A gives a send packet command to core IBC. Then we have the relayer who is going to query and see that the send packet has been submitted. So along with the proof, they submit a receive packet on the counterparty chain. When we have the on receive packet, some logic can be executed, and we will also have an acknowledgement that is being written, and then the acknowledgement will follow the opposite way back to the source chain, so that the source chain also knows that the packet has been received on the destination chain. All right, and after this we can, for the first time, go to the demo. So the link is right here. Oops. All right. I hope everyone can see this. So in the demo, we have the overview. Here setup is the installation. So I already sent you guys who are live here in Korea the instructions to install. So this is both the Hermes and Golang relayer. Also the repo itself you can clone. But first, before we start, let's look at what we're actually going to do in this demo. So in this demo, we're going to use two IBC applications. So remember I said we have the transportation layer, which is already finished, and then we have application layers. And the IBC Go repo also includes already ICS-20, which is token transfer, and also interchain accounts. And so today what we're going to do is we're going to have two chains. One chain is going to be HackATOM, the other chain is going to be Seoul. Because of interchain accounts, we have, we will see this later, controller and host. And so Seoul will be the host and HackATOM will be the controller. And the first thing we're going to do in the first part is we are going to send over some tokens from the Seoul chain to the HackATOM chain. And then in the second part, when we have interchain accounts, we will delegate some stake from the HackATOM chain to the Seoul chain without actually doing this on the Seoul chain. So we're going to do this from another chain, which is the functionality of interchain accounts. But that second part will be later. So the first part of the demo will be to send over some tokens from the Seoul chain to the HackATOM chain. I have my terminal set up here. It's a little bit difficult with the mic, but let's see. So first off, what we can do, I'm going to drop the mic for a bit. So yeah, you can first check if the binaries for Hermes and the Golang relayer are installed by simply using the version command. This should probably be fine. Then the next step, what we're going to do is we're going to bootstrap 2 chains and start them in the background. So if we go, for example, to the repo of the code, we see that we have a make file which has all of the different commands. When you scroll all the way to the bottom, those are the commands that we'll mostly be using in the demo. So here you see init that has the killdev, which basically makes sure that there's no chains running in the background, which can mess up with our program. And we're going to install the binaries. So let's go over and do this. So here we have make init. This will take a little while to set everything up. So here we can see it's installing the binary. The binary here will be ICAD. And you can see that a lot of things have been happening. To get a little bit of a better overview, we're going to take a quick look at the init command. So this is below network. Here it is. So basically here we have a number of variables. So we have mnemonics for some accounts. So we have a demo wallet. We have some validators that we're going to set up. We also have some accounts for our relayers. All the different ports, but like I said, we're not going to go too much into detail. That's out of the scope of this presentation. But as you can see, what we do here is we remove previous data, we initialize the chains, adding Genesis accounts, creating and collecting Genesis transactions to make sure that our validators that we will need have some stake delegated to them. And then we're just going to make sure that all of the defaults in the configs are being changed and that we have everything set up to have our particular setup. Here on the bottom, this is also important. This will be for interchain accounts, but we'll come back to that later. And then the start command, or the start script rather, is simply starting our binaries. And as we see that everything has worked out here, we can now trust that we have 2 chains running in the background, and we can go on to the next step. So here, this is just like to see the situation that we had before, make init. So basically, we had the code in our repo ready, but the chains were not built. This is why they have like the dotted lines. After we had this command, make init finished, we now have the chains that are ready. But to use IBC, we still need to make sure that we have our connections, well, actually our clients, connections, and our channels set up. But before that, we will also make sure that our relayers are configured. And so we have both commands. Now, in this demo, we'll be using both relayers. So we'll be using both of those commands. If you prefer one relayer over another, then you could decide, for example, to use only Hermes. An important addition to that is that right now in the version that we're using, version 2, the release candidate 3. Interchain account support was not yet added in the Golang relayer, but I think the version that was released yesterday, the release candidate 4, should include it, but I haven't been able to test it yet. All right. So this initialization of the Hermes relayer, essentially what it's doing, as you can see, it is setting up keys. So just that we have keys set up for our relayer accounts. So if we need to submit messages with our relayer, that they have an account that is also funded. We can also take a look here in the repo below network. Network is actually the only folder that we will be using often in the demo. So if we look at Hermes, we see here that we have the config.toml. And essentially for all relayers, what is important is that we set up the config for Hermes. For example, what you can do is you can go to the Hermes website. And on the Hermes website, you will find some information on the installation. If you had some issues of installing. And then also we have the configuration and an example configuration file, which has also a lot of comments on what the different parameters are. But so for Hermes, it's important that you copy-paste this file and make sure that if we have our chains here below, this is the most important thing, that we have everything that is correctly filled in. So here we see that our chain ID is HackATOM for one chain, Seoul for the other chain, and then some other ones that are important are the RPC and gRPC ports, and also the WebSocket, and some other parameters. Key name, for example, is also important. This is the key that we just set up in the make init Hermes relayer script. And this is what we do for Hermes. And then we have a similar thing for the Golang relayer. And actually in this script for the Golang relayer, let's look at it for a second. Should be this one. Here we will actually have the command relay config init. And essentially what that does is it creates the configuration file for you if you haven't got one yet. So the default folder is in your home directory with .relayer. But here actually we are using a custom home folder. So oftentimes when you are developing yourself, you may want to choose this option just so that you don't clutter your main configuration file, especially if you're testing locally like we are doing now in the demo. It could be very useful to have a custom configuration file and then use your main configuration file if you're relaying on mainnet. And as you can see, we have initializing, adding configurations for both the chains and some paths. And then restoring accounts, again, is making sure that we have our relayer accounts funded and with the keys attached. All right, so then we can go back to the demo repo and look at the next step. So as you can see here, the next step is to create a connection between both chains. So this is the IBC part. And we're also going to create a channel that is for ICS-20 transfers. And so when we have one of those two commands, it's important that you don't do both, because then we will have two separate connections and two separate ICS-20 channels. And so for this demo, we're going to use the Golang relayer for the first part. So we're going to execute this command. So we have make setup Golang relayer. And so this is going to go through the steps. So here we see, for example, already a client created. So it's going to create some IBC Lite clients on the chain. So we have clients created. What else can we see? The next thing when we have our clients created is the connections. So they're on top of the clients. Connections, they have a handshake. Let's see if we can find some information. Something to note here is that this could be a little confusing in that you have a lot of errors, but that doesn't necessarily mean that there are in fact errors. Sometimes it's just that we are querying for packets, for example, and that it's not finding packets just because there aren't any, so don't be fooled by that. Actually, what we can do is when you have this set up, so the script has finished, and now we can actually check if we have the required connections and channel. So by the way, I have a tab here for a relayer. I also have 2 tabs for the controller chain and for the host chain. So controller chain is HackATOM, host chain is Seoul, and a separate terminal tab for the relayer. And so this will be like very important, is that when you have the binary that you can use the help function. And actually when you go and look at the repo for the Golang relayer, here it is, you will see that they have some documentation, but they do say that it's probably better to look directly at the help, and then you will see the available commands. So we have something to set up the config, which we already did, chains, path, keys, but we can also query. So what we're trying to do right now is we're trying to query for the connection and the channels to see if they have been correctly set up. So there we see that, for example, we have relay query clients, but clients created this we got, so let's try connections. And so I'm first going to try it like this, but this is going to give a mistake. And the reason why is because we have chosen a custom home directory for our configuration file. So this we also need to give into the command line. And if you have JQ installed, this is a tool that will output the information in JSON format, which is a little bit nicer to read. Let's see. Looks like we still, oh yeah, we forgot the chain. All right, so it's important that you also tell on which chain you want to look for connections. We can do this on both chains. I've now done it for HackATOM. And here we see indeed that we have a connection ID, connection 0. So in fact, our connection has been established. Some more information you see here is that our connection builds on top of a client. So we can see the client. So it's going to be a Tendermint client, and it's ID 0. We have some version information, the state. So our connection handshake is essentially going to finish with both connection ends in the open state, and then we have some information about the counterparty. And then we're going to do a similar thing, but this time for channels to see if our channel has been correctly set up. And there we see that we also have a channel. So here we see some information. It's an unordered channel. So token transfer channels are unordered. Channel is open. Port ID is transfer. So we're working with ICS20 token transfers. Okay, so that looks good to go. When we go back to the repo, then we can start the fungible token transfer part. And first thing that we're going to do here, this is just to make our lives a little bit easier. These are two commands that are going to export some environment variables. These are the demo wallets. So on each chain, we're going to have a demo wallet that has some funds attached to it that we can use. All right. And it's important if you do this that you pretty much do it in each of the different tabs. Now for me, this should already be fine because I did this in the preparation, but let's just do it again just to be sure. There we go. And then we can go to the first transaction. So now we have set up the client connection and the channel for transfer. We can go ahead and take a look at the actual command. So here we see we have the binary, TX, IBC transfer, a lot of transfers. But the way that you would go about it, if you are unsure what the command is, you could so you could go and check also with the help command, and then, for example, you will see transaction and basically do the different steps until you find this command. Let's copy it. And actually, we want to send some tokens from the host chains from Seoul to HackATOM. So this is this terminal command. It's actually not really necessary to have the correct tab, because ultimately here we have the node which we are specifying, right? So even if we were to submit this command in the different tab, it would still work. But I think it's just like easier to follow if you do it in the correct tab. So now we're going to send this command where we are sending, I think it's 11,000 stake, which we're sending from the demo wallet 2 on the Seoul chain to the demo wallet 1 on the HackATOM chain. All right, and actually I noticed that I forgot to spin up my relayer, which obviously we need to do. Oh, and by the way, I see that I didn't add this in the repo, so this is something we should do. Oh, and actually I started the Hermes relayer. I meant to start the Golang relayer, but both will work. All right, so here we see that some packet has been sent. I think the timeout is set at 1 minute, so we were just in time to make sure that there was no timeout. And now we can check if we have received our funds by using this command. So this is just a query to see if what funds are available in the demo wallet. This is on the controller chain. And here we see that we have 11,000. And what we see here is actually not the stake. So we sent 11,000 stake from the host chain. But what we see here is, like I said, it's an IBC voucher. And this is a representation of the 11,000 stake, but on chain Seoul. And because this is obviously not super easy to read, we also have a command that allows you to have this hash and actually reverse it and give you the regular output. So this is the command denom trace, and we can do this on the HackATOM chain. So query IBC transfer denom trace, and then you just submit the hash. So IBC here is just a prepend to clarify to people that this is an IBC asset. And if we put enter, then we see that we have the base denom, which was the stake that was used on the host chain, on the Seoul chain. And then we have some path information, like we said. This has the port, which is transfer, and then the channel 0. And basically, this uniquely identifies, because our channel goes from the Seoul chain to the HackATOM chain. So this uniquely identifies the IBC asset. All right, so now we have some assets on the controller chain from the host chain, and this will set us up for, we can probably kill this for a minute, and this will set us up for the second part, which is interchain accounts, but first we'll go back to the presentation for that. All right, so token transfers we have now seen in action and seen that it works. And token transfer is an important first step. But of course, like we mentioned in the introduction, with IBC we can send arbitrary data. So we don't just want to send some tokens. We also want some more customizable application logic. And so you could do this in 2 different ways at the time. So we have interchain accounts and custom IBC applications, and we're kind of going to take a look at what the difference is between both and why you would use one or maybe the other. So let's start off with custom IBC applications. So essentially, this is a module, an IBC module that you build from scratch yourself. So in the documentation, we could take a look at this. So here we have the IBC Go documentation. Here, applications. This will basically go over all the different things that you have to do to build an IBC application module. So we have to implement IBC module interface. So this will have some channel opening, handshake callbacks, channel closing handshake callbacks, packet callbacks. It will bind to a port, like the transfer port that we saw with token transfer, adding keeper methods, and so on. So basically, this should give you an overview of all the things that you need to implement to have an IBC module. And then, of course, what you will need to do is add your specific application logic. So this is basically like a completely customizable way of developing application modules. So here we see that we have a module that we build. We can send pretty much any data that we want. Then it goes to the corresponding module on the counterparty. And what we see here on top is that we have ICS-X. For example, token transfer was ICS-20. So the number actually defines a particular application. Now, the thing is, when we develop these applications, like it takes a lot of development effort. Also, it will take some time for it to get standardized. For example, recently we had the ICS 721, which implements the spec and the implementation of interchain NFTs. But this, takes some time to develop. And if you want a lot of customizability in the application logic, this may be the way to go. But if what you need is something else, you could also use interchain accounts. So what interchain accounts allows you is basically to use functionality on the host chain. So here this is chain B, to be used by a module or an account on chain A, which is the controller chain. So I like to think of it as pretty much an API. So for example, say that we are developers on chain A, and we are developing some type of module. And during this module, during our execution of the logic, we would need some functionality that is present not on our chain, but on chain B, for example. So what we can use interchain accounts for is basically to have a programmatic way to use this functionality on chain B without leaving the environment of our own chain A. So to make this a little bit more clear, we're going to take a look at the architecture. So So once again, the different namings, like it's important to get some familiarity with that. So we have the host chain, which is the chain that will host the interchain account, and then we have the controller chain. So the controller chain is the chain that will trigger the actions to be executed on the host chain. Once again, you can think of it like an API. And then these two things we'll take a closer look at in the next picture. But what is important to notice is that as a chain, you could choose to implement both host and controller functionality, or you could simply choose to implement one of each, right? So you have the choice in that. And actually what we've seen up until today is that most chains have, or a lot of chains actually have had this host functionality included, but not yet controller functionality. And we'll take a look at why this is. So here we see another diagram. So again, on the left we have the controller chain, on the right we have the host chain. So what is happening, this is for actually already an execution of a transaction. First thing actually is that we need to register this interchain account. So when we see the two main functionalities of interchain accounts, this is register interchain account, and then we can send a transaction. But the important thing here is that on the controller chain, ICS27, the module that is present in IBC Go, implements this, and this actually works as middleware, but this has to have an authentication module that basically has to be built customly by the developers. And that's why we think that, you know, up until now there's not so much adoption of controller chain, because chains will have to figure out how to build the authentication module. And again, we have in our docs like step-by-step guides on how to do it, but still it takes a little bit more time. But basically when we have this, we can wrap the middleware around, and then we can go to the other chain where we will route the transactions to be executed to the interchain account. And the interchain account, which is just actually a regular account, can submit the transaction on the host chain. Something important to notice here, and maybe this will be easier with this, is that the original intention of interchain accounts was not to make sure that just any account on chain A could control an account on chain B, right? This is actually possible, and in the demo this is exactly what we're going to do. But this was not the intended use case of interchain accounts. More so, it was the intention to have a chain itself, or a module on this chain, control an interchain account on another chain, and so, again, to use it as an API. But still, there's a few different ways to do it, and we can take a look at this. So, first and foremost, the most simple is just single user. Every single user has one separate interchain account. This is what we're going to do in the demo. And what is actually easy about this is that when we have this module with the two different functionalities, register interchain account and send TX, in this case, you simply make sure that your authentication module exposes these two methods directly to the end user via the command line interface. And so a small variation on this is if the interchain account is actually a contract, smart contract account, for example in CosmWasm. And then we have like the more like intended use cases of interchain accounts, which we call few to one. So this is, for example, a DAO or a group. The groups and gov interface of the Cosmos SDK 046 will make this a lot easier, so we're already working to make sure that we can use this easier interface. But we'll basically allow a group of users to control an interchain account on another chain. And then we have the last one, which is many to one. So basically this is what we said before, that we have a module that we're building, and our users can interact with the module on our chain, and if necessary, our chain can trigger an interchain account transaction on another chain. But as we said here, we're investigating if we can kind of have for each of these templates, if we can have some kind of a standard controller, which would actually limit the amount of development work that developers have to do to create their own custom authentication modules. And if we manage to do that, then yeah, probably we will have a lot more interchain accounts functionality out there in the wild. And I think I also believe that this is one of the challenges in the Juno track, which is basically to make sure that a CosmWasm contract, which would be a module on the chain, is able to be like a standard for interchain accounts functionality. All right, and this sets us up for the second part of the demo. So let's go back. So first, before we start, a little summary of what we did. So the first thing we did, we transferred some tokens from the Seoul chain to the HackATOM chain. And right now I'm going to use the namings controller and host. So Seoul is our host and HackATOM is the controller. And like we said, what we wanted to do is that we want to do some transaction that will delegate some stake to the host, or to a validator rather, on the host chain without leaving the interface of the controller chain. So specifically for interchain accounts, we have this situation. So our demo repo, which is actually a fork of the interchain accounts demo. So you can check this out as well. It's actually pretty similar. I just changed some names. And here actually the Golang relayer doesn't really work yet. So it's better to like use the HackATOM demo repo. Where were we? Yes, right here. So essentially, this implements also the authentication module. And if you take a look at the code, if you are familiar with Cosmos SDK development, our modules are in the X folder. And here, intertx is essentially the authentication module that we built for the demo repo. But once again, this is the quite simple implementation where we just expose the methods to the end user via the CLI. All right, so this is what I forgot the first time, so let's do this immediately. We're going to start the Hermes relayer. All right, so our relayer is set up. So when we think of IBC, what do we already have? We had our client set up, we had our connection set up. We also had a channel, but that was an ICS-20 channel. So remember I said that for each application, we need a different channel. So we don't really have a channel yet. But for interchain accounts, it's a little bit different because each interchain account that we create on the host chain will actually require a separate channel. And that's actually one of the reasons that initially we didn't think it would be a good idea to give every single user on the controller chain a separate interchain account on the host chain, because that could lead to like a lot of channels, which could be an issue for relayers, but hasn't been like tried. Maybe it's not that big of an issue. But the important thing to realize is that first we need to register our interchain account, and this will be with this command. So this is a section registering interchain account. And registering the interchain account is something that we want to do on the controller chain. So essentially what we want to do is we want to stay on the controller chain. So let's go over, copy the command, and let's take a quick look. So we see intertx, which is our authentication module. This is what we're going to interact with. We have the register command, and then we have the different flags that we have to fill in. You can take a look at that in more detail later. But let's see. So we have submitted this transaction, and then we see when we go to the relayer tab that a lot of things are happening. And let's take a look. So we see channel handshake step completed. And indeed, this has been performed on the connection 0, which is exactly what we want. And here we can see, for example, that the port is ICA controller, and then we have the address of the interchain account. So in ICS20 for token transfer, we basically have a symmetrical situation where the port will be the same transfer on each of the counterparties. For interchain accounts, it's a little bit different. So for interchain accounts, we have ICA controller dash and then the interchain account address as the port ID on the controller chain. And then on the host chain, we have the port ICA host without any added information. All right. So let's go back. So we have now hopefully created the interchain account. We're going to see by querying. So back on the controller chain, we're going to query interchain accounts. So this is just a regular query that looks at the interchain accounts that are present. And then we see indeed here interchain account address, which is this one. So that should work. And now, ultimately, our end goal is to use this interchain account to submit a staking delegation transaction. But of course, this is going to cost some funds, some gas. And this is actually the next step that we need to do, is essentially to fund the interchain account, and then we can go ahead and send our transaction. This step is just to make our lives a little bit easier, and we're going to export the ICA account address. So let's just do this in the 2 terminal tabs, just for safety. All right, so we've done this. As I said, next step is funding the interchain account wallet. We can just check. So if we check on the host chain, which is where the interchain account is located, oops, we're going to check for the balance of the interchain account address. This should be 0 because we just created it. And in fact, we see that there is no balance yet. And then we have 2 ways of funding this interchain account. One way, which is just a regular bank send on the host chain. This is what the original interchain accounts demo uses, but I thought it would be more interesting to use actually interchain token transfers. So essentially what we're trying to do here is, for example, if you had the native token of the host chain already available on the controller chain. So for example, this could be that you go to Osmosis and you make a swap, and you actually have the native token from the Soul chain without actually ever interacting with the Soul chain. And you have this. We could take another look at the balance. Let's see if we have one here. I think it was this one. So again, just a little reminder, the balance of our demo wallet on the controller chain is essentially these 11,000 and the IBC voucher. And what we're going to do next is we're just going to send a part of that to the interchain account address via an ICS20 transaction, and then we can use our funded interchain account. All right, here we were. So this is our command for the IBC transfer. Again, we are on the controller chain. So IBC transfer, transfer, channel 0. We have the interchain account address, that is the recipient, and we're going to send over 9,000 of our 11,000 funds. And then we just have the regular flags. Let's take a look if our relayer is running, and yes, it is. So if we perform this, we can take a look. Yeah, something seems to be happening. Always takes a while, but it doesn't actually take that long, so we should be fine. And if we check now again for the balance of the interchain account address, it should be funded, and indeed it is. And we see that we have our original denom back, which is just a native stake, and we have 9,000 of this. So, okay, this is now our situation. So we have the controller chain, host chain, we have our interchain account that has some funds attached to it. And the next step is going to be that we want to stake some of these funds to one particular validator. And this is the next part. So here we see that we can send interchain accounts transactions using the intertx, which is our authentication module, and then submit. And yeah, we have the example of a staking delegation. So this command first is just to find a validator address on chain, on the host chain, on Seoul chain. So here we have the validator address. And then this is actually the interchain account transaction. And so basically what we submit here, as you can see, is the transaction data. So this is what is going to be inside the packet, and then on the host chain, this packet is going to be decoded, and we can simply submit this transaction on the host chain. So let's copy this. And let's go to the terminal again. So again, still on the controller chain, haven't left this interface. And we can submit this. Let's check again. Relay is still running, so that's fine. And let's submit this. We see that something is happening. All right. So this should have worked, and now we should have some stake delegated to this particular validator. And by the way, there's also an alternative way to do this. If you don't want to add this to the command line interface, we can also have a path to a JSON file that essentially includes the same information. Yeah, it tells us to wait until the relayer has relayed the packet, and then we can check with the query of the staking delegations for the validator address. So this is going to be on the host chain. Oh, and by the way, I should mention that we staked 3,000 stake. And here we see this. So this huge amount of stake is essentially created in the Genesis transaction. And then here we see the 3,000, which we have just delegated ourselves. All right. So yeah, this is the end situation where we effectively delegated some stake from the controller chain without leaving this interface to the host chain. So let's do a little recap of what we did until now. So we first sent over some tokens from the Seoul chain to the HackATOM chain. Basically, this is a step we do in the demo, but ideally, the scenario is that you don't actually have to interact with the host chain. You simply interact with the controller chain, which is what we did. So again, if you want interchain accounts, first you need to register your interchain account, and then you can use the transactions. Those are basically the two functionalities. And the next thing that we will have in the demo is a timeout scenario, but let's first go back to the presentation and talk a little bit about this. So remember that earlier in the presentation I gave you this packet flow for the happy case, but of course not all cases are happy, and sometimes we have something that happens, and here we see that the relayer, for some reason or another, maybe they were online, maybe something else happened, but for some reason they did not pick up the packet, and so when we don't pick up the packet, obviously we don't want our packet, especially when there are funds attached to it, we don't want our tokens, for example, to be locked up indefinitely. So that's why we have some kind of a timeout functionality. And what we see here is the query non-receipt. So the cool thing about IBC is that we cannot simply query to see if we had a receipt of our packet, of our token, but we can also query for non-receipt. So if the timeout period has passed, we can use this query non-receipt, and if that comes out positively, then we can submit on the source chain a timeout packet command or message, and then yeah, some application logic can be used to revert the original send packet logic that was executed. So for example, when we have token transfer, that would just mean that the locked tokens are being unescrowed again, and you can use them again, maybe like send another transaction, or just keep them on your account on the source chain. But yeah, this is basically the timeout functionality. And something that is important to note for interchain accounts specifically is that interchain accounts have ordered channels. And the case is in an ordered channel, if we have a timeout, basically that means that a packet got lost, and because we have ordered channels and every packet needs to arrive in order, this will lead to problems, and this is why in ordered channels, if we have a timeout, the channel is closed automatically. And so this is another situation that we're going to look at in the demo. So here we are. So we are going to test the timeout scenario, so this will require some coordination on our part, because as of right now, my relayer is still running. So to make sure that we can test this timeout functionality, it's important that we shut off the relayer for a bit. So now, essentially, we don't have another relayer running. So if I were to send a packet, this packet will not be picked up. And the channel that we have created will be closing. So here it says, first step, stop the Hermes relayer, as we did. We should wait for approximately 1 minute, because the timeout period has been set to 1 minute here. Oh yeah, and in the first step it also said to send another staking delegation transaction. So let's do this. This is this command again. So back on the controller chain. So we said 3,000. That's not enough delegation. We actually want to make it 6,000. So we're going to try this. But obviously our relayer is not running, so it cannot be picked up. Let's see, let's wait 1 minute. And so while we're waiting, I'm already going to go through the next steps. The next steps, after we've waited enough, more than 1 minute, is to start up the relayer again. And when we see this, we will observe that the relayer is taking care of the unrelayed packets. So when you start up the Hermes relayer, it will look if there's any unrelayed packets that it needs to take care of. It's not just going to start listening to packets, but forget about those that it didn't pick up. All right, so I think that should be fine. Let's wait 30 more seconds. And the next things that we're going to do is we're going to check if indeed our channel state has gone to closed, as you can see here. So obviously if our program works correctly, or if the IBC protocol works correctly, this is an ordered channel with interchain accounts, and so it should be closed. All right, I think we waited long enough. So here we go. Let's start up the relayer again. And here we go. So yeah, you'll have to learn a little bit how to read these debugging tools. But here we see, or the logging tools rather. Here we see they extracted a timeout packet event. So indeed, when starting up the relayer, it looked for the packets, saw that the timeout period had passed, and yeah, they submitted a timeout to the original chain. All right. And so the next step, as we said, was to check if our channels had been closed. Now, remember, at first we did this actually with the relayer software, but we can also just do this with the chain binary. So let's check it first on the controller chain. So we're going to query the IBC channels, and let's take a look. So we have our channel ID, channel 0. Remember, we also made a interchain token transfer channel, so this is actually the channel 0. This should still be open. So even if we had sent another token transfer transaction, this channel would not have closed because token transfer channels are unordered, so it doesn't really matter if there's a timeout from a packet, everything can still go on. So this was our channel 0, and then we should also have a channel 1. There it is, it's on top. The channel 1, and this one says indeed that it is closed. All right, so the IBC protocol did its job. And yeah, we're also going to look on the counterparty chain. There we go. So here we see the same thing, channel ID, channel 1 is closed, and channel 0 should still be open. There we go. All right, but of course, if your channel has been closed, that doesn't mean that you can't use interchain accounts, transactions anymore. So next step would just be to register another interchain account. So again, on the controller chain, we have this command, intertx register, and we're simply going to create a new interchain account, which will use a new channel. All right, yeah. So the relayer was still running. And so if we go back to the previous command, so again, we're going to query the channels. So now we see we have channel 0, we have channel 1, the ordering is a bit off, and then we have this new channel, channel 2, which is our, here we go, port ID is ICA controller, and then the interchain account. Address, and then we see counterparty ICA host, so this is clearly ICA host, ICA controller, and then the address, whereas, as I said before, for channel 0, token transfer is just port ID transfer, and counterparty port ID is also transfer. All right, and I think, yeah, we're not going to send another transaction, but actually we could, just to check if everything goes as planned. Right. So now we do have our relay running, and we're going to try again to send an additional 3000 delegation to our validator. All right, seems to have picked up the packet. And then we can check again the staking delegations, and now we have 6,000. All right, so this worked. And I think that's it for the demo. I think we still have some time, so what I'm going to do is I'm going to maybe take a look at the Hermes help command. So yeah, essentially I was explaining that it's probably a good idea to play a little bit with these commands, use the help. So for example, say I want to create something, I can do Hermes create and then help. Say we want to create a new connection. right? And so there we then see Hermes create connection, we have some options, and we need to make sure that we have as a arguments the chain AID and the chain BID. And so for each of the different things, you will find some some explanation here and all of the arguments, all the flags that you need or that are optional. So essentially this is what you could be doing. Some other sources maybe to go through. Okay, this was the demo. So again, the documentation from IBC. So if you want to write your own custom IBC applications, this is where you go. First you have an overview. Let's see if this loads. Yes, there we go. So this is a high-level overview, essentially what we did today. So we have applications, as I said, middleware. So this could also be an important thing. If we have some functionality that doesn't really go in IBC core, we could use this as middleware and basically reuse it for different applications. So we could actually build an entire middleware stack. I don't think the picture has been added, but I should have it here. Yeah, so basically what we see here is that we have the base application and then we can have middleware 1, middleware 2, but essentially we can keep on stacking the middleware and create functionality that way. And so here we have then on top core IBC. And so, for example, the messages, packet and write ACK are going from base application to core IBC. And when we have handshake setups, ACKs and timeouts, the communication actually goes from core IBC through all of the middleware to the base application. And so what you can see here is that the order matters. So if you have a particular order on one chain, for example, make sure that the order is the same on the counterparty chain. All right, what else do we have? Upgrades. So this is also an important aspect. So because we have the entire ecosystem or the interchain, which all have IBC, if we want to upgrade both our chain or the IBC version, this is not something that you can just do because we have our light clients that are depending on the information that you have. And so if you perform an upgrade, you might want to plan this and make sure that the relayers can send the appropriate messages to make this a coordinated upgrade so that we can keep our light clients and basically can keep the channels functioning. We also have governance proposals. So for example, if a light client could get frozen, this could be because there was some misbehavior, or it could be because there was not enough activity. So basically, the light client that we have on chain for another chain, it needs to be updated with some information. And so if there's not a lot of activity between a channel, between two chains, we don't really get that update client information. And so usually what relayers do is they make sure that periodically, even if there is no activity, they're going to send an update client message just so that everything keeps running. We also have a trusting period, and if it so happens for any reason that the relayer is not updating the client for longer than the trusting period, the light client could get frozen. And then we have governance proposals to unfreeze the light client. Relayer doesn't really have that much information. It's actually better to go to the Hermes documentation or to the GitHub repo of the Golang relayer. Then we also have a section for the IBC application modules, interchain accounts, interchain transfer, token transfer. We have fee middleware. This is a new thing. So we haven't seen a lot of implementation with that, but you could go ahead and familiarize yourself with it. And then also migrations for going to a different IBC version. And then we also have the Cosmos developer portal, which we talked about already. So there you have some tutorials, some articles, but mainly we here have the Cosmos Academy. So if we take a look, all right. So here we see a general introduction to Cosmos, main concepts, running your own Cosmos chain. So I think here basically, yeah, you work with Ignite CLI, and you're basically going to create your own chain. The example that is here being used is a checkers blockchain, so you can play the game of checkers, but hosted on a blockchain. And then here, if you're only interested in IBC, we have also a section on IBC. So we have the overview, general introduction to IBC, what is it? And then we have the different aspects or the different abstraction layers of the transport layer. So we have clients, connections, channels again. Also some applications, so fungible token transfer, interchain accounts, relaying. So if you need some more background information on relaying, you can also find it here. So first we have some general information, then the Go relayer. Maybe if you go to this today, like I said in the introduction, there have been some upgrades for the Go relayer, so and also actually for the Hermes relayer, so we're going to have to review this information. But yeah, in general, the information also about the config file and what you need to add is there. And then last we have some IBC tooling. So map of zones is an interesting one. Basically you have this nice overview here of all the chains that are being connected, which is kind of nice. The next one is MinScan. So we have MinScan also now with the nice visualization of all of the chains that are connected and all of the IBC transactions that are happening. So yeah, MinScan, map of zones are good sources to find some information about IBC in particular, but also about regular transactions. And then we also have IOB scan. IOB scan is still in development, but it has improved quite a bit already. And so this is one that is really like focused also on IBC. I do see that this link is not working. We should look into that. So that's the IBC information in the Cosmos Academy. Like I mentioned before, the same topics will be in the Interchain Developer Academy. If you wish to apply to that, there's still time to apply for the September cohort. So this is the Hermes documentation, which we already went through. This is the HackATOM path. All right, and then a few more words on what to do next. So, as I already mentioned, if you're interested to learn further about IBC or the bigger Cosmos stack, go to the Cosmos Developer Portal, maybe sign up for the Interchain Developer Academy. Basically, the advantage of the Interchain Developer Academy is that you are guided and you also have like some exams, some quizzes. So if you need some accountability to, for your learning, then this might be a good option. You do need like some time, I think it's like 10 hours per week for 6 weeks long that we ask for people to spend on this. Another thing that you could be doing based on the demo of today is to build some custom authentication modules. So what it could be either the standard based on these templates. So for either of these sections is something you could be doing. You could build your custom IBC application. So again, in the documentation, you should find all of the necessary steps, and then you can add your custom logic. Also, two other things, interchain security will be really, really nice, and there's actually a workshop today. I'm not sure if it's still at 2 p.m., could be a bit later, but it's by Dan from Informal. Also, interchain CosmWasm contracts. I think also the next talk, next workshop will be about IBC contracts. And there's still a lot to do in the Cosmos ecosystem. So yeah, I think if you want to develop, that you'll have no shortage of tracks to go. And I think that's the end of the presentation. Yeah, there's some time for questions. First and foremost, thank you for your attention. And yeah, good luck in the hackathon, and hope you build great things. Thank you. Are there any questions? Yes? Sorry? Yes, I do think there's some ideas for some pruning later, but I don't think we do that right now. Someone else? Yes?
Is middleware on the packet level, or is it on the higher level message?
Middleware is more on the application level, yeah. So, so essentially, this is also maybe interesting. In middleware, we could also like manipulate, for example, the packet data. So some examples that have been talked about are like, some filtering. Maybe like manipulating the packet data in middleware is a little less interesting. But yeah, like I said, if you have an application for it, there's a lot of freedom to use it whichever way you want. Yeah, you had another question? So even in unordered channels, we have like a sequence number, but it means that the sequence numbers don't have to like arrive in sequence. So there's still a sequence number. I'm not actually sure what it's being used for, but yeah, in ordered channels, it's basically the packets have to arrive in a certain order, and if that's not the case, then we time out the channel. There's also work on partially ordered channels, but that will probably be for Q4 of this year or later. Sure. Feel free.
Sorry, I just want to answer that a little more. I'm giving the next talk, and it's a very good question. Sorry. Unordered channels are basically like UDP. The packets arrive, and you're only guaranteed timeout or arrival. Ordered channels are like TCP, you're guaranteed in order, right? That's really kind of the equivalent there. The one key point this is, in an unordered channel, any packet could time out, right? So you do 5 packets. Number 1 is relayed, then number 4, then number 2, and then 5 and 3 never deliver, they're timed out. Then 6 comes later, doesn't matter. With you don't have any guarantees if you send multiple packets at once. If you have an ordered channel, you're guaranteed if you send 1, 2, 3, 1, 2, 3 will arrive. If there's any of them times out, the channel gets closed. It's actually pretty strict, meaning it's impossible for a relayer to trick you and, okay, I'll just like drop one of those packets and run the other ones. So you have guarantee, you can send 3 or 4 packets in a row and you guarantee them arrive in that same order. And it's very important for that. It's a little more fragile, it's very, very strict.
Thank you. Any more questions? All right. If not, I just want to say that I'll be here the rest of the day, so if you're interested in following the interoperability track, feel free to reach out to me and we'll look at your question, even if it's about the documentation or about the specific workshop. And once again, thank you everyone, and yeah, have a great rest of the day. Thank you.
Hello. I'm Ethan Fry. I'm the creator of CosmWasm, and I was also writing the IBC white paper in 2017. And these are two things I'm really, really excited about. So yeah, I've been hot on IBC since 2016, and I've been hot about CosmWasm since I wrote it 3 years ago. And these are amazing. Today, I'm showing you how to bring them together. We have multiple mainnets. There's almost 20 mainnets, I think 20 mainnets now running CosmWasm and IBC together. And we can start really connecting contract calls between multiple blockchains. This is an alternate way of writing Go modules. You can argue which is better, but CosmWasm contracts are by far faster to deploy them. You can write and deploy both sides of a contract, deploy it to one chain, the other chain, and immediately have a new protocol running cross-chain in a matter of minutes. The deployment speed is incredibly fast, and you do not have to wait for another blockchain, 2 blockchains, to do hard forks. So I'm going to show you how you can do that today in this hackathon, but also those techniques can be used to add things, making Juno osmosis connections in a matter of, write it and deploy it within a week or 2. So I think this will allow a whole new era of IBC experimentation. And those experiments that become very successful may eventually port it into Go modules and reach all those non-CosmWasm chains. But I want to show you how to make this. To start, I recommend this GitHub check, CosmWasm resources on GitHub. You can follow along. All the links I'll be showing at this talk, almost all of them are on that page. So you can follow along locally. You can check the code out. I'm cool if you're looking at your machine, not me. So yeah, please check this out. The main point here is we talk about the beginning is how to use a CosmWasm Academy, the docs for it, the book for CosmWasm. These are great resources to learn in general for CosmWasm. And yeah, if you're interested in the CosmWasm Academy, please come by our booth over there and learn out more. We have a large series of videos there. You should be able to access them. 6 videos to learn Rust, learn CosmWasm in Rust, and get going. So they're available for everyone starting today or yesterday. We opened them up. So they're really for this hackathon to help you all learn CosmWasm as fast as possible. Now jumping to IBC. I want to explain a little IBC. So thank you very much for that last talk. It was amazing. I was wondering how I could explain IBC in the beginning intro, and you did an amazing job. So thank you very much. Thank you for that talk. I'm just going to do a brief recap of some key points in that talk, and then show how you can deploy them into making an IBC contract. How the interfaces are for writing an IBC contract in Rust and how that works, design-wise. Then we're going to look at simple code to see the interfaces. That should be the first hour of this talk. The second hour, I go into a real use case. The real use case, I wrote basically interchain accounts as 2 contracts. You can deploy a host and controller on 2 CosmWasm-enabled chains. It's basically the same design as I have there, a slightly older version of interchain accounts. I wrote this thing in January 2021. So I just refreshed it the last 2 weeks and updated it. But it's not just the 2 contracts you have, it's showing you how to do full stack integration tests. So it's going to launch multiple blockchains locally in the CI environment, and it will run node tests to quickly create channels, create connections, move packets, verify packets, and execute CosmWasm contracts in CosmJS and TS Relayer. So this is really, really powerful, so you don't have to test those command line tools. I've written bash scripts for testing. It's painful, and parsing JSON in bash and forming JSON in bash is not fun. So we can use Node.js and TypeScript to create really powerful testing environments and use all that tooling to really leverage that to do cross-chain tests of your contract, to quickly deploy contract to 2 local chains, connect them, run packets back and forth, and verify that it did the proper state changes. So I think this is really going to revolutionize the act of writing and testing, especially IBC contracts, and give you a factor of 10 speed up possibly from the current way of doing it. So I want to introduce that today, share it with you, and hope someone can build something in this hackathon and beyond. So if you look at this, this is from the IBC spec. Basically, this is a recap of what I was talking about earlier. You have a client and a connection between 2 blockchains. Let's just use Juno Osmosis. I use them because they're 2 major chains in the Cosmos ecosystem running CosmWasm. So you can deploy to those 2. The hub is the largest one, but it's not using CosmWasm. So I'll just look at the other 2, number 2 and number 3 in the ecosystem. So yeah, imagine you have Juno on the left and Osmosis on the right. You make one connection between them, And on top of that, you can connect many other things. There's already a connection there. And you will then make like a port here. To connect this one is transfer to transfer. So you have the transfer port, you connect it with ICS-20 to make a protocol moving money back and forth. In the meantime, different contracts can have different ports as well. And other contracts here have ports, and you can connect those. So you connect those things between these different contracts, the different ones, and you have multiple channels running one connection. Once you establish a connection, which is a light header proof, you just have quick channels. So look at the life cycle here. A channel basically, and this is where the contracts come in. If you upload an IBC-enabled contract, when you create your contract, it will automatically reserve a special port for you. The port name is wasm.your address of the contract, so it has its own unique port name. And once you have that port name, you get in the beginning. Then you make new channels, so people connect you. You connect a contract to another contract. And this is the state. Basically, there's channel initialized and channel open try, which are the first call on A, the first call on B. Then there's open ACK and open confirm, which is the second call on A and B when they agree. So the first two are really to verify they're the same version, they actually know what they're talking about. I'm not trying to connect ICS-20 to Interchain accounts and they go, who are you? So the first two, this first step and the second step here, are really to verify the other one is talking the same language as you, the same protocol, and you're compatible. You do that version negotiation. And once you've both said, yeah, you're good, we like it, then with the second stage here, to confirm it and store any state changes, oh, it's really a connection established, I'm going to store the state change here locally and do any initialization I want for that connect channel. So we expose this to the contracts as two different calls. They have one call which combines these two, the first attempt, and one call combining these two. These are basically the same, just the A and B versions of those. So we expose those as different calls to the contract, and we also expose the close. When you close at the end, there's another call. So there's three calls to the contract, which is start open, confirm open, and eventually, possibly or never, close, which are channel life cycles. We expose those to the contracts. If you have an IBC-enabled contract, you must expose 3 handlers for these things. They can be do-nothing handlers, but they must exist. The other part that happens is the packet lifecycle. Once you've established a channel, you move packets back and forth, as you saw in the relayer demo of moving data back and forth over the channel. This whole app here is send packet, query packet, receive packet. You see this whole process here. You also have a few callbacks to contract in this lifecycle. We use all of the standard IBC Go libraries, the client library, connection, channel, port, all the infrastructure has been heavily tested, built. It's amazing infrastructure, and we build on top of that. We don't replace it, we build on top of that. So we just give a few hooks it gives us for calling on the channel lifecycle, starting, confirm, end. And once a channel exists, we have a few more hooks. Once a packet is received, we have a separate message here. So if you have an IBC-enabled contract, you can do send packet, which allows you to send a packet, a new packet, any format you want. It's a new message format, Cosmos message IBC send packet, which will send a packet on a channel that belongs to your contract, right? Only your own channels. You have one port, so any of those channels that belong to your port, you can send a packet on it. The other side will receive a on-receive packet callback. That callback gets the packet on the other side and returns acknowledgement or an error. There's yes or error as you want. So that's side B will get that. So side A will call send packet. Side B will eventually get this callback, the receive packet callback. And then call app A will get this on acknowledge. So it will get an ACK containing the original packet it sent along with the data that came back from side B. Usually if you send packet, you should expect acknowledge packet. However, sometimes it does not get relayed. Maybe the chain goes down. Maybe the relayers go down. Maybe gas fees are too high. The packet never gets there. So there's a timeout, they mentioned, and the timeout packet will get called. So you're guaranteed to eventually get something back. Either you get an acknowledge packet containing a success or error message in whatever local format you design, or it never happens, it never gets over there, so you get a timeout message. So there's 3 more hooks we expose to the contracts, which are on receive packet, on acknowledge packet, and on timeout packet. which we'll send to the contract. So when a contract makes a new channel on its port, all those packets on that channel will trigger callbacks on that contract. Do you understand this? Am I speaking too fast? Please, speak slower. So those are those callbacks. You can look here. Another thing, this is in the resources directory. This is linked there also. You can type it in now. And CosmWasm resources has a link. This is a spec in CosmWasm of how to build IBC contracts. It's maybe not a good introduction, but it's a very good reference. It explains all these pieces. So I explain how you can send a transfer message using ICS-20. We built in as a native call. And we explain how to write new protocols. This explains the channel lifecycle of open and the interfaces for it, the channel connect interfaces, and the packet lifecycle with these callbacks I mentioned. So this is a reference here explaining what I just talked about in a little more depth. So I highly recommend this repo. This thing is linked also in resources. You can refer to this if you don't remember what I said, if you want to read a bit more and see those code of what interfaces are needed for a new contract. So that's basically what you need to know as theory. I'm now going to start looking at a contract. This contract is a nice one, not mine. It's a nice guy from Juno wrote this, Zeke. And I was writing one, he shared this thing, and that's awesome. It's a really, really simple contract, which is why I like it. It's Mint, so you just, yeah, it's not a multi-repo, nothing complex. It's the simplest CosmWasm contract that is IBC to learn from. So this is a great starting point. If you've ever used CosmWasm, there's a CW template we have, which generates a simple app, which basically is a counter. You have messages to like update a number, what the number is, update it, what number is. I mean, it's a pretty simple app, but it gives you a framework of building more complex apps. This is the same thing in the IBC world. So you can look up this repo here. It's Ezekiel CW IBC example. I believe I've linked that also on the resources page. So you can see it here. This one here, simple example contract. That's where we're at right now. If you're following along, I just did a quick run through theory because it was covered in the last show. If you're watching at home and missed this first part, look back an hour and a half. It was an amazing talk. Beyond the IBC contracts, we're right here now, if you're following along. So this is a simple example contract I want to show you. This one basically, you create the same contract in two sides, and then you call increment on one side, and it will create a packet. And that packet will go to the other side. And then you can query them. So you have two direct contract calls. One calls increment, and the other is get count. But increment does not increment that contract, it increments its partner contract. Yes? So when you call increment, it will send a message to the other side, and the other side will go up. So I can create two contracts. I tell A, increment. It sends a message to B, increment. It gets a message. It says, OK, I'll raise my number by 1, and say, OK, I'm done. And then over here, the number should go up. So it's a very simple example. It's not very useful in the real world, but it helps you understand the basics. So it explains a bit here about introduction here, the init, and the handling messages. So again, this is a nice repo. If you want a simple example, I'll cover it. You can refer to this as a very simple example of an IBC contract. It's the smallest possible one I've seen. And inside of it, you can look at the entry points. So I'm going to start here to kind of make a not very scary version of using IBC contract, right? So it's just a few things. You have this funny line here. Just copy it everywhere. Entry point means we expose it in the WASM blob. And this CFG after not feature library means if I import that contract from another contract, I don't make an entry point. Entry points means actually the WASM that's compiled with it will expose this as a command that the VM can call. But you can't do it twice. So if I have an IBC contract import another IBC contract, and they both try to make entry points, they'll make two entry points with the same name. It conflicts, doesn't compile. So we have this library feature thing that turns it off, basically. So you don't really know this. Just remember, put this line above all those calls. Just copy that line. We use it everywhere in libraries. Just copy that line. It means make it an entry point. Expose this one, please. You must use the exact same function signatures here. And if it doesn't, again, the compiler will give you some error. It might be a little opaque error saying does not match, something does not match something. But basically, you have to use the exact same definitions for it to work. Yeah, so here's the deal. IBC channel open. What it does is we say opening it. And the relayer first is we're going to open it. It calls side A. Open with this version. And it verifies the version is proper. Right? Let's see if the version is OK. And the ordering is OK. Are you ordered or unordered? What the version of this protocol we're using? That's the first step. And then after you do that A, then we call this on B. OK, is the version right? Very good. After that is done, then A, it calls IBC channel connect. That can again validate the ordered versioning. Because if A starts a version, B gets another one, it returns a different version, it can negotiate versioning, and it comes back with a different version back to A. So you want to double check again here to make sure that B is not changing the version, right? I say I want ICS 20-1. This one says, no, I want ICS 20-2, that's newer. And it comes back here and you say, oh yeah, okay, that's cool, I can use ICS 22, or no, I can't. So you want to double check that also in the, on the third step. So these validate order and versioning is a very nice thing to check. We do a lot. And then after that, you can save the state, because now you're basically guaranteed both sides agree the channel is valid, we can use this channel, it makes sense to you, we know what we're talking about. We're using the same IBC functionality, we're counter 1, we're talking to something we know. So we have the same protocol, this is a handshake for the protocol, which API we're using, and then you basically here it saves some information of the connection, the channel and the number of connections. So then on close, whatever happens, what it does here just deletes the channel from store, which is simple cleanup. But every application needs to do when you destroy that thing, you can do some tear down logic at that point. So these are just hooks you can use. They're usually pretty simple stuff. That's basically, check the order versioning and set a little initial state for this channel. It's simple stuff. These are your hooks. The more complex stuff happens in the packet lifecycle. This is really where you combine execute and query locally as remote functions. So you can see the IBC packet receive is what happens. We sent a packet and it gets a packet. So you parse it. And actually this code is based a bit older of my stuff. So you don't need these two functions to do it. Anyway, I'll explain later. The newer version, but basically you have this, you get the message back here, you parse the data, and then you can match on it. If you just CosmWasm, this is just like how you do for execute messages, right? So I received a message on my channel, some message on this channel, I know what channel it comes from, and then I can parse this message into an IBC execute message, and then see, okay, what is it? Oh, it's execute, great. If it's something else I don't know, then I return an error. But that shouldn't happen because we agreed on the protocol already, so they should have the same protocol. So we have this, and you're talking to a known party on the other side. Anyway, you have this is where you parse the data and dispatch them on IBC receive. And you see here, basically it just does this same thing. It says, okay, increase the number by 1. This is update number and make it 1 bigger. Unwrap or default by 1. So that's pretty simple, right? If I receive a packet, it says, I parse it, and it says, okay, increase number by 1. That's very simple. And it can return some data. So what it does, it returns, when you create the response there, you need to return an acknowledgement packet. And this one has basically make act success. It's an empty packet saying everything is good. And if it fails, there's a packet here saying everything is bad. So you define the shape of acknowledgement packet on your code. The same way that you define in CosmWasm like a query message and a query response, you can define an execute message, a packet type, and a acknowledgement or response type. It's an enum in this case, if you need it. So here we have, so this is called here on receiving a message. This is when it happens. When it's finished, it gives an acknowledgement that comes back, and it calls on IBC packet ACK, which does nothing with it right now. This knows it could parse this if it wanted to, and determine whether it failed to exceed the other side, right? It could actually, it knows the original packet it sent here in this message, and it also knows if it failed or succeeded. So you have this information available to you, and you could do something, in this simple example does nothing, but it's a placeholder for you to add. And on timeout, you also know that the package never got anywhere, and usually you want to handle timeout and fail the same. So if I get an acknowledgement of a fail and a timeout, I usually treat them the same way. It's garbage, nothing happened. And success is a different way. But some protocols want to care about all three different cases, so you have all three exposed to you. You can decide what to do with it. These are all the entry points you need to write an IBC contract. It's not scary, is it? It's just, we've looked at like 100 lines of Rust code. Most of it comments and function definitions. But yeah, that's all it is. This contract, when compiled and uploaded to Juno, will immediately make a port. It'll bind a port. It'll make a new address and bind a port. And if you deploy another version of Osmosis, it'll bind another port. If you create a channel with the right version, if you make a channel with counter 1 as a version, and what valid, it needs unordered. So it needs unordered channel, and it needs a version of counter 1. If you try to connect to the wrong version, it says, can't make a channel. If you try to connect to the right version, it'll say, great, make a channel. And then you can call increment here, the number goes up on the other side. Any questions on that one so far? There's one more piece here to this repo. So the IBC directory here, there's the contract. So how do you actually create that first packet? We talked about how to receive the packet, but how do you create the packet? So execute, if you call increment, this is a really small function. So when I call increment on the first, not the message, but like the normal execute. So when you call a contract, you just call it directly as in transaction. Say call this contract and give an increment thing. It will make this message call. If you know CosmWasm, it makes sense. If not, maybe not so much. But basically it says, do an IBC message send packet. Given a channel I own, it sends this message here, right? Which is the increment message you saw parsed on the other side. So we can use any message you want there. And this is basically what we're executing on the remote side, the packet we send to the remote side, the data value. And this is a timeout. This one says timeout in 5 minutes. So if the relayer is not running, you forgot to run a relayer on the channel, and no relayer moves it, 5 minutes later you can time it out, and you can say, hey, it's dead. You start your relayer, oh, I forgot, I'm late. 20 minutes later you start your relayer, it'll time out this packet, and it never happens. So you know it timed out. So you can set the timeout you want here, you set the message you send to the other side, and the channel you send on. So you have to send a channel you've already created yourself. And you can check that if you want here. You could actually assert that channel is a connection I know, not some arbitrary channel. It doesn't really matter, because if you try to send a channel that you do not own or does not exist, you'll get error anyway. So you can check it locally or just send the message and see if you can error on it. The whole IBC runtime will check all this stuff for you. And query, the rest of the thing is, so once I've called increment on side A, it creates that send packet. That send packet is relayed over to chain B. Chain B then processes that number and increments the number 1, right? And so returns an acknowledgement. How do I know it happened? Then I go into chain B and I query count. I do the get count call and I get a response with the number that happened. So I can see it. So I can call a message here. When the relay finishes, I check on chain B, the number did go up. I know it worked. So right here is the entire lifecycle. In a little bit of code, check that repo out, read it. It's a very simple CosmWasm contract. A lot of the stuff that looks like scary stuff is really just boilerplate. I mean, you have these function arguments, they're all the same arguments. It's just a set of arguments here, right? Like all those lines are the same thing. And it says, okay, this is a whole logic in the function, which is just put some log messages on it, emit some events in Ethereum terms, emit these events, and send a packet. I mean, that there is 8 lines to send a packet. It's not hard at all. So once you learn the CosmWasm framework, this is not a very complex contract, but suddenly it's a cross-chain contract. The hard part really is designing the protocols. So I'm trying to show you that the interfaces are pretty simple. There's references, you can look at examples to learn them. It takes time to learn them. You don't know them. But once you see them and play with them a little bit, they're not that complex. The hard part is designing them properly. The protocol design. So before you write this one, you can draw a piece of paper. I have two sides. I send a message here, here. What messages can I send over here? What happens, right? This one is a very simple message. All it does is change a number. But if you're changing state, if you're locking up ICS 20, you lock up tokens here, then you send them over here. This will release the token over here, right? If it sends it back, the same token in the same channel, then it can release this original token. If it's a different channel with the same token, then it reject it, right? That logic here. If the transfer gets a failure message back or times out, then it releases those tokens because it never went to the other channel, the other chain. So that's the logic of ICS 20. You can probably write it down on draw a picture of paper, one sheet of paper, and try to draw that down. It's very simple. They have one type of message, back and forth, and you can probably draw that one piece of paper. If you have a more complex one of locking tokens and doing complex stuff, it's a little more complex. But I think the protocol design really is what you think through, all the use cases, flow diagrams or protocol diagrams. And that's really the hard part in this IBC for me, is designing it, thinking what it should be. And once you have an image of how it works and know how it should work, writing that code should be as easy as possible. I want to make nothing as little as possible stand between your ideas and the code, and then the code and production in mainnet. We try to make that whole process as fast as possible, and the hard part becomes thinking of and designing the image in your head of what you want to create. That is hard. That is very hard. But the rest of it, we're trying to make it as easy as possible, and I cannot help you designing the protocol so much. I can review your protocol if you want. If you have an idea, I can review your protocol idea, but really, once you have an idea, you can write down your idea and show me your idea. I can sit here, I'll be here today and tomorrow. I can help you write it into code and help show you how to tips into writing the code and actually making it live. So yeah, that was nice. I thought I'd have much less time because I expected this to take an hour of a lot more explanation of IBC. So thank you again, and I have a little more time to actually dig into a deeper contract. Yes?
It's probably because I'm not too familiar with the terms in the ecosystem. Usually in the traditional, I would say, computer programming world, packets are the ones that form the message, which is meaningful only it is with the other packets. But why do we have to keep parsing the packets when we know that a single packet wouldn't mean a ton of things in the contract level, which is very expensive?
You're right. So packets here are not like a TCP packet or something. They're broken chunks. This packet is basically like JSON RPC call or REST call. You can imagine it like that. One packet represents basically, if you're used to JSON RPC or REST, anything, it basically includes first all the metadata, the header metadata that proves authorization, all that stuff, along with the payload, which is actually the message being called. And that whole authorization mechanism, so we call that a packet in this term. I didn't invent that word, but it's a packet. This pent along channel is basically one call. And all the metadata of channel, load client proof, all that stuff is handled for you behind the scenes. That's the header kind of stuff, the authorization. And the data of the packet, the data part of the packet is this message, this execute message increment. Is it just, we put the data, we set the data value of that, and the rest of it's handled by the framework. We don't touch it. So once you've established it, this is the metadata, and that data packet, you pass it there. And the response value also is header metadata, which is validated on this side. And the JSON data inside the response, or the HTTP response, is basically what we get as acknowledgement. So I think that's a better term, and hopefully that makes more sense, because yeah, packets are very low level. Does that make sense? Cool. So yeah, I really think it's basically JSON RCPC or REST, something like that, with HTTP headers as authorization. Cool. I have one more thing. So just before I go into coding and open up my editors, I'm going to show you this one, CosmWasm testnets. So you can check this repo out. We have 2 testnets live, Ibiza 808 and Malaga 420. We did a team retreat in Malaga, so we decided to make some testnets here. And we said, hey, 1 testnet is fun, but 2 is better because we can do IBC. These are not tied to any mainnet. They're not Juno or Osmosis or Cosmos, nothing. There's no mainnet. They're just 2 testnets run by us at Confio for all CosmWasm developers. They have nice faucets because no one really cares about these test tokens. They're worth nothing. So we have faucets. You can hit them with curl. We have nice definitions here. You can look inside. And basically, we define where it is, the RPC endpoints, the PDP endpoints if you want to run one, and some defaults that let you configure this up. So you can see where all the things come from, and you can see where the faucet is. And this is the faucet we have, which you can load from a curl command. You can get tokens in a curl command, and there's actually a CosmJS faucet client library that just give this URL and it'll get you money. Just give me money. Yeah. So our testnets are meant for CI, basically, and for scripts, so you can just automatically do it. TS relayer, if you can figure out the faucet URL, it will just, when it starts up, if I have no tokens, I hit the faucet to get money. So it'll self-feed itself from those faucets, which is great for testing. So you can actually test these testnets. TS relayer will fund itself. Don't worry about funding itself. Makes it easy. So yeah, you're welcome to deploy, and maybe you actually need to deploy on Osmosis or on Juno testnets for the winner. I'm not sure, but at least you can use these for early on starting. I think they're nice, simple ones. Yeah?
So we have the same in the counter. We have the same smart contract on two networks.
Yes.
So it's bidirectional, the increment. And outside of the example, is it unusual to have the exact same smart contract on two networks we want to do?
It's a possibility. So if you look at ICS 20, it's the same code on both sides. That's completely symmetric. The Go module, there's one Go module, which is IBC transfer. And that's the same on both sides. They both know I can take my local token and send over a voucher. I both know a remote token comes back to me, I mint something, or my remote token that I sent earlier comes back to me, and I then release it. So that logic is the same on both sides. It's symmetric. So token transfer is fully symmetric. ICA accounts, interchain accounts, has a control on a host side because A is controlling B. It's a unidirectional protocol. It's an asymmetric protocol. So both of them exist. Interchain security example, there's a controlling chain and there's a baby chain. The parent chain, the baby chain. I don't know what they're using these days as names, but they use it for a while. So one of them controls the other chain. It's very clearly asymmetric. And so other than a transfer in this example here are bidirectional. You can choose that. I'm going to go into a code example, which is asymmetric as well. It's based on interchain accounts. It was back in early, so when I wrote CosmWasm in a hackathon, that was in Berlin, 2019. And Tony from Chainapsis, Kepler, Osmosis, doing amazing work there. He actually spec'd out interchain accounts as a super prototype in the demo. Then he got very busy writing Kepler full time and didn't really build it out. And, but I thought it was a really cool idea. So when they started building out IBC, I need a test contract to test it. I built something called IBC Reflect, which is basically loosely based on his prototype definition. And I wrote this thing and stuck it there as test contracts we stuck into a WASM VM to verify that our bindings worked and we could actually run this stuff. So we used it as a test contract just in our CI, never in production, never for anything. So I built this thing, and the last few weeks I basically pulled this out, brushed it off, updated it to IBC v3, cleaned up all kinds of stuff that was like these old ways of doing things and try to make it more modern. But now it's the same idea, basically. It's a loose idea of ICA accounts. I call it simple ICA. It doesn't do everything ICA does, but whatever. It's the same idea, the same general theory that you learned an hour ago about interchain accounts. And it has a control on a host side. I renamed the two sides also based on the newest name. So I try to clean it up so it's more understandable to modern development. And so that's what I'm going to show now as an asymmetrical protocol that's actually live. Well, actually works. So not live anywhere. I've only deployed it on my local machine. So I haven't actually seen these contracts in any testnet even. Yes?
What is the easiest way to test our ABC contracts?
That's where I'm going to go. Thank you very much for that question. It's a great question. There's two ways of testing them. I'm going to show you can write some Rust tests. They test basically the unit tests. Yeah. So you can test one call. So you can test the send part. My method sends a packet. I can sort of see that if I have a packet over here in this format, it will parse it properly, right? I can then fake an acknowledgement and do it. But I cannot do the whole flow because I'm just unit testing it in isolation. We don't have any mocks to mock up two blockchains to connect them with real IBC and all the whole handshakes. So we're basically mocking little pieces, unit testing them in isolation. That's what we're going to do in Rust. I'll show you how we're doing that in Rust here. It's a very good question. I think it's a very important question. What I say is that's not enough. And so another thing I spent the last 2 weeks doing was brushing off the TS relayer, TypeScript relayer, which I also wrote back in early 2021. And that one's a TypeScript relayer is not just a relay like Hermes, it's really a library wrapped as a node command. So that library now can be imported and very quickly write TypeScript tests. So first I'll show you the Rust code to use, and then I move over to TypeScript. So if you're front-end dev, you can ignore the next half hour, and then I show you the front-end stuff, which is really just TypeScript, very high-level tests saying I load up one doc image with Osmosis, one doc image with WasmD, Juno. I then have a CI test. It says install this contract here, this here, create a connection, create a channel, call a command, send packet, relay packet, get result, relay ACK, do that, and verify the state. So that whole process you can do very quickly in a nice, just whatever test run you want. Use Jest, Jasmine, whatever. So that's, for me, the best way of testing this stuff. This was not done or documented until recently, except buried somewhere in the ICS, in the TS Relayer repo, which I understood. I used it, but it was not accessible to anyone. So I spent, again, the last few weeks pulling this out of the repo, extracting it in the simplest way possible to use a template. So I'm showing you now that first contract I showed you is a template to learn IBC. And this is one repo, which I think is a template for building your own IBC contracts. You can copy this one as is and rip it apart. You might want to just copy this one and then fork it and modify it if you want to do it, or just copy it directly and then completely change the underlying thing. But that structure it gives you is a structure to create two contracts and then a CI that will run them. So this all in one repo. It's both Rust and TypeScript. I'm going to look at the Rust side first. If you look here, it's a standard multi-contract repo, standard, like CW Plus or many others. It has two contracts, simple ICA controller and simple ICA host. It has one package, simple ICA, which defines the protocol itself, the shared library that they both use. And it has a little function repo thing called tests here. Test is actually just a package JSON. It's a node app here. It's a little node package, NPM package here. And this package, JSON has a source file here. I'll open up later in something else. And a controller calls on the spec, and you see these tests here. I'll everything. That shows basically a bunch of code here that just says upload contracts to WasmD, upload contracts, step channel with ICA 20 contract, whatever, ICA, connect account and send tokens over. So we have just simple tests here you can run, assuming you have local networks. So I'll go into this TypeScript stuff later, but this really is really interesting integration test for me. And once you can do this, you really have the same code here in these test cases as you'd use in client setup. So if you want to deploy contracts, you can use the exact same code. You pull into a script saying deploy. Deploy.ts can be a CosmJS thing, which will actually load contracts on multiple blockchains and instantiate them with the proper values and create the contracts. So the same code used in CI, you basically pull out into a script and use that same code in a script to deploy it and to execute it. So I think this is really nice for here because I find bash scripts really hard again for interacting with things. But I'll get into that later. So this is the structure I'm proposing. This is not like the Bible. This is not something I've worked on for 10 years and said this is perfect. This is my current iteration. I took up some old code I wrote. I cleaned it up as much as I could in a relatively short amount of time. I think it's relatively clean code, and it presents a way of doing this. If you think the abstractions here are bad, change it. These patterns I'm using are decent practices. They're not necessarily best practices. The patterns in CW+, I think are pretty much best practices. We've tried them for a long time. They work out quite well. These are still newer, so I'm very happy to have them challenged, PRs to improve the structure. But at least you start with this, understand it, and if you find it limiting at some point, ask me. We can make them better. What you define here is basically the packets. So the packages, so not looking tests, I'm looking in packages. So I have a shared package called simple ICA, which has basically a few things. It's a library that defines the constants, and we use unordered channel, and we use simple ICA v1. It defines some constants to share them everywhere. It defines a few checks, some error messages we can use here, and check order and check version, right? We talked to the other function, assert order and version are correct, and this does the same thing, straight up, right? So we make some simple helper functions, so they both wanted the same thing when they check it. If you have two different contracts, they want to share the same logic for validating the version and order. And the main thing it has is actually defining the common message passing structures. So we pass packets, this is what's common between the two sides. This is not their personal interaction to execute messages, instantiate messages on the contract. This is the wire protocol. This is the inner blockchain communication protocol right here. Packet message is the message that is being sent from the sender to the receiver, right? So when you send packet, you're sending this one and receiving this packet. And it's just like this. We have 3 different versions here. Dispatch, which says run these messages. Who am I? Finds out, given a channel, what's my address. And balances gives me my address and how much tokens I have on the chain. It's a useful query. So we can make it a better one with more queries, more things, but seems decent stuff here. For that, so I think the main thing to think of here is if you look at it, these two would work as queries. If you look at a normal contract, these would be query message, and this is execute message. We don't have such a distinction in interchain communication because it's only a packet you send, right? Depends how we handle the other side. We don't have different entry points. We just have one way of calling it, which is send packet, and that's relayed. Over here, the other side determines what to do with it. And we define the acknowledgement format. This one's called std_ack. You can actually copy this code. There is an attempt to standardize acknowledgement format that was used in ICS 20, right? They have a kind of standard thing. It's also in some ICS 7 or 27, I don't know, some other one anyway. But this is basically defined as protobuf. But ICS 20, they use as JSON. So you get a result, or you get error as a string. And this is a JSON format. I found that very handy for contracts, and we can use this one. There's one bonus of using this as a wrapper for acknowledgement. If you return an error on IBC packet receive, right? If your code returns an error there, you don't catch it, or a sub-message returns an error that you don't catch, and somehow that contract returns an error anywhere, we'll grab the error, we'll wrap it into this standard acknowledgement format as an error, and we'll roll back all state changes. So it will not fail the transaction will succeed, and it will write an acknowledgement error to the other side in this format. So as long as you use this format, if you do not want to use this format for errors, basically capture all errors, all sub-message errors, roll back and state internally, and you can define any acknowledgement you want. We did that before. It was a very hard user experience for me. I mean, I could do it, but I found it challenging, so I said, we're going to make it easier. And now we say, basically, just use this format if you're making new protocols and not trying compatibility. If you're doing compatibility with existing protocols, you have to do their format. But if you're designing your own format, it's your contract and your contract here, just use this one as acknowledgement, and you can return error anywhere and receive, and that'll automatically get wrapped into this acknowledgement packet on error and do the rollback state as you expect in a contract. So I made this one here as a few helper methods to create a success version. You'll serialize your data. And a fail, which will make the error message, and as an unwrap thing to verify it. So it's a really simple thing, but it's a nice little helper to use. I recommend using that in your own protocol. So even if you just want to use something else, you can rip out this piece of code here and use it. And the last thing it does is responses. So again, on one side, this is both message and execute and query. But like query, every one of them returns response data. Right? So when I get dispatch, I have to give acknowledgement. So this acknowledgement contains, if it's successful, it's a result, which is binary data. It's a message. What is that? Well, it should be one of these things. It can either be like query, a dispatch response, if it's a dispatch packet, a who am I response, or a balances response. And that's what's passed inside the acknowledgement packet on the way back. One of these 3 things, depending on the type of packet. So this is the shared wire protocol they both use, and they just have this common data structures here. I found it a useful thing to have separated, and then you can just work on the logic separately. If I look at, should I start with the controller, where it starts? So the controller here, again, I'll go a little fast here. On open, just basically checks versions, it inserts versions are correct. On connect, which is the confirm, once it's established, the connection is established, it will do this, and it will, the controller will create an account data, basically an empty data saying, hey, we created a channel here. We don't know who it is, we create a channel. And interestingly, what it does is it makes a who am I packet. So when the channel is established, when we make a new channel here, they do this much fancier now. They refactored all IBC Go in a very, very complex way to do this in the version negotiation, do this inside of that one, which is actually nicer in a way, but super complex. And the simple way it had, again, worked a while, was just when you create a new channel, controller starts, it tells host, I'll make a channel. Host says, okay, I speak your version. And then the controller says, who am I? Right? Who am I? And so then the controller, the host, when it establishes the contract, says, okay, when it establishes it, it will make a new account for you. It makes a new account for you. And then you say, hey, what's my address on the other chain? Because I need to know my address on the other chain so I can send money over there. We'll see how this works. So it does this automatically. It does a send packet here. You see this lines here to send a packet. Pretty straightforward, to lifetime. And then you just do add message to send the packet. And this is how it says, okay, send a who am I message on the connection. Close just does some cleanup. Then receive doesn't do anything because the receive part is not in the host, right? So let's look at the execute part here. So this is just the controller. So one thing happens when you create a new channel, it says, who am I? And there's a few more messages. It has update admin. It has send messages, which actually dispatches or wrote messages. It tells the other side, do this on the other channel on my account name. Check remote balance. It's a query. It sends a packet to the other channel, the balances query, to find out how many tokens I have in the chain. It's a pretty useful query to have. And send funds is an interesting one, which basically says use ICS20, like a parallel connection, to send money to my account on the other side. Which is useful. So I can say, hey, I can make a connection. Then there's this packet, say, what's my account address? Great. So they do ICS20 to send funds over there. Then I can query balance. I have money. Then I can say, go swap that money, go invest it in staking, do what you want with it. So this is kind of the protocol. And query message, you can find information about your account on channel ID. An account will tell you the channel on it, the update time, it was updated, how recently we got the message back on the other side, the remote side, the address on the other side. So if I'm running on Juno, I have my Osmosis account here, what's my Osmo address, and the balance on the remote side. So that's how we execute it. In the contract, basically, you see those things handled. That execute message, send messages here. We'll basically verify that I'm the admin. My contract only called it one address owns it. And it just does the same thing. You see this thing, it just basically says dispatch. Take those messages and dispatch them. And then add message of this send packet. So to send a packet, it's pretty easy, right? Just do send packet and you run it just like a WASM execute contract call. Same thing, check remote balances. We'll make a new packet called balances and send to the chain to wait for the ACK. Now jump to the host side. So we see how this works, the controller, how it sends packets in the beginning. Does this kind of make sense, how I've structured it? So it does first, it checks its own life cycle when it starts up, just some initialization. But basically, anytime you want to, you can ask for check balances, and it'll query again, and when that's finished, you'll have a new updated data from the remote side. It's out of date. The number of days is all out of date. But you can ask again, and it will then later get packet back and give you new data of the new balance on the side. So you can see who you are on the other side, you see your address, and you can ask it to send packets over there, do messages. So if you look at the host side here, this is more interesting, I think. So we have the way we create new accounts is this. Every time you create a contract, it gets its own account. There's a very simple contract in CW Plus called CW1 whitelist, which says, let any of these addresses do anything you want as me, right? Basically it says, just you send a message to it and it repeats your message again with that new address. Reflect, basically. So what that does in this case, you could use it for like access control lists, allow 3 people to share access of something. But what we do in this is basically say, our simple ICA host controls another contract here. It makes a contract, and that has its own address. And every time you make a new channel connection, it will make a new contract, a new baby contract. Oh, this channel called me, I'll send the message. I take it, I go to this contract, it sends it in that name, just one address. Another connects, I make a new address for them. So it basically manages to have multiple addresses controlled by one contract. So obviously, if me and Jake both connect to something, and he sends all his Juno over there on his Osmo address, I shouldn't be able to access that same thing and somehow steal his money. So clearly we have to be separated. We have different addresses on the Osmo side. We have different addresses on Juno side. So that's the reflect code ID. And we see here basically the host doesn't really have many entry points except for the open. Open here is checking, right? The connect here, what it does, you see this is, so when it connects and the connection is succeeded, it will make the instantiate message call. And that says make a new contract. We have the code ID to use a contract, it's already uploaded. And it says, okay, now this is even more hard. This is even harder, look at this. This is harder than sending a packet even. This says make a new contract. It's not that hard, but the sending packet's so easy, this looks a little bit hard. It says create a new contract with this configuration, which is listing I am the admin. Me, ICS host, is the admin of this other contract. I create this new contract, and they get a callback to find the new address. So we use the ACTO model. If you don't know CosmWasm, you don't call directly. To avoid reentrancy, you return messages. Those are passed. If you return messages, you can just fire and forget. If they error, the transaction is rolled back. You can also get a reply, so when it succeeds, you get a callback so you can handle it later on. So I finish my job, I say, do this. It runs that, it might run subcommands, anything it wants to. And eventually when it finishes, I get a note, hey, it finished, and here's the data. So this is a good pattern if you instantiate. We do this thing called a reply block. It's a bit complex, CosmWasm. And if you see this one, the reply init callback here, basically just says we parse the reply instantiate data and find the contract address that was stored there, find the contract address from the reply, and then we can store it here and make sure we have not stored it once. So it's a little checks here. But basically it says, okay, find the address of the new contract we just created. This is a pattern. It's medium, moderate, advanced CosmWasm, I guess. But so we use it here. So create a subcontract I control, I have the address of it. There are a number of people here who know CosmWasm. They should be able to teach you this if you don't know. But what it does is, when the channel is created, I create a subcontract, there's a new address. I store that address, I say this channel ID 17 is connected to this new address of a new contract of mine. Right? Let's do this mapping. And that's what we do here, is account save the contract address. So I know the channel ID is mapped to the contract address. So I've stored that when I create a new channel. And now when I receive a message here, I'm going to stop going into the details here. But basically, when I receive a message here, it gets a packet, it parses into a message thing, and it dispatches based on the type of message, right? Just like execute does. We don't catch errors here because we just say they're handled by the environment now. This is new in IBC v3 that we can handle with the runtime. We just do the rollbacks. So basically, this is receive dispatch, receive who am I, receive balances, just like execute. Who am I? We just load the account, right? Find the account ID, the contract address for the channel, and return that number. Return it, and then we say basically make the response here, and then make a success acknowledgement for it. And then set ACK. And this is how we define basically, this is what has data, we turn it to an acknowledgement wrapper, we wrap it up and then set the acknowledgement. And that will be returned back to the caller. If it is balances, we find the address first of all, like before, then we query the data of coin balances to find all the coins that the contract has, and then return it like here with a success and acknowledgement. You don't have to get all of this now, but I'm just going through it a bit. You can look at the code later at your own leisure. And finally, dispatch, which is more complex, which says basically load the account that belongs to it. We start with this empty result. We start basically with something saying we did nothing. You'll see why. And we have to give acknowledgement of something. And basically say, okay, now we find a message saying, CMU whitelist, run this command, execute these messages on my behalf. So the host contract says, hey, baby contract I created, whitelist contract, run these messages on my behalf, and then runs them with a new address, with a unique address for that channel. So it looks it up basically on this account. So given this, this caller, this channel ID, what address do I have? And it says, hey, tell that contract, WASM execute, tell that contract to run my messages with no money. So that's basically a way it can dispatch with multiple addresses from one contract, which is a pretty cool trick, I think. And then when it succeeds, you get a response of what happened then. Receive this message. So yeah, anyway, I get the response on all of that. Then, yeah, then ACK, we never get ACK or timeouts because we don't do it. And when we receive this stuff, so there's a reply dispatch one, which basically says find the result awaiting data. We get the data we got just from this callback. We get the data from that call, and we store it in a dispatch response. So we first set a placeholder saying we did nothing, and then once we get the result, we override. We use set data to override the acknowledgement. So in the reply block, you can update the acknowledgement later on. So we start with an empty acknowledgement saying we did something, nothing happened. And then when something did happen, we say, oh, here's the actual result. So we can override that one with success. So this is a pattern of how you can do something, do some message, and update your response based on that. Lots of information, I know. Then we go back into the, I'll take a break in a second, the controller, and look at the ACK part. So in the controller, we are looking at the acknowledgement. And so this is interesting for me, this pattern here actually, right here. So when you acknowledge something, we get the original channel we sent it on. So we get both this packet. So when we get the acknowledgement, we get the original packet. We find the original packet that was sent, as well as the acknowledgement data. So we find the caller from the original, the packet, the source, I was the source of the packet, and the channel ID. So we can find out which channel I sent it on, right? When you get the acknowledgement, right, where did that come from? It comes from here. So you can find out which one is sent on, and then I take that original packet data to see what actually that packet was I sent a while ago. And then I can also parse the acknowledgement from the acknowledgement data, right? So you go with the original packet and the acknowledgement. What it lets me do is the following. If the original package was dispatch, I'm going to expect a dispatch response. If the original packet was who am I, I'm expecting a who am I response. And the original packet was balances, I expect a balances response. So you see this nice pattern here. You just use the type of the original packet to figure out what I'm expecting as data in the acknowledgement. And it's a standard thing. So acknowledge dispatch does nothing right now. We should do something. Ideally, in a better version, this would call back and do some, trigger some callback to the original caller. So if you tell it to dispatch, when that comes back acknowledged, it would tell you, hey, original caller, this happened. Check it out, right? Right now we do nothing. But this callbacks is really something I'm working on in IBC Go right now, and a great thing to make it usable so some protocol can actually get the feedback. There's also acknowledge who am I when that comes. Basically, we parse this thing. If it is a result, we get the response, right? So this is basically match the type. If it was a success value, we parse it into a who am I response. If it was an error, then we just return an error message, right? And once we find the address, we say, hey, who's the original caller? What packet ID, remember what the channel was sent on? And then I can update it to set the remote address. So the first time it gets it, it sets the remote address on the other side. So once I get a response from whom I locally cache the address. It just never changes. Right? So the who am I says, okay, I asked the size of who am I. So now locally, I can query that on the source chain. I have channel 17. What address is that? It doesn't have to just do a new packet. It doesn't have to query it anymore. Once it did that one time on setup, it knows who its address is on the other side. And balances does the same other thing. It basically, parses the acknowledgement, make sure it's successful, right? Make sure it's successful, and then parse it into a balances response. And then it says update it. It makes sure it's the same address. Doesn't use a different address. If it uses a different address, it's a problem. And it will update the remote balances level. A remote address must not change. You can never change that number. One channel should have the same address all the time, but the balances will change all the time. So that is basically what it lets you do. So you can say, at this update time, I have this remote balance. This is actually not really correct here. I should not use my local block time on chain A. I should use the time that the acknowledgement is processed on chain B, right? So I send a packet at 11 o'clock, and on chain B, it's actually at 11:02, and I get the response at 11:05. It's not 11:05 update, it's 11:02 update, snapshot. But I'm not sure where the data is stored in this packet. For callbacks, so it might be lost on a lower level of what time the receiving blockchain processed it. I don't think is available in the application level, so we're just using it by this one. Maybe it's changed now. This is old code, so maybe in IBC v3 this is exposed. I'm not sure, I have not checked that again, but you can just be aware the time is tricky. We have two different blockchains with different times and different heights. Anyway, that's the same thing. I'll take a little break now, and then like a question break for a few minutes, and then I'll show you the TypeScript stuff building on this. So, like 5 minutes. Food's gonna be a long time. I'll end up early. I'll just do another 20 minutes after this, and then I'll finish up. So it's not food time really now. It's more just a quick, you stretch a little bit. Just a few minutes of questions. I'll get into this. I'll do 20 more minutes on the TypeScript stuff. Then we're done. We have half-hour food break, or a little more, I think. All right. So look at this code. Poke around a little bit if you want to. It's on resources. There's a link to it. If you have any questions about something I did here, I covered. I know it's a lot of information, but please, if you have questions, I'm sure if you're a little confused, I'm sure many other people are too. So please ask. Jake.
This is really cool. Wow. What do you think are some improvements that can be made to this for anyone who is interested in like hacking this small track?
Very good question. So, yeah, I just tried to clean this up with old code, and I wished I could do improvements on it. I didn't do any improvements. The first improvement I have is callbacks. So when on the controller, you have a message which says basically send messages, right? That's going to run on this channel, which must be owned by me, the caller. It checks I'm the owner of it. Run these messages. When it finishes, nothing happens to the caller. So it's fine if the caller is an external account. But if the caller's in the contract, it wants a callback, right? So it knows I did something, and so it should basically, I think, have some sort of callback hook, right? I don't know if it's just, would be the simplest way, and you define some standard callback hook that is used, right? And if you set that to true, the original caller of this message, the original caller of it, will get this standard format with the original data response at the time. So I think that would be a simplest way of doing that callback. There's probably better ways of doing callbacks. You can invent that, but like some way of saying the original caller can get this data. Another one I think would be interesting is, so Interchain accounts is ordered channels, which I find to be really fragile. And so when you're discussing this, back a year ago, they were building one ordered channel between them. I said, this is problematic. Because if, Jake is moving lots of money, he's running the Juno Hack DAO or something like that, and they're moving lots of money in the dev DAOs and these big things, they're using this channel. Me, malicious guy, also sends a message in that channel, which is some illegal instruction, or some infinite loop, or some very expensive operation that caused 15 billion gas, right? Oh, that's packet number 5. Now Jason's packet number 6, which is actually, staking his tokens. It can never be executed until mine's executed. So if we're sharing an ordered channel, it's very dangerous because I can stick something really dangerous or really slow to execute, really expensive, and it's going to block the entire channel until someone actually pays that gas or runs this thing. They can't do their own work. So sharing an ordered channel is very dangerous, right? So I said basically you cannot have one ordered channel. You have 2 choices. One unordered channel, like ICS 20, so everyone can share it, doesn't matter. If my packet never gets relayed, yours can still be relayed, doesn't matter. Or you have one ordered channel per connection. Per owner, every person has their own ordered channel. So the ICA team took that advice, I guess. They looked at them and they said they prefer the ordered channel, keep it, so they made multiple ordered channels, which is this design here. I made it unordered here because, well, TS Relay does not support ordered channels yet. I haven't done too much maintenance in the last year on it, so I haven't added that feature. I've done maintenance, but not added features. So I made that, but that also means you could combine them in one channel. So I'd be curious to see that as like one channel. Rather than making a different controller contract, you have one controller contract, you have one host contract, and depending whoever calls this one in the message, we say, oh, sender ID was this, which then figures out where you dispatch it on the other side. There's a different mapping. Rather than using a channel ID to map it, we use who the original caller was. Then we say, hey, when it finishes, we send this call back to the original caller, which makes it very easy to implement now. We create one channel, one setup, one time, and multiple contracts can call this thing. They immediately get an account on the other side, and they can, and then they can get callbacks when it finishes. It does mean there's a different step in registering account. So when you want a new account, the first time you have to register an account to get an address and then wait for that to come back, which you get a callback saying register account message, get a callback when that finishes. And when it finishes, you can get a callback saying, okay, now I'm going to send another message that's going to actually do something, right? So I think callbacks are super important to get workflows going on. Those are my thoughts. I think a lot more stuff could happen on it. So that's just the first step, right? Like callbacks and combining into one channel. It makes it easier, I think, ease of use. And I think it's then, actually differentiates a little bit, having this one unordered channel and how important is ordered channels. Yeah.
So it's safe to have a constant reply ID even when you're going for relay. You don't need to have a custom reply ID. Does that make sense?
The reply ID you saw on the reply block, they are not in the relay, they're local. So the reply is only called, the reply method is only called locally as sub-message in the same transaction. That's a local call. There's 2 ways of getting callbacks, right? So if I send a message as a sub-message locally, right, in the same transaction, I will get a reply callback. If that reply callback, if uncaught errors, or reply callback erroring, will revert the entire transaction, including what I did before that reply, before the sub-message. The whole transaction gets reverted, right? That's synchronous. In a way, it's actor model, but it's some way in some sort of transaction that can roll back the whole transaction still, right? If you have cross-chain, you don't have that reply ID. You do send packet, receive ACK. Those are different calls. And the receive ACK, what I'm saying is you don't have that constant ID, you just match the original packet. So that's what I was showing you earlier, that match the original packet format, so you know what was happening, and that's how basically your ID is the original packet that got sent. Okay, any more questions here? So I think the other protocol is ICA. This is complex enough protocol here, I think, to be a real world example, right? This is like a major protocol. So you can look at how it's built as a contract. I think it's a starting place. And if you have another idea, like cross-chain swaps, you can probably modify this and not just accept any messages. Like, this is pretty generic. It doesn't know what it's doing. But you could actually make a protocol that says, I have a cross-chain swap protocol and query TWAP, and customize this maybe a bit. Use a lot of the same design, really, do some cross-contact calls in a limited scope, and maybe they have triggered more processing and different actions. Maybe they trigger a whole series of transactions on the other side based on state. So there's, okay, I'm going to move tokens, then I'm going to swap it, I'm going to check how much is returned, then return all the balances returned, and you can actually add logic and complex logic on the other side rather than just saying blindly run transactions. You could actually do various things here instead of this one and have much more complex logic on the other side rather than just run whatever they told me. It can actually process it internally. So I think that's a very interesting way. So you could basically fork this one, rip out this part and replace it with a bunch of more complex subcommands to do things like, you know, move tokens over, swap them, return the results, and give me this average price back, whatever you want. And it would have to do lots of queries and things, combine them together and give you the results. So yeah, I think that's one way of also going to make another protocol here. Okay, I'm going to, without further ado now, I'm going to go over and check out the VS Code. So, yet another IDE here. Yeah, so I use IntelliJ. I recommend it highly for Rust development. I found the Rust extension very, very quick. It checks everything, underlines errors. It's very fast, and those inline hints are very useful. So if you look at this stuff, if you're not a fan there, this code here, where's the message? Contract. So here, you see these messages here and these arguments here. I found them quite useful, especially these type hints here, what's going on. And sometimes it says, oh, it's a result of something. I forgot to put the question mark at the end. If I do this, okay, it's a result. It's not a vector, it's a result. Oh, well, then I put a question mark here. So those type hints for me are super helpful. And I recommend using this if you're not addicted to another IDE yet and using Rust. I recommend this one. It's very helpful. Key bindings are a bit annoying sometimes. You don't know them, but it's very nice things. There's also a Rust extension for VS Code. You can use that one. It's good. I prefer this one, but it's also good. Anyway, VS Code, I use that for TypeScript. I think they're the best support I found for TypeScript. So that's where we are. Inside this, this whole repo here I showed you, there's this directory called tests. And tests is like a subdirectory inside this whole Rust repo, which is holding actually a package.json file, right? So we have a package.json file here, which is, you know, its own IBC test. Oh, it's actually the wrong one. Yeah, I think I copied this from other demo I did. So basically it's a package.json. I'll explain a few more things, but this assumes we have some local blockchain set up. We have TS Wheeler, has a bunch of test utilities in it. But I'm going to show you basically how we write the tests here. Let's close this, and I'll show you run the test later on, and then we're done. Then you have food. Promise, 15 minutes maximum. Thank you for your patience. So basically we have a bunch of import statements here. We set the test utils, we set the osmosis fee here before. So this is set up. We store external contracts we download CW and whitelist. And internal contracts, we have the ones here. I can run a command to build it locally, right? So I have a script there that will build these contracts. But the CI, what it does, actually, it will first test the unit test the Rust code. It'll compile the Rust code to WASM, and then it'll execute the JavaScript test with that WASM I just wrote. So if I break the Rust code, I change it in a modified way, it will actually first make sure all the local Rust tests work, then it'll load in blockchain to run a full integration test with that same WASM I just had, which is pretty cool. I thought it'd take forever. Running a test run in about a minute or two, or 2 minutes maybe, which is, I think, pretty good to run the whole battery of Rust tests, compile it, and after you compile it, you run the integration test with multiple blockchains, which is, I think, pretty good time, actually. Anyway, it's not 1 second feedback, but pretty fast feedback to know if you broke a whole protocol. So the before block basically says, you go upload stuff. I create a WASM client here, and I call these contracts. I say, basically, I want this contract controller. I take this file here as controller. And on the osmosis side, I need the host contract, and I need this whitelist contract. Right? And so I do this one time to upload all the WASM files onto the 2 blockchains I have. Local blockchains, not real blockchains. That's too expensive. And then, so the setup one, the first test is this. I'm just going through it really quickly. Let's maybe close. How to get smaller? There. So the first step is this. Basically, you set up a WASM client, and you call instantiate. We have the addresses now. So it says instantiate. It has WASM. This basically is a helper method in TS Relayer that will create a new account and fund it. So it creates a new account with 4 WASM or something on it, tokens on it. So a few tokens on it. You say, hey, create an account using this controller contract, right? The initialization message is nothing, and you label it with auto fee. Boom, it's created. And we verify, we get the port of it, we pull the port out, we get contract, and we can query the port of it for the controller port once it's created. It's synchronous, so it finishes. This makes an osmosis client with funds. It then says, okay, instantiate the host contract, right? But it tells the host contract what the waitlist ID is. So later on, it knows how to make those, right? We create these contracts, we use 3 IDs. This is a reflected ID, we don't create it yet. It will be created by the host contract. Verify it doesn't get the host port. And then this here is basically saying a relayer. So those Osmo and WASM clients, right? Those are basically users. That's my user and my user I have there, right? This is in the relayer. So this creates a relayer setup. We'll take 2 blockchains, I'll fund them, and it'll create a relayer that knows what these 2 blockchains with accounts. Then you pass into link create new connections. That is a great CI one. Somebody says create a new client and create a new connection. That link is 2 accounts on different blockchains. Those blockchain definitions, a new client and a new connection between those blockchains. And that's called a link. That link is like the high-level thing in our library for TS Relayer. It allows you a whole lot. And then link create channel starting on side A. You start on side A or B, right? The first one here is A, so WASMD is A and Osmosis is B, right? We put them in that order. This is A. Using controller port on side A, host port on side B, Osmosis, unordered channel, and using the version string. So these 3, with a wait, of course a wait, right? So these 3 things say create some accounts, create a channel, and then create a client and connection and create a channel with my things. And this verifies that actually works. So that's, I think, pretty easy to run Relayer. Now, this is just the original setup function. We verified it worked, right? Another one is actually, when I want to do other ones, I want to build on that. I don't want to write the same code over and over and over again. So I pull this basic test code out into something called demo setup, so the demo mode, and I basically store the information, who the WASM client and Osmo client for my user is, right, me, the controller port ID, the host, I think these are channel IDs actually, no, yeah, the controller is then the address. Yeah. So this is the address of the controller address on the WASM side, the address of the host on the Osmosis side, the link, which is basically the relayer knowledge, and an ICS20 connection. So why have 1 channel? We have 2 channels, right? So the setup here, same thing, we instantiate the initialization, we instantiate the host. We do set up a link, we create a new channel, client and connection. We create a new channel for controller port. And then we say, let's create another channel. Let's create another channel, which is using the ICS20 ports of both chains, unordered with ICS20-1. So we create an ICS20 connection as well. So on that same connection, we have 2 channels, the relay is running. Both are custom channel between our two contacts we wrote, and an ICS20 from the standard transfer one. And returns all the information here so we can do things in test cases. All the test cases then basically do the same thing. They do the demo setup to start up, to configure the whole thing, configure the contracts in the relayer. And what do? The first thing, remember the packet, the whoami packet we had, right? The whoami packet we launched. So we're just going to relay that one. So if you want to relay it, do relay all. Relay all will say, I take all packets from side A, I relay them to side B, and return the acknowledgement to side A. Then I take all packets from side B, pending, I relay them to side A, and release the acknowledgement to side B. That's what relay all does. It's everything for you. And it returns the info. Info is the acknowledgements, how many packets were relayed, right? And so then you can say, okay, I'm asserting packets from A, it's a helper function I wrote, which says basically this information here is saying there's one packet relayed from A, and it was successful. So I said, I'm relaying the packet, and I said, oh, yeah, you did relay one packet and successful. So I know there's actually a packet on the wire, and it did not fail. So that's 2 lines of code. Pretty easy. And I've actually then run the whole thing on both blockchains, the whole who am I. And after it's done, I say, okay, it succeeded. Now that contract should be registered, so I can find the WASM, I query the WASM controller, I get the account listing, and I find the remote address of my channel, and I find my channel IDs here. I can show the accounts, I can find all the balances, I can find the information on it, right? So I can start querying it because I know who the other one is. Then you can basically say, okay, I'm going to send some money to the remote address. So I see my balance. I'm sending money here, fund remote account, which we go into it, is basically using the send funds. So I'm going to send funds to my account on the other side. It will actually, the controller will trigger ICS-20 and send funds on the ICS-20 transfer packet. Yeah, I know. Anyway, it will do that one. It sends tokens, and then, so we fund the remote account, and we relay that packet, which will actually move money, right? Then we say, we can get the balance we had. Then we can check the remote balance, which says, from, again, WASM, I call Osmo, what's my balance, get the number back, and I can find out that my balance was actually done on the other side. So these are, every time I want to do another message, I basically do a function call here, a method call on the local contract, on the controller side, relay everything, make sure it did succeed, right? So make sure it didn't fail somewhere in the relaying, or got an error in the relayer. And then you check to see the state was updated properly. The same thing, you have control action on the chain. I'm going to stop, I know. Control action on the chain. So you actually just, I moved money on the Osmo side directly, and then I basically say, okay, remote bank send, saying, tell the chain to move money from my account on WASM, from Osmosis to another account on Osmosis. So I set this up, and whatever, these 30 lines here is basically doing that connection and everything there. I think a lot of people are hungry. I'm going to run in the background. I'm going to show you how to run some tests on it. But if you're interested, basically what I'm going to do is I'm going to start up. I'm going to stop talking, and I'm just going to watch these terminals here. If you want to get up and start eating, get up and start eating. We have half an hour break now. And I'm going to continue and just show you how to run it. You can check out this repo and run it. But basically, you create 2 local blockchains. You run Osmosis blockchain and WASM blockchain on the local host. And then you can run npm run test, and it will do this whole setup here. Yeah, I'm running on a MacBook, and it's simulating AMD. There's a little limits here. So if you are a MacBook, the problem is you have Intel-based binaries running on a MacBook and simulating Rosetta. And so when you're running Osmosis with WASM contracts through Rosetta, it uses a lot of memory. And Docker seems to kill it now and then because it's using too much memory and it hits a Docker limit. So I'm going to try to actually adjust my limits on Docker first and then see if I can get this to run. It's usually running about 4 tests and then crashing out of memory, and the Osmosis binary will die. But if you're using Intel-based thing, it does not happen. If you actually compile Docker images for ARM, it works better. Just letting you know, there's a few tricks. But yeah. You can get up and ask questions if you want. I'm just going to do it in the background, show you how to run this stuff. So I'm going to give it a little memory here. Let's see if that works. So I'm going to give Docker a little more memory to see if it will be a little more robust than last times I've been testing it. Yeah, you can have food. So I'm not going to talk, I'm just going to be running stuff. You can watch the screen, keep recording it maybe, showing this. I'm going to be showing the screen. You can see some of these commands running, some npm test commands, and see the stuff run. No, I'm going to show the live stream. Just, you can mute it if you want to. If you want to, you can mute this. Yeah, you can mute me, but I just want to have the video showing.
Okay, can you hear me? Can you hear me over there in the back? Yeah? Okay. So this QR code is for people who want to register to try the first Interchain EVM bridge, so interchain transactions through the EVMs, through smart contracts that you can write in Solidity. And this is how you can get tokens. I have 3 chains. You'll get tokens for all 3 chains to be able to send transactions between these chains. So this is done with Ethermint Evmos technology, nBridge, and some other tools that I've coded, like a Web3 wallet for sharing your work. I am a volunteer. I'm actually sent here by the Evmos community by vote, which is something that I've never seen in other communities. So you can do work for a chain, and then the community, if they consider your work important for that chain, they can reward you by sending you to hackathons. You can see my work on Ethereum, EVM, Evmos on my YouTube channel. There are a lot of demos. And I programmed as a volunteer the following Evmos modules and features: the fee rewards module that will be live pretty soon, the global minimum gas price for both Cosmos and EVM, which is live now and has helped Evmos get rid of a lot of spam transactions, and proposals for cron transactions, eventual transactions, EVM interpreter. So this is an EVM interpreter inside the EVM. It's an abstraction that can help layer 2 solutions come in and have native tools that make them much precise and faster. And many other proposals. You can check them out at this site. So I am working under a volunteer project, which is the Laurel project. You can follow it on Twitter, and you'll see all of our work. The EVM interchain. So this is a set of sovereign chains that implement nBridge. So by nBridge, you replay EVM transactions from one chain to another. And in the next minutes, you'll learn how you can interface with nBridge from Solidity. nBridge is a ring of blockchains. I already said that each transaction is replayed on a specific set of chains, and you can set that set of chains to whatever you want. The sender is an account abstraction that keeps its nonce synchronized. Because we're talking about replay, we need to keep our nonces synchronized. And all participating contracts get the same address on each chain. So that's how you do the replay. You get a unique instance of a contract. It's like a singleton that's actually represented on each chain with the same contract address. And I will show you a demo of the simplest state synchronization and more. But let me tell you about the dev setup. So we have 3 chains, as I said, based on Evmos Ethermint, Mythos, Logos, and Ethos. They are all using the same software. And you have IBC channels between each of them and one nBridge. The nBridge is based on a set of precompiles, and we'll look a bit at these precompiles. There are 4 of them: abstract accounts precompile, intertransaction precompile, which handles the interchain things, Cosmos SDK precompile, which actually allows you to send Cosmos messages through the EVM. And it's part of our, what we call, Quasar system of bridging the EVM and Cosmos APIs. And the EVM interpreter precompile. The intertransaction precompile has 3 main functions that are quite important. You have emit transaction, which allows you to do an IBC transfer from the EVM. You have emit dependent transaction, which allows you to do a transaction on your current chain and one on another chain, but they should be dependent on one another, so if one fails, the other one fails too. Also through IBC. And then you have emit transaction multi, which allows you to send from one chain transactions at the same time on many other chains that you have a routing of IBC connections. between them. So I've put all of these precompiles and functions of the precompile under a single wrap, so it's actually easier. These are the precompiles address. So for people who don't know, precompiles act like a normal smart contract. So you have an address for them, but they don't have actual bytecode, EVM bytecode, because they are implemented natively in the client. But they can act like a smart contract. So they have an address, and then you have all these functions. So it's easier if you want to develop with them. And also you have documentation explaining exactly what each of these precompiles do. The abstract accounts one gives you access to do the EVM part of the transactions, and the inter-transaction precompile is based on interchain accounts from IBC. Okay, so now I have some demos, and we'll do this live. We'll see how it goes. I have this. This is an IDE that I can put, that I can make available for hackers who want to use Evmos and want to use, maybe even do something interchain with the EVM. It's an IDE where you can write with a Lisp-like language, and for example, it's very easy to set up. So we have this transaction. It's very easy to set up a transaction. It's like this. You have this function React contract. You put the name of the contract because you load the ABIs. You put the name of the function, and you get immediately a UI, and you can test right away. So you don't need to set up and do a front end for your smart contract. In 2 minutes, you have a UI that you can test. So this is kind of the interface for the N-bridge thing. So what we'll do now, let me see if I am on the right account. I should be on the Mythos chain. Okay. I'm on the Mythos chain, account 4. So what we'll do now, I have selected Mythos, Logos, and Ethos. So we should be able to deploy a contract from Mythos to all of these chains. And I have Remix here. I'm compiling it. I'll be copying the bytecode and then the ABI. And deploy it, and let's see if the live demo works. We need to wait a little bit because this is IBC channels and transactions. Okay, so the contract was deployed, but we need to get the deployed contract address. And this is a bit tricky. Because the address is derived from the abstract account corresponding to the Ethereum account that I've just used. But it should be at this address. So let's see if this works. So the contract should be initialized with a value of 5. Not this one. Bear with me a little bit. Okay, so finally, so it was I was one off with the nonce. So we have a contract deployed on Mythos. And now we can switch on the logos chain, and we should be able to get the same value. But let's test this in Remix to have another verifier than my own. So let's. Okay, we change to logos. We get the address. And the value is 5. So now we change to ethos. The value is still 5. So let's do also a change of state. And we do this, we have the address set. We do this also multi-chain. So we should send this state change across all chains. We'll have a gas limit of something, 1 million to be sure. Now we need to send the call data for the transaction that will be replayed on all chains. And I've made this easy with this tool that encodes and then automatically sets the call data. So we'll change the value to 8 on all chains. And now we need to be on the Mythos chain because this is the controller, and we will replay and we'll probably need to wait a little bit, and the value should change. Okay, finally. So it's changed to 8. And again, we can, so here we are on the logos chain. The value here has changed to 8. And on ethos, it's also 8. So this is a multi-chain transaction triggered by the EVM. What we can also do is dependent transactions. And let's do this using an ERC20 contract that I already deployed. So it's an Interchain ERC20 contract, and we'll talk about it in a minute, which has this address, and we need to get the ABI. Okay. So for this, we are on the Mythos chain. We can move tokens from one chain to another chain from our account on, again, our account. Or we can transfer from our account on one chain on somebody else's account on another chain. The total supply remains synced across chains. And let's see what balance we have now. on this account. And this is a hex number. Let's so it's 9999 something with an 80, ending in 80. So we are going to move from 7001 is the chain ID for Mythos to 7002, the chain ID for Logos. And we'll move from this address, and the value will be 10. But let's look, so I have this loaded here. Let's look on Logos and see our balance. Okay, balance for this account is this very nice number with a lot of zeros. So we go back here, and we need to encode this transaction. It's a move transaction. We press here, and we have the call data that we should use. Let's do this again. 7001, 7002 from our address, and we will move 10 tokens. And for some reason, the encoding doesn't work. So let's go over this. You've seen, at least you've seen a multi-chain transaction. So a normal EVM transaction, you have the function signature, you have the input, this is the call data, and then you send the contract address. For the interchain transaction, especially multi-chain transaction, you have the set of chain IDs where these transactions will be replayed. You have the contract address, which is unique across chains. You have the function signature and your input. Other tech that goes along with this, and you'll see this in the YouTube videos, in the demos, gas refill precompile, dtypedb, singularity governance, because now you can do governance from one chain on other chains. And I think this is quite interesting, and no one has done this before. I've shown you Mark's factory already, and this is how you can, when you set the ABI, this is how you can, but let's actually try this. So this is a new Mark's factory IDE. You put the contract name, You put the contract address and then the ABI. You just load it in the page. Let's just write it down here. And you get the function from the ABI. So this is how fast you can have an interface for your contracts. And then this is, I'll show you this to people who will want to hack on Evmos. This is an Interchain wallet, and if you do your front end with Mark's Factory, you will be able to just share your work by mobile. And this is related to the EVM interpreter, which allows you to do all sorts of interesting things in low-level EVM. And I am going to show you a little bit of how this works. You can actually use a spreadsheet for it and write down EVM assembly instructions in a spreadsheet, like all sorts of push, add, and then create bytecode in a spreadsheet. And then you have this bytecode and you have the EVM interpreter precompiled, so you can interpret this bytecode and get information like how many reads or writes are in that bytecode and what you have on the stack at a certain location in the bytecode. And nice things like this for hackers. Okay. If you want to know more, just if you see me around here and you've got your tokens, we can go through these steps together and register, get tokens, create interchain accounts, create abstract accounts for EVM interchain transactions, forward the abstract accounts on the other chains, deploy on multiple chains at once, and then simple, dependent, and multi-chain transactions. And that's it. I'm right on time.
Hey, oh, it's definitely working. Can you all hear me okay in the back? Alrighty. We're going to do a workshop on Celestia, the first modular blockchain network. Let's go over what Celestia is first. So I'm Yaz. I'm the head of DevRel at Celestia. You can find my Twitter handle here. We'll cover what is Celestia first before we dive into the workshop that we're going to do for today. So what is a modular blockchain? A modular blockchain decouples the core functions of a blockchain: execution, settlement, consensus, and data availability. So on the left-hand side, you see what a monolithic architecture is. It combines both execution, settlement, consensus, and data availability. But a modular blockchain decouples all those components, where you have execution on top, and an execution environment can settle on a settlement layer. And then finally, you have consensus and data availability layer. Celestia design is for the consensus and data availability layer. So what are the benefits of a modular blockchain? The main benefit is scalability. So originally, there are two traditional types of blockchain nodes. There's a full node, which downloads and verifies all blockchain data. It has a higher barrier to entry because the requirement to run a full node is higher than a light node. It's more catered to a minority of users. Now, if you look at a light node, it only downloads block headers. It doesn't verify the data. It has a lower barrier to entry, and majority of the users can run a light node. So Celestia scaled by decoupling execution from consensus and introducing what we call data availability sampling. Now, what is data availability sampling? It allows light client to have a very high probability guarantee that the entire block is valid by only downloading less than 1% of the block. This is what we call trust minimized clients. It increases scalability by reducing the cost for the user to operate nodes and verify the network. So the more nodes that are running on the network, the more capacity the network has, which means the larger the blocks can become. So another thing we're going to cover is sovereign chains on Celestia. They're basically rollups on Celestia, which are self-sovereign blockchains. The scalability and trust assumptions of a rollup, and it combines both the scalability and trust assumption of a rollup with the sovereignty of a Cosmos chain. So sovereign chains on Celestia, they share full security with each other. They don't need a validator set, their own validator set, and similar to the Cosmos vision, but without splitting validator sets. So best way to summarize what Celestia is just three, where Celestia's vision is a marriage of the Cosmos sovereign interoperable zone and a roll-up-centric Ethereum with shared security. All right, so for the workshop today, time permitting, we're going to cover how to build a sovereign roll-up on Celestia. But we're going to build Wordle. So I don't know if anyone ever played Wordle. It's one of my favorite games. But we're going to do a sovereign Wordle chain on top of Celestia. If you want to follow along, you can go to the link github.com/celestia.org/Wordle. All right, to start the tutorial, before we, let me see. Sorry, the laptop froze. All right. Okay, So yeah, the section on tutorial on Wordle will be where you want to get started, and that's where we're going to follow along. But before we do, let me double check if you all can see my screen okay on terminal. Yeah, while my laptop stops freezing, let's see. Okay, can anyone see my terminal window okay? Is it clear? All right, perfect. Let me just get rid of that. Yeah, so if you ever played with Ignite CLI, I'm going to assume most of you are familiar with Ignite CLI, and you probably installed Golang on your machine before. If not, let me know. But these are the assumptions we're going with. And if you ever played with Ignite CLI for building a Cosmos SDK application, then what we're doing here, we're building one specifically for a Wordle game, but we're going to connect it to the data availability layer. So we're going to build the simplest Wordle implementation, right? So in the current design, we're going to implement the following rules. One word Wordle can be submitted per day. Every address has 6 tries to guess the word, and it must be a 5-letter word. The other thing you got to do is install Ignite. So if you haven't installed it, there's like the tutorial. There's a way to install Ignite directly from the celestia.org/Wordle tutorial. It goes over it. Like if you copy this command, it should install it on your machine, assuming you got if you got Golang installed. So to check if you have it installed, just run Ignite and it should show you that it's installed. All right. So the first thing we're gonna do is we're gonna scaffold the Wordle chain. And to do that, Ignite has a command where you can scaffold a chain with no module. Here we're specifying that it's a Wordle chain. That's the name of the chain we want to scaffold. And we're going to paste it here. And now Ignite is scaffolding the chain to us. While we wait on it to scaffold the chain, so the laptop keeps freezing. I'm guessing it's the MacBook M1 not playing nice with external monitors, but we'll see. All right. So the main thing here, which can apply not necessarily for the Wordle tutorial, but for any Cosmos SDK application you want to build, is if you want to connect it to Celestia, what you're using is something that we call Optimum. So what is Optimum? Optimum is an optimistic rollup implementation of ABCI, which is Application Blockchain Interface, in order to build sovereign chain using Cosmos SDK for Celestia. It's basically what we're doing. We're replacing Tendermint, the Cosmos SDK consensus layer, with a drop-in replacement that communicates directly with Celestia's data availability layer. So the way to do it is basically the following command under installing Optimum. So I would just copy these over. Okay, now that the chain is scaffolded, basically what we go inside Wordle directory, and we're running these following command. In this command, what we're doing, we're telling the gomod file that we want to replace Tendermint with Optimum, and we're just going to tidy it and download the rest. And now it's downloading all the requirements. How are we doing on time? Okay, we got 15 minutes. We'll try to speed up to the rest of the tutorial, and if we don't have time, you can find me after and I can go over more in depth with you. But basically, the next step is we want to create scaffolding, create the modules. So when we scaffold the module, for this demonstration, we only care about the banking module. So basically, ignite scaffold module Wordle with the dependency of the bank. Okay, here we installed Optimint. We should be good to go. I mean, you can always commit when you get that prompt. I don't, just for the demonstration purposes, so I'm putting no. And now let's go to messages. Here we're going to specify two different types of messages. Submit Wordle message and submit guest. So basically there's two functions here, right? Submit Wordle allows one user per day to submit the Wordle of the day. Submit guess allowed the other user to try to guess what the Wordle was. Okay. All right, we'll wait for it to scaffold the chain. Also, if you feel like, if you just want to play around with it, basically the repo itself, you can just build it directly and it has everything already pre-built for you, so you can play around with it directly, but we're trying to go over it step by step to show people how to build it. The next thing we're doing is we're going to scaffold the Wordle types. So the first one is a type mapping Wordle to the word and the submitter. So every Wordle submitted per every 24 hours, it has the actual word, what is the word of the day, and who submitted that word. And for the guess, it has three different types. It has the word, like if I'm guessing the word of the day, I'm submitting that word. If I'm a submitter, what is my address? And finally, the count. Remember, every address has 6 tries before to guess the word, right? And then okay, and now we're submitting the final map for guessing the word. So while this is scaffolding, let's talk about the keeper functions, right? I'm not going to implement them here, but the code is available for you to implement them, and then we'll play with one already pre-built, right? Let's see first. So the first one you want to pay attention to is like in the X directory that's pre-built for you already in Wordle. You want to go to the keeper function called submit_Wordle, message_server submit_Wordle. Here, what we're doing, we're defining the logic for submitting a Wordle, right? So you got the context from Cosmos SDK, and then you get the message, and one of the messages is the dot word that we already predefined. Now, we're doing some checks here. First is we want to check to see if the word is actually a 5-letter word. Remember, it can only be a 5-letter word for Wordle. If it's not, it will return back an error. The other one is we want to make sure that the word is actually only letters. So if you send some integer, it's not going to work for a Wordle. And then we try to figure out the time. We want to create an index for the newly submitted Wordle of the day. So we figure out the time, and we convert it to bytes. And then by that, we take, like, what's the date of the day? And then we encode the hash, and we create a hash for the submitted, Wordle. Sorry, it's frozen again, but. And then we also try to check if a Wordle has been submitted for the day. So let's say I submitted a Wordle for the day, somebody else uses that same function to submit a Wordle for the day. It will check the key value store to ensure that only one Wordle has already been submitted. And if it's already been submitted and you try to resubmit a new Wordle, it'll tell you Wordle of the day has already been submitted. And then after that, we set the Wordle of the day. And then we have some helper functions. So that is it for the first keeper. And then the second one is submit guess function. Here, we're trying to create the logic around what happens if you submit a guess for the word of the day. So here, again, we have the same check. Word is 5 characters long, it's alphabets only. And get current date to pull up Wordle of the day as a hash. So that way, if I submit a guess for this specific day, it will match it with the key value stored of the Wordle submitted for that day. And then after that, for every submitter, we create a hash function of the current day and the person who submitted the guess. That way, like let's say I submit a guess for today's Wordle. It takes my date, time and day, and my submitter address, and it creates a hash. That way, I can do 6 guesses per day rather than 6 guesses for one, only one time only. That way I can guess the next Wordle after 24 hours. And, if the guess is found, like if you go over 6 guesses, it tells you, because there's a counter function, it tells you have guessed the maximum amount of Wordle. And then after that, it's it kind of increment the count for if there's no entries for that submitter, it will start initializing a count. Okay. The other thing we got to do is the protobuf file, but it's already documented here. You can do it on your own. And then finally, we're going to go over how to start the Wordle chain. So here, now that we built the functions, we're going to do the command ignite chain build. And then after ignite chain build, you got to do Wordle. This is the command. It's a long command. The one thing to look out for here, I'm going to go over in the terminal, is basically because we're connecting to a Celestia data availability node, we need to provide the IP address. So if you see here, sorry, it's a long command, but I'll go over in a second. If you look here at the base URL, like we have an IP address. I mean, you can take this IP address, it's just for a light node that has testnet tokens on it. If you want to figure out how to run a light node for the data availability layer, you can do one here. And I can go over that separately, but basically it allows you to instantiate a Celestia node because basically we're submitting blocks from Wordle chain to the light node data availability layer, and that's the IP address we're exposing. Okay, so now I'm going to start the Wordle chain. So this is just starting a Cosmos SDK chain called Wordle. But this one, because we added Optimint, if you notice, it's submitting blocks to the data availability layer because we modified Tendermint for Optimint, so now we're submitting to the data availability layer. Now let's try to submit a transaction. So here in Wordle, I'm creating a transaction for submitting a Wordle. I'm calling it Cosmo. We got to be 5 letters. I can't put an S after, but from Alice with the keyring backend tests. And the reason we do asynchronously is because it takes some time from a sovereign rollup to be submitted to the Celestia data availability layer. So what we're trying to do is we submit the transaction asynchronously and we wait a bit for it to be submitted, then we query the transaction hash. Okay, so after I submitted it, I got a transaction hash. Now we just gotta wait a bit for it to so what I'm going to do here with this command, I'm going to query the transaction hash that we just got. If I submit it now to try to query it, I don't think it's already submitted yet, so maybe it won't work right now, but maybe in a few seconds. Okay, yeah, it didn't work yet because that block hasn't been submitted yet to the data availability layer, so we'll wait out like a few seconds for it to be submitted. In the future, what we're gonna improve Optimint to allow for more submissions. Like to be faster submission of the block data to the data availability layer. Yeah. And yeah, so while we wait on it, does anyone have any questions so far about Wordle or like, you know, building with Celestia so far on? I mean, you can always find me after if you have more questions, but basically, once the data is submitted to the block, it would allow us to query that data. Otherwise, let's see. Laptop froze again. Okay. Yeah, so this kind of command allows you to test. For example, if I submit a Wordle giant, it shows me what the output is going to look like for the Wordle giant. And like, yeah, confirm the transaction, we query it, and we can verify that it displays something like submit Wordle function. And then let's say we want to submit a guess, 1, 2, 3, 4, 5, which is an integer. It will result in an error because we can't submit an integer. Otherwise, if you submit more than 5 letters, it's going to come up with an error that you could only submit 5-letter words, so a 6-letter word is going to be invalid. And then finally, let's say you submit a Wordle called meter. What it'll do is, because it's technically a valid guess, but it's not the right guess, it will start incrementing the transaction and the transaction count for how much guesses you're making. Yeah, and then it would allow you to list the guess output JSON, how many guesses you made so far. And if you want ideas to extend it in the future, there's a lot of ways to improve messaging to get the correct word. Creating a Vue.js front end, there's a lot of open source examples for Wordle. You can create a bot that submits a word every day, every 24 hours, improving the current date, improving the UI, and making sure that nobody can front run a word. So when we submit a Wordle, we're not hashing it prior to submitting it, so somebody can front run that word and submit a Wordle before us. So maybe doing some checks there. Okay, hopefully this works now. There's probably some issue with the data availability node we're connecting to, so let me try to debug it after and connect with me if you want to talk more about Celestia and building on top of Celestia. Thank you very much. Thank you.
So, after many technical difficulties, we're finally ready. After many technical difficulties, finally ready. After I'm gonna try to make this. I'm gonna try to make this low energy. I'm gonna try to make this. I'm gonna try to make this low energy. I'm gonna try to make this. I'm gonna try to make this low energy. I'm gonna try to make this. I'm gonna try to make this low energy. I'm gonna try to make this. I'm gonna try to make this low energy. I'm gonna try to make this. I'm gonna try to make this low energy. I'm gonna try to make this. I'm gonna try to make this low energy. I'm gonna try to make this. I'm gonna try to make this low energy. Nice emails. Yeah, so as I was saying, we're not a company. We're also not VC funded. There is no pre-sale. There was no like inside deal. There's no like investors. Well, maybe there are. In like, you know, no, completely community owned and operated. And we're not a personality cult. There's no one person that runs Juno. There are many different people that run Juno, each with their own ideas. Juno is not run by Wolf. Juno is not run by Demi. Juno is not run by Block or the Frey Needlecast or Notional DAO or BlockPain or Joe Abbey or Dojmos. All right. We are a DAO. Juno is a DAO, and that's why we're cool. So what is Juno? In case you don't know, it's a sovereign L1 in the cosmos. We have permissionless CosmWasm, so you can write cross-chain smart contracts, very exciting. We have a very strong developer ecosystem, which I'm going to talk about, and we're fully community-owned and operated, which is sick. Strong community, strong Juno, that is our secret. This is our little mascot, Max. He's a little wombat. He's so cute. WebAssembly is the future of smart contracts. It's better than the EVM. I'm sorry, I started writing my first line of Solidity in 2016, and now that I've experienced WebAssembly smart contracts, I can never go back. What are the great things about them? Well, you can use existing languages you already know, like Rust, like Go. CosmWasm supports both Rust and Go right now, but eventually we can support any language that compiles to WebAssembly. So like TypeScript, C#, C++, Scala. You don't have to learn a new language to write smart contracts. It's easy to write secure smart contracts with CosmWasm too. Ethan and the Confio team and everyone who's contributed has done a lot of work to and also they've had the benefit of hindsight, designing a second or third generation smart contract language. It's easy to write secure contracts in CosmWasm, and so you can move a lot faster and innovate more rapidly. You can use existing libraries. If you want to make a really cool generative art NFT for Stargaze, you don't have to re-implement a math library for Scratch in Solidity. You can just use an existing Rust crate. It's highly extensible. It's IBC ready. I mean, you saw Ethan's talk earlier demonstrating interchain account functionality. You have this low-level access to IBC. And the last thing I want to note is performance. A lot of people talk about transactions per second and all these other silly metrics, but here's a metric you probably haven't heard about before. It's the largest computable Fibonacci number. And each Fibonacci number is a lot more compute than the next. As you can see, CosmWasm in this chart is basically equivalent to a Cloudflare worker. It blows away the competition. You can do way more compute in CosmWasm or in WASM smart contracts than you can do in EVM smart contracts. It's just more efficient and it's more performant. So Juno is the best way to launch a new Cosmos project. You can build your protocol in CosmWasm and iterate rapidly on Juno. You can find product market fit with our very engaged community. And then, once you get product market fit, once you have a bunch of people using your protocol, you can launch your own sovereign chain. Or deploy cross-chain. You can deploy on multiple chains. We have projects that are not just deploying on Juno. They're going to be deploying on Stargaze or Osmosis or all the other CosmWasm chains. And that's a really cool option you have. And then, of course, you can leverage shared security if you need it. One thing I want to talk about is the Juno funding ecosystem. So we're a DAO-first entity. We want to make sure that projects have access to the capital they need to launch and build really cool things. And so we have multiple launch pads that are coming up. Eclipse, DAO Up, there's actually a few others that have happened since I made this presentation. We have an ecosystem development fund. This is kind of the next evolution of the TerraDev fund, but it's literally the Juno community investing in projects, which is really cool. We have dev grants as well for like maybe some of you in the audience or watching on TV. You know, if you're building useful things for the CosmWasm ecosystem, we want to support you. We want to support people that are building like valuable public goods. And we want to support like also cool new projects too. Oh, and of course, there's still private investment. You know, we still have like a bunch of private investors that are looking to invest in projects launching on Juno. Oh, and of course, there's Hack Juno. There is over $1 million of prizes in the next round, and it keeps going up as the price of Juno goes up. So it's pretty awesome. You can participate in HackATOM and Hack Juno. That's great. There's more info about that, and you feel free to ask me about it after the talk. So some projects launching on Juno. We've got Loop with their DEX. We've got Kato Money, which is a fiat on-ramp. You'll be able to like buy and sell Juno directly with a credit card or bank account. We've got Levana, which is doing a bunch of like some games with dragons and like a lot of DeFi products that are really cool. People are excited about them. We've got Subquery, which is like an indexer for like smart contracts. I don't know if you've used indexers before. We have the Graph protocol. The Graph protocol is one of the leading tools used by a lot of like crypto analytics firms. We have Eclipse Pad launching, which I already mentioned. That's like a place for you if you want to start your own, like say you want to start like an Oracle project, you know? And you can go to Eclipse Pad and like help like crowdfund some funds. We have Leap, which is a new wallet. I still like Kepler, but you know, diversity is good. More wallets is good. We have CoinHall. They chose, you know, Terra and Near, which are like very large, very centralized blockchain that have lots of investor money. And then they chose Juno. So we have TFM, which is like a DEX aggregator. We have Skip protocol that's coming, and they're working on really cool positive MEV, which is something that a lot of people have been interested in recently. We have Talus. We have Fan Fury. So if you're a degen and you want to bet on sports, there's that kind of stuff too. I'm not really into that, but you know. We have Raccoon. This is like another gambling one, but I just like the raccoons. They look cool. This is the project I'm probably most excited about, which is Wind. I think a lot of people don't understand this project, but they're actually building next generation DeFi protocols. And the really cool thing about that is they're using a portion of the funds to fund environmental projects. I think it's a really cool model, and they've got like some really great like lending protocol stuff that's coming out. Super stoked for Wind. Oh. We have Juno tools. You want to do an airdrop, you want to upload contracts, you want to like instantiate some base contracts. Beautiful UI to do all that stuff. We have Juno Juicer. You know, I think privacy is important. Like, you should have like privacy. You know, if you want to like send money to account without like people being able to trace it, you should be able to do so. We have that with Cash. We have Stake Easy. There's actually a bunch of liquid staking derivatives that are coming to Juno. I cannot keep track of all of them. But this is one, Stake Easy. It's a liquid staking protocol for Juno. We have, this goes along with like many of the crowdfunding kind of tools that are coming out. So this one's very focused on kind of nonprofits. It's called WeFund. Very cool. We have Margin Protocol, which is a decentralized margin engine. So if you're into margin trading, it's really cool, written in CosmWasm. Oh, and of course we have Juno Swap. It's still cool. And that's just a few. I didn't want to like go on too long, but to name a few. So what's our growth secret? It's just community. It's like the one moat that you have in this industry. Like, this is all open source software. You can easily just copy and paste it, The real moat, the thing you can't copy and paste, is community. And that's a community of like passionate like users, like people that use the dApps, but it's also a community of developers. And one of the great things about not being a VC chain is all the tokens that we would have given to venture capitalists in a pre-sale round, we instead give to people like you, to the builders, to the people that create real value. And surprisingly, like, things have been going pretty well. We just got listed on Kraken, which is a pretty big deal, pretty exciting. But you know, I think some people were getting jealous. Somebody, you know, we got attacked with a 0 day. It could be a really long talk. Happy to talk about any of you about it personally, like afterwards. But you know, I think the key is like we have an amazing community of validators and developers, and they all came together to figure out what the problem was and fix it with pretty minimal downtime, and that's really cool, especially because we don't have like a central company like controlling everything and telling everybody what to do. And I think this is a really great summary of the last 24 hours. It was a really difficult like kind of exploit upstream in the Cosmos SDK. It's tough to catch. We got the instructions and the fix out to validators. We identified the problem and fixed it in less than 10 hours. And I think the key here is Juno is important enough that someone used a potentially like $1 million exploit to fuck with us, you know? That's pretty cool. And, you know, I think that's bullish. I'm bullish on community. I'm bullish on a community of devs and builders. I'm really excited for everything y'all are building. Even if you're not deploying it on Juno, you're part of the Cosmos. Cosmos is family. All right, gotta talk about DAOs. It wouldn't be a Jake talk if we didn't talk about DAOs. So there's this thing, it's called DAO. And what is DAO? Well, it's fully on-chain, no code, modular, and interchain DAO tooling. And this is DogDAO. It's fun. You should all join DogDAO. One dog, one token. So maybe this is a project some people would be interested in working on. Happy to talk with you more later, but we're short on time. I did want to cover just some of the features that the DAO contracts provide. So we have these things called voting power modules. What do voting power modules do? Well, they determine voting power. And the really cool thing is each section is different, so you can recombine these in interesting ways. We already have voting power modules for membership, so like a typical multi-sig that you might have. We have NFT-based voting, that's relatively new. We have token-based voting, both CW20s and native tokens. And we also have staked native tokens. So say, on Osmosis, for example, governance is getting pretty busy. Do we really need to be voting on marketing stuff in the main DAO? What if we have a separate DAO where everyone who's an Osmo staker can go and vote in that kind of side matter, if they really care about it. But then, the main validators don't get as distracted. We're giving people options. Again, these are little governance building blocks. The coolest voting module contract, though, is the mixed voting power contract. So you can actually mix all the different things together. You can have a token-based DAO that, if you have a certain NFT, you get extra voting power, which is pretty cool. So you can create like nice mixes of all these different things. We have custom proposal modules. So we have the normal stuff that you would expect, like a single choice proposal where you yes, no, abstain, veto, but we also have multiple choice proposals. And we have ranked choice voting on the way. And quadratic voting, again, allow you to really easily mix and match, and it's really easy to build your own custom one. We have middleware. I don't think there is other DAO tooling, even in Ethereum, that has like middleware like we do. In large part, it's because CosmWasm is so awesome. It's all based on the actor model. It's all based on message passing. It's really easy to implement middleware. And so some of the middleware we have, we're calling it an approval flow. So say you want to like pass a proposal and then have someone who has to approve it. This is really great for regulatory compliance. I know everyone's really interested in regulatory compliance here. I am. So we have an approval flow. We have an authorizations kind of module, which allows you to basically control spending limits, for example. Like the address can only spend so much money, or it can only perform certain actions. Like maybe you want to have someone trade on behalf of your DAO, and you don't want them to take your money, but you want them to be able to trade for you. So you like allow them to, I don't know, use like a Juno swap contract and swap to like your token to USDC or something like that. But you don't allow them to do anything else. We have hooks, so you can build contracts that like react to everything that happens in DAO. We're going to be launching something with DAO soon called incentivized voting, where you get paid to vote, and it's built with hooks. So, and then the last thing is subDAOs, and this is actually the coolest thing, and it's rolling out probably in like the next 2 weeks or so. SubDAOs allow you to build these really complex structures of DAOs. You can have these nested hierarchies, each with different privileges. It's a really great way to scale an org, to scale a DAO like Juno. And why we built this is because we really needed it. You know, having everyone vote on everything all the time doesn't work. You need smaller groups. You need groups of experts, but you also need to be able to like control everything. And yeah, could talk a lot about it, but you know, gotta move on. I will say that there's something that's gonna happen on August 11th. That's it. So go build on Juno, go build on all your other things. Ethan, I just wanted to address one point. You know, they've got a really awesome tool and it uses WasmD. And as far as I'm concerned as a sponsor, if it's using WasmD for your test code and it's not specifically on the Juno testnet, we can deploy it on the Juno testnet because we use just basic WasmD ourselves. And so you know, I think DME that should be like still eligible if you use like WasmD, but it's not technically on the Juno testnet. We're not protective like that. So go out, use the TS relayer tools. They're really cool. And yeah, any questions or concerns or comments or? All right, I'll get off the stage. So thank you.
All right. How's everybody doing? So I've been here before. I'm Noam again. I'm going to give you a little workshop. It's about an hour, probably, maybe a little longer, about how to build a front end for your CosmJS, your Cosm SDK chain. If you're building your own module, this might be useful. It's nice if you're going to be presenting your work and you're doing a demo and you have some kind of a user interface. I'm sure the judges will love that. This is quite a beginner tutorial. This is pretty easy. This is also really meant for newcomers to the space. If you're familiar with writing in writing a Next.js app or something, you should be able to sort of follow along. There's a MD file that I'm reading from. I don't have a presentation. I just wrote an MD file. That's on this GitHub link. That's just I put it in the HackATOM chat on Telegram. So if you want to read along, just go in Telegram, click on that link that I posted there, and just read along with me. I'll be showing a bunch of code. We'll be building a basic application. So yeah, I'm Noam. I'm a developer. I'm a coordinator. I work at Interchain. I'm also a musician, but I don't do that for Interchain. I'm a developer relations lead. I work on the developer portal, which is where it's like a tutorial page where you can learn everything about the Cosmos. I work on the Interchain Developer Academy, which is a training program that people can sign up for free. I'll tell you more about that at the end. I work on the Cosmos Hub as well as a DevRel, and I am involved with several front-end applications that we're building. So yeah, my goal is basically to get people more excited about using the Cosmos stack, both the users but also the developers. So some context before we begin. There are some really cool things being built. Lately, we've gotten a couple of cool modules coming out, the Auth-Z module, the Groups module, Interchain accounts. The cool thing about these things is that they're really powerful, but nobody's really building like the appropriate, or there's not a lot of front ends for these yet. So interacting with this is actually kind of difficult. You have to use CLI, and I think the thing to make this successful is a great user experience, and so I really encourage people to build front-end interfaces for the blockchain, because the blockchain is a really scary thing, and I think we want to get to a point where people using or interacting with blockchain technology, they don't even know that they're on a blockchain. They should just be using an application. And there's, of course, some really good examples where that's the case already, but yeah, my goal here is to sort of like educate you to get started on doing that yourself. So, what are we going to be building? It's really introductory. Introductory, is that a word? I don't know. It's beginner stuff. We're going to just build a basic front-end application. After this tutorial, you should have basically a simple Next.js app setup that you can expand, and you guys could probably use this maybe as a starting point maybe for your own front-end if you're going to have one. So we're going to set up a Next.js app. We're going to import CosmJS. We're going to connect to the Cosmos Hub testnet. We're going to get some testnet tokens. We're going to connect to Kepler. And we're going to query and display your wallet's balance, and then we're going to send tokens to another address. So I'm actually not that good of a TypeScript developer. I'm going to be straight up honest with you, but I know quite a bit about Cosmos. So my point here is just to sort of like teach you about Cosmos and yeah, get you a little bit up to speed in terms of the CosmJS side of things. So if you want to code along, you need something to code in, obviously, npm. You need a public endpoint, like a node where you can query the data from. We'll talk more about that later. You're going to need the Kepler browser extension installed, and you need to set up a wallet. You also need a Discord account, because we're going to request tokens from the testnet faucet, and you can do that in Discord. So if you don't have a Discord account yet, please sign up now. But if you do have one, make sure you're in the Cosmos Network Discord, and make sure that you're verified so you can get these tokens. So before we get started on that, was there any questions or anything? It's pretty straightforward, I think, right? All right. So we're going to set up a Next.js app. Everyone's done this. So let's just create, where are we anyway? So, disclaimer, this is not my laptop. My laptop isn't working, so yeah, wish me luck, because this might not have what I need installed or anything. So it's going to be very fun little experiment. All right, so we're just going to go, let's just create one right now. Okay, it's going to ask us what we want to call it. I hope it's going to ask us, why is that not working? All right, we're going to have to wait a little bit. The internet's probably not that fast. I think we're on a VPN. It's fetching There you go. We need to install some packages, sure. So if this was my own laptop, we wouldn't have need to install all these packages, but let's go ahead and do it. All right, what's our project name? We're going to call it Cool Cosmos App. And they're setting up basically the Next.js framework for you. Well, while that's loading, I'm going to go in VS Code and open that project, which should be here. I trust the author. The author is myself. And so far, we don't have much yet. Sorry about that. It's the VPN probably being a little slow. Is this readable? It's not that great, eh? You can all read it, or is anyone? Yeah, it's on the Telegram channel, the URL. But I can just tell you. Actually, maybe I can just. How do I make this really large? This is the URL. Gnomesky with 3 O's and then / CosmJS - tutorial. And then there's an instructions MD file in there. Okay, this is going to load. So while this is loading, I'm just going to tell you a little bit about CosmJS, some context before this is downloaded. It's going to be a while. So what does CosmJS really do, right? It does a whole bunch, but the most important stuff is that on the SDK, a lot of the modules, they have their own messages and their own queries. And these are, they become encoded and they become decoded, and they're defined in protobuf. And on the SDK, that's all sort of taken care of. But on JavaScript and TypeScript, you need to sort of the browser needs to understand, or TypeScript needs to understand what's in those messages. Like, how do you decode them? How do you encode them? And what are the variables that are inside that? CosmJS sort of takes care of that. CosmJS is modular. So some modules take care of signing messages for you. Some take care of encoding, cryptography, CosmWasm, and you have a full overview link there. So one of the main modules that you'll be using is called Stargate. This is the module that contains the client that's responsible for signing the messages you'll be sending to the blockchain, for example. Or not just that, but a bunch of other stuff as well. It's called Stargate because that was a very important update about 2 years ago, I think, to the Cosmos Hub that enabled IBC and a bunch of other really important features. You'll be using encoding as well, which handles the encoding and the decoding for the data. Let's see where we're at with this. My lord. I'm going to connect to a faster VPN. Where are we? Let's try this. Yeah, so once again, my apologies. This was supposed to be on my laptop, but the HDMI wasn't working, so let's see what's going on. Maybe I spilled some water on my laptop, I don't know. Thomas, do you mind if I disable your VPN for just a second? Yeah, that's cool. All right, cool. Oh. We're not connected. Okay. Please tell me this is going to be faster now. Well, anyone got some good elevator music? We have to wait. Well, while we wait, I'm just going to tell you a bunch of other stuff. I just want to, maybe extend this offer for I was going to do this later, but I'll do that right now. We have this thing called the Interchain Developer Academy, and that is on academy.cosmos.network. And this is a training program, and we do a couple of those each year, and we accept about 150 students. This is a free training program. It's about 7 weeks. If you're interested in learning more about Cosmos and you have some developer experience, I would recommend you sign up. We have a new cohort starting in September. Basically, this gets you from A to B, from A to Z really with Cosmos. You learn how to build your own chain. You learn how to run a node, how to run a validator. You learn everything about IBC. You learn stuff about CosmJS. you'll learn about using Ignite CLI, which is sort of the tool to bootstrap your blockchain. It's 7 weeks. You get support. There's a whole support team. And at the end, we even sort of like give you an overview of sort of the jobs that are available in the ecosystem. And yeah, the people who graduate, we're trying to sort of like get you in touch with the core contributors who are hiring. So it's a great opportunity. Would recommend anyone who's interested in continuing on the Cosmos path to sign up for sure. And if you know anybody who might be interested, that's cool. We're also very much catering to people who are coming from the Web 2 space. So if you don't know anything about blockchain yet, and you want to learn something, this is pretty much the best way to get started. We'll give you an overview about what blockchain is and what it does and what it's for and how to get started on it. And it's very, very Cosmos focused. That's that. Let's see, why is this not doing anything? There we go, come on. Oh, I'm sorry this is taking so long. Well, in the meanwhile, what I would also recommend is installing Kepler, in case you don't have that. The Kepler wallet is just a browser extension for those who don't know it. I think most people do, but if you're not familiar with Cosmos, this is how you, create a wallet, basically. And there's a few other options as well. There's one for Cosmos Station. There's a couple other ones that are really cool. But this is the one we're going for today. And Kepler has been added, and once you open it, it will ask you to create a wallet. So let's do that real quick. We create a new account. We'll call it Workshop. I guess we need a password. And, oh yeah, we probably need to remember this. Ugh. So let's see. Don't do it like this. But I'll do it like this right now. I think also like when you do these mnemonics, that you can like read them as if they're like your tarot cards, like they predict your future. Like sometimes I do that. I don't know if anyone else does that. I just read them and I wonder what it means. Some Edge brain high recipe, like it's interesting stuff. I should talk to my therapist about that. Syrup, reopen, horn, original, stairs. There we go. We got ourselves a little wallet. Okay, easy stuff, right? So now we have a wallet right here. Yeah, exactly. And we have no money, because that's how it is when you start out in life. Let's see how we are here. I think that, all right, oh, look at that. There's an error. That's not nice. Network connectivity. This is turned off. Why is that a problem? Let's try again. Oh. Let's create another one. All right. Thank God. Please. Well, won't you look at that? Okay, well, let's open that folder. Yes, I trust the author. All right, so here we have a page. Amazing, amazing. Let's get back to it. So now that we have created this Next.js app, let's run the app. Oh. npm run dev. So this will just run the server, and we should now be able to visit localhost. All right, is it 300? Yeah, let's just do that. Boom, this is our website. It doesn't do anything. It's just a template. But we got something great. So instead of like doing any sort of boring markup work, we're just going to copy the code. What I would suggest is you just create a new folder. Oh. Components. Create a new file in that. We'll call it simple UI.tsx. Let's open it. Now let's just be dumb and copy this stuff. Oh. There we go. So this is just a basic user interface. Just sort of like display a balance. It doesn't do anything yet. It doesn't fetch any data. It doesn't do anything. It's just a placeholder so that we can actually get started. So what we want to do is we want to like remove the index.ts that's currently there and replace it with something that actually loads the component. So we go to pages, index. We just remove all this, excuse my French, shit. And then we just replace it with this. Now, what this does, for those who don't know, it just loads the component basically and displays it. So now we have a runtime error, which is amazing. Not something that we want. Why is that happening? Now we don't have a runtime error. Okay, good. Cool. So what do we do next? We have a basic user interface. So this is just like it's going to load the chain ID later. It's going to load your address and your balance, and you're able to send tokens, and you're able to connect to wallet. And this does nothing at the moment. It's really just empty stuff, just a placeholder. All right. Now that we're ready to go, and is anyone following this? Anyone doing this right now? If you are, let me know if you're running into questions. Just raise your hands. In general, if you have questions, just raise your hands, please. All good. So, talked a little bit about CosmJS. We're going to now actually import the right modules. So, we're going to install the Stargate module from the root of our working folder. So, let's go back to that folder while the thing is running. Set a cool Cosmos F2, yep. And we're going to install CosmJS Stargate. Now that that's done, we can import the actual modules at the top of our component. So we go back to the simple UI. We import it here. We save. Nothing breaks yet. Good news. That's it. We've imported CosmJS. Now we want to connect to the Cosmos Hub testnet. So yeah, this is actually kind of an interesting thing that's often, I think this is often overlooked when people are trying to explain how to do stuff with Cosmos, because this is like the beginner stuff that we all think everyone should know, but I know a lot of people actually don't. So newcomers to the space ask, how can I connect to the blockchain? Everyone's just wondering like, oh, well, the blockchain, can I just like request things from the blockchain? But you'll need a node, you need a server. So what is a node? A node is just a server running the binary, the software that runs the chain. A node carries the data that sits on the blockchain and it stays in sync with the chain, block by block. Important to note is that nodes are often pruned. This means, otherwise they would have very large and expensive to maintain sizes. So when you prune a node, this means that they generally don't contain a lot of historical data. They will just like, after a certain amount of blocks, they will say, okay, I don't need this old data anymore. This is in the past. This is important to know because practically this means you can't always ask pruned node things like, what was the balance of this address 5 years ago or even 2 months ago? Because they won't have that data available. You can always ask it, what's the current balance? They will know this. But they might not have the other data available. So a node can do this. A node can be pruned. You can also have all the data if you want, but that's just really expensive. And that's called an archive node. So where can you find these nodes? For the Cosmos Hub testnet, you need to connect to one of these nodes. We have a repo here with a bunch of nodes. You can look at it. I'll be using this one. I'm just going to go ahead and copy that actually already for later. There are some public nodes available for most chains. There's a nice overview here at the chain registry, which is also a repo with just all the chains that are currently out there for Cosmos, or most of them. And they contain, for example, if you look at the Cosmos Hub, they contain a file called chain.json with a bunch of information, but also a bunch of RPC endpoints. These are these nodes that we're going to request data from. But these are public, but they're not meant to be used in production. These are actually used just for development, for testing. If you're going to use them in production, they're going to get too many requests and they're going to go down. So don't use them in production. But it's a good resource if you want to know how to connect to Juno or connect to FMOS or other chains. They're right there. So how do we set up the RPC client at the endpoint in CosmJS? Well, in index.tx, we have, we're passing along basically this variable RPC URL. We're just going to copy and paste the URL to this server. If you actually click on this URL and you go there, you just get a bunch of this stuff. And that's basically how we request things. So you can actually ask, like, what's the status of this node? And then it gives you a whole bunch of information. Let's see. So now we're going to try to get some actual data that we're going to like put on our, in our user interface. So we first have to initialize and then sort of like call this function called getChainID. What this does, it connects with the RPC endpoint with the Stargate client, and then it waits until it gets specifically the chain ID. And then it sets this on as the state as chain ID. So let's just go ahead and copy and paste that. And let's see. We're going to paste that below the constructor here. Where's the, oh. Oopsie. There you go. Save that. And yeah, so this explains how to do it. And we should probably also add a little timeout in case we are waiting too long. So now, when we run it in our browser and we refresh, you see now that Theta testnet 001 is being loaded. That's the chain ID of the Theta testnet. Does anyone have any questions about what just happened? I don't know if anyone's, some people are watching and following, some people are doing the thing. No questions so far? All right, cool. That's how you basically get any sort of data. We just ask the client something. We can do anything here basically. We can say client dot, well, get all balances, or get balance of an address. So we can input an address and a denom. We can ask all kinds of things. Just go like this and you see what's available in this specific client. All right, now that we have data from the chain, let's also make this a little bigger. Now that we have data from the chain, let's get some testnet tokens. Yeah, free Atom basically, but you can't actually use it. So we have Kepler already installed. We have an address created, easy. We're also on Discord. Let me just go ahead and copy my address and go to Discord and go to, go to the Cosmos Hub, Cosmos Network Discord. There is a channel here called Testnet Faucet. We're going to go and request for this address, Theta. We should now, in a while, get a message that we have received some tokens. Great news. Well, how do we know if we received those tokens? Well, you would want to check in Kepler, but surprise, surprise, we don't have the testnet in our Kepler. Kepler only has a bunch of chains that it says these are the ones that we support right now. But Theta isn't in there yet, the Theta testnet for Cosmos Hub. So how do we do that? Well, I built this little tool that does that for you if you're interested, except for some reason it's broken. That's weird. It shouldn't be broken. All right, well, it doesn't matter. We can do it later. But basically, you can add this. You can add a chain to Kepler. So now that we have some testnet tokens, we can do something with it. So let's make that connect wallet button work. So first, we're going to install some of the Kepler modules here that we need, packages. So we copy and paste this in our terminal, in our working directory. And this will install yet another package. And then we have to import this and declare the Kepler window or the interface for that. And we'll do that in our components file again, simpleui.tsx. We'll just put that right here. Oh, and we save this. Cool. Now, we need to tell Kepler what the metadata is of this chain. So we need to tell Kepler, like, hey, the chain is called Theta testnet. This is the endpoint for that, how to talk to it. This is how the address starts. This is, yeah, we won't get into too much detail, but these are the coins, and this is how you understand the coins, and this is how many decimals they have, and there's a whole bunch of stuff that we basically need to copy. So let's add this below the onKepler-clicked function. That should be onKepler-clicked here. Let's add this right here. Easy. This doesn't do anything just yet. This is just like a function that sort of like, passes along the information. So now we need to make sure that when the user clicks on the button Connect Wallet, that it will actually connect the wallet to the application. So we have to replace this onKepler-clicked function. OnKepler-clicked, this is just currently a to-do button, basically. It just we didn't do anything. Let's replace that. And let's look at that real quick. It's real simple. It just says like, hey, there's Kepler. If there's not Kepler, you need to install Kepler. Otherwise, wait. And what it's doing here, this is the cool feature. It says experimental suggest chain. So what this does, it actually says like, if you don't have this chain in your Kepler wallet right now, it will suggest that you add this. So this should work right now. And if we go to our little application and we click on, we refresh just to be sure, we click on Connect Wallet, look at that, chain add request. Localhost would like to add the blockchain theta testnet 001 to Kepler. Let's do it. Cool. This now means that if we go to Kepler, we can click on this little icon to show the chains that exist, and voila, we have theta testnet. And voila, we have 10 atom. It's not real atom, it's testnet atom. But now we can finally see that what the faucet gave us worked. Cool. Now, on to the next step. We will now want to try to query and display the balance of our wallet inside our little application. So, below the experimental suggest chain, we're just going to create a bunch of stuff. Let me just go over that once we're there. Something is going wrong here. Let me just check why. Oh, sorry. My bad. Yeah, sorry, we want to do this, of course, in the function like when you click on Kepler. So that makes sense. So what this does, and there's a few errors and we're going to solve them soon. What this does basically, it creates a signing client. It creates this offline signer, meaning that it creates the signer to sign the actual message. It tries to connect with the RPC URL, and then it asks for the account data. So at the offline signer, it's going to request like, hey, can I get your account, please? Can I get the first account? And then it's going to set the state on your application, which is called my address. It's going to replace that with the actual account address, and then my balance, which is the holding variable for the balance, is going to like request the actual balance using this function get balance, and yeah, put it in there. It's not working because we haven't imported the account data and offline signer from CosmJS yet. So let's go ahead and do that at the top. Save that again. It should run now. And refresh. Let's connect our wallet. Of course, let's approve that. And now we have our balance and our address. Amazing. We can now query all kinds of stuff from the chain. Let's see. I think we're at that stage where we could now actually start sending some tokens to an address. So we're almost there. We're going to replace the onSendClick function to do the following things. So you're going to get the current state of the form and our address. We're going to create the offline signer and signing client, get the account data, submit the transaction, update the balance in the UI. All right, so I'm just going to go ahead and copy and paste this for now, and we'll go over it. Oh, and somehow the dictionary was curious to know what all that meant. Let's see, I onSendClicked. Here we go. So, why is this? Oh yeah, of course. What's wrong? Oh, I think I realize now that I have not done this properly. 1 second. That's just a little thing on my end. Yep. This should work now. Yeah. Cool. Forget about that. But yeah, on synclink, what does it do? All right, so it gets the current state again, and it says like, okay, I need to know what the to amount is. I'm not sure why that's happening. Offline signer again, it connects to the RPC endpoint. It gets the account data. It says like, hey, what's the account again? And then it creates this transaction. So you have this transaction called send tokens, and send tokens requests an address, a to address, and an amount, or like a coin actually. And a coin is basically just a type that contains an amount, and, sorry, that's not true. It requests the coin here, basically, and then it also requests like the gas and how much you're paying for that. We just input that basically based on the account that we're fetching and on the state of the form, basically. After that, after that send result, it's sort of like it sends it to the signing client, and we get the result here into send result. We can print the send result into our log, into our console, so we can see what happens. After that, we set the state and we update the balance, so we make sure that the balance is still quite there. So this should work, and we're just going to go ahead and try this. The real question is, where are we going to send it to? Well, if this was my computer, I would select an address, but maybe we can just send it back to the faucet so that the faucet doesn't run dry. So we're just going to use this as an input address to send tokens to. So let's make sure we connect to our wallet again. Here we go, we have our wallet. We have this address that we input. Let's send it a bunch of tokens. And let's see, for example, like, remember how much we have? We have 10 ATOM right now. So we're going to send it not 2 million ATOM, but 2 million U ATOM. For those who don't know, U ATOM is just basically, what is it, a millionth of an atom. That's how it works. So when we click send, we're going to get this pop-up, and it says, this address that we just input will receive 2 ATOM. Cool, let's do it. And then we wait. Shouldn't take long. We can already see here on the right, and forget about this warning, we can already see on the right here that we're getting our result. We can actually look into this result, and we can see, oh, this is the amount of gas that's been used. This is the height of the block that it got into. This is the raw log of the actual transaction. And we can go quite deep into it. You can do all kinds of stuff with that, but it's not really important right now. What's important is that we just sent 2 ATOM, but we're also missing 0.2 ATOM. Why is that? We use that for gas fee. That's it. That's how you send a token over Kepler, over in a front end, and that's how you fetch data, and that's how you use Kepler. It's real simple. I know for a lot of you probably this was too simple, but I hope that for some people that was very useful, and I hope for the people watching later also that this is a great introductory to getting started with this kind of stuff. So we have some final thoughts here, right? Now we have a Next.js application. We're able to query data from a chain. We're able to display a balance. We're able to send tokens to people. What's next? Well, if you're using CosmWasm, you might want to interact with CosmWasm contracts. For that, one of the recommended ways to do that is to use CosmWasm.js. There's a couple other solutions. Some chains have their own solutions as well. You want to look into that. I'm not sure. Milan will probably be here tomorrow. I think he'd be pretty good for you to help you out if you have any questions about that. I know that there's a bunch of other people here that might be useful as well. So the other thing, if you're building your own SDK module and you're building your own custom sort of like application, it will have its own messages. It will have its own queries. But CosmJS won't understand that. You need to tell it, hey, these are the messages, these are the protobuf files, these are the types that you need. There's a couple ways to do it. Dan Lynch over here made this beautiful tool called Telescope. And basically what that does, it looks into the proto files of your module and it generates these types for you. So I would very much recommend you use that tool if possible. There's also another way to do it, which is a bit more manual, and that's set up on the developer portal. You can have a look at that if you follow this link. So yeah, once again, if you like this stuff, if you're into it, we have this training program. It's about 7 weeks long. We do it a couple times a year. Please sign up if you're interested. Want to check also for the last very minute, like, does anyone have any specific questions or anything they want to ask right now? Because this is pretty much the end of my workshop. So any questions for anybody? All right, so that means I had, oh, one question. All right, go ahead.
So if you send tokens to a smart contract, it will be different process.
Yeah, so you would have, actually, I'm not entirely sure with CosmWasm, because on Ethereum you would send tokens to a smart contract. I guess with CosmWasm you do the same. The send tokens doesn't matter. You can send tokens anywhere. I'm not entirely sure. You should check with Ethan, but I think CosmWasm contracts can have an account. But if you want to do something with the contract itself, that's different. So if you want to like actually interact with the contract, interface with that, that's a different process. And you will need the CosmJS, CosmWasm.js, for example, or some other way to interface with that. Yeah. Does that answer your question? Cool. Anything else? Great. Well, I wish you all so much fun. If there's any questions, please let me know. And thank you so much for your time.
Okay. Hello, everyone. My name is Rafa, and I work at Interchain, and I'm part of the ecosystem growth team. And I'm maybe one of the few presentations that isn't necessarily code. It's going to be brief, but I think it should be very helpful for teams like you who are building in Cosmos. And the Builders program was launched a few weeks ago. Doesn't work. Okay, now it does. Cool. So the Builders program was launched a few weeks ago, and it's funded by ICF, the foundation. And it's a public good, and the idea is that we want to help developers be successful in the ecosystem. So I want to present you what the program is, what our mission is, how it works, the structure, and what kind of teams are very suitable for this. It's going to be quick, but I think it's a resource that any developer, any team that is developing in Cosmos can go for, can use, and can take advantage of. So launching a chain or a project in crypto is sometimes difficult. It is painful sometimes. You think, you draft your white paper and you think you're going to be the next unicorn crypto, and then one day before you're launching, you think you're going to go to jail. Like you're scared that you're going to have legal problems. It's a bumpy road. There's so many decisions that you can take at the very beginning that are going to have a huge impact down the road, right? It's hard. It's just really hard to build. And we feel right now in the ecosystem there aren't enough resources that are helping entrepreneurs, developers, not just to build, but also to sell, to architect products, to market, define your go-to-market strategy, your community strategy, your governance strategy. There is a lot involved in launching one of these projects, and we just want to be there for you. We just want to be helpful. And that's our mission. In the sense that our mandate in the Cosmos ecosystem is growing the ecosystem, right? Cosmos wants to be the interchain of blockchains, internet of blockchains, excuse me, and we want to be part of that growth. So our team runs initiatives to accelerate that growth, right? And the Builders program is essentially one of those initiatives. Imagine it as an incubator or as an accelerator, but for free. Like right now, we don't take any equity, we don't take any tokens from you, but we give you the help that normally an accelerator would, right? Think Techsters, think YC, and all the help they give their companies. We do that for you, but for free. So who is the Builders program for? Right now, we're targeting new and existing chains in Cosmos. So if you're planning to build a chain or already know somebody who's building a chain, the program might be for you. If you're building a dApp on top of any Cosmos chain, we can also help you. We have relationships to all the chains in the ecosystem, so we can be that window into the ecosystem for you, right? Regardless if you're a chain or if you're a dApp on an existing chain. And also, we are very focused on bringing dApps and chains outside Cosmos into the ecosystem, right? So if you have experience on Ethereum, or you've built something on Ethereum or somewhere else, and you want to bring it to Cosmos, we can also help with that. The program is designed in a way that we have verticals. So, we know that you're also building a company, right? Not just a chain or a dApp. So we know there are a bunch of verticals involved in that process. So we can help you with incorporation and fundraising, between giving you recommendations on how to set up your legal process or your legal entities, issue your token, but also connect you with investors, tell you what the fundraising strategy should be, what the mechanisms are so that you understand them. We'll help you with the tokenomics and distribution. We'll give you token checklists, token economics models, templates that you can run yourself, everything for free. Technical and product support. Our team consists of a variety of Interchain members, including the Cosmos SDK lead, for example. So we have access to technical resources within Interchain that we can connect you to and help you on the product and technical design. We'll help you then define your community and governance strategy as well. Marketing and go-to-market strategy. If you're doing B2B or want to do a B2C marketing strategy, again, we'll help you with that. We have templates for that. We have workshops for that. And something very important to emphasize here on is that we'll help you on a one-to-one basis. We want to, right now, especially we're doing on a one-to-one basis, so we'll have a relationship with you. There's a lot of our content that also scales for a lot of teams at the same time, but right now we're doing this on a very high-touch basis, and I think that's really good, especially right now, so that you have a direct relationship with us and with the ecosystem at the same time. Then there's a lot here in this slide, but the 6 verticals that we have, basically the way we structure the program is that each one of them has different modules. So depending on what your strengths are, the expertise of your team is, you can opt in to any of these modules and we'll help you with them, just like that. Just imagine a team selecting those individual modules, right? A team that there are teams right now that we're working with that, for instance, only need help on one of these verticals. Normally in practice, teams are picking one or the other vertical more than a little bit everywhere. But right now, I think our most popular one, just more of an FYI, are like incorporation, fundraising. There's a lot of teams asking for that. Tokenomics and distribution as well, but also on the technical support vertical. And just to mention a few things more, like if you're building a chain, for example, we have connections to validators. We'll help you bootstrap your validator set. Help you with find auditors, the exchanges if you want to list your token. So everything that a crypto project nowadays consists of, sort of like we have you covered, right? Of course, we're better at some things than others. We just launched it, we're getting better. But again, this, for developers like you especially, I think is a program that has a lot of value. The way the process or the program are being executed right now is, we'll call it the milestone-based program. So right now, you can submit an application to the program, and you'll go through the onboarding phase. Every team goes through the onboarding phase. We're not rejecting anybody, let's say, before the onboarding. So you'll have an introductory call with us. We'll assess your projects. We'll give you some recommendation in the evaluation, and we'll deep dive a little bit into your project. And then we'll decide if you get into the program. Once you are in the program, together with you and your team, we'll define specific milestones for you, depending on what your needs are. If you only need help on incorporation, maybe that's just a few months. If you need help with all of the verticals, that's maybe a year or more. And we'll define those milestones to you, and we'll map the modules that you opted in for to those specific milestones, right? So it's a very practical program. The cadence and the relationship varies depending on your needs, right? Some of the teams we're having weekly calls with, some of the teams we're having monthly touch points with, some of the teams we're just having conversations via Slack. So it varies. And right now we're very flexible. Again, we're starting, we see what works best. And again, just emphasizing the fact that this is a huge asset funded by ICF that I think every team should be taking advantage of. And just a few of the things that we provided, I mentioned at the beginning, but you know, a checklist for all your tokens. Like we have checklists for everything, like how your pitch deck should look like, how your tokenomics should look like, how your go-to-market strategy should look like, your community strategy should look like. We have this model, we build this template of tokenomics for you that's for free, basically, where you can set up your parameters and see how your tokenomics models differ, change, and look over time. And most importantly, we have this thing called the Knowledge Hub, which we haven't open sourced yet, but it's coming soon. And we're just open sourcing all of the content that we're putting together during this program and before, so that anybody can access it. In a way, that will mean that any developer, not only if you're in the program, but any developer will have access to all of this content, at least in written form, a few videos, etc. But yeah, so that's the Builders program. Right now, it's a team of 4 that manages the program specifically, but again, we also have relationship to the whole ecosystem, right? So if you're a team, for instance, that's building on Interchain security, we have direct access to developers on Informal who are building this and can help you with, and we can channel that help. We have access to validators. So it's the 4 of us right now managing, but again, it's pretty much you having access to the whole ecosystem in a structured, systematic way. We've gotten over 50 applications just in a few weeks, which is more than we can handle actually. So I encourage you, if you're interested in this, to apply as soon as possible, or after the hackathon, if you're interested in really building something out of this. And we'll announce, we'll be a little bit more loud in the next few weeks about who the teams that we're supporting are, how we work. And like I said, we're open sourcing everything that we're doing that's consumable, at least in the next few months as well. So yeah, you can go to join.builders. That's our website. There's a form there that you can apply through. We'll get back to you probably in the next 48 hours after your application. I think you can schedule a call right in the application response emails that we send. But I invite you, any of you who are interested in being part or being a team, part of the Cosmos ecosystem, to apply to the Builders program. Again, right now, it's for free. Take advantage of it. Also, I forgot to mention that there are a bunch of teams that are developing dApps here that also want to connect to other dApps that build on top of them, etc. So you'll get access to all of the Builders program batches that come in, right? So you'll have direct access to developers that maybe you want to sell to, or that you want to partner with. So in a way, being part of the Builders program is also being part of our community, right? A community of new developers that's growing and it's coming to Cosmos. So thank you very much. If you have any questions, I'll be around. If you want to speak Spanish a little bit, so you prepare for Cosmoverse, let me know. But yeah, thank you very much for your attention, and looking forward to seeing what you guys are building.
Hello. Hi, everybody. I just want to jump in right away and say Interchain security is almost here, and it's going to be awesome. Okay. So, my name is Daniel Tisdall. I'm here today, very happy to be in Seoul. And today I'm going to be presenting Interchain security, a new upcoming feature for the Cosmos Hub. Interchain security is going to let you launch new blockchains into the Cosmos. It's going to let you scale horizontally while sharing security from the Cosmos Hub, which is a multi-billion-dollar market capitalization chain with a global community. In short, Interchain security lets you launch arbitrary high-performance app logic safely, securely, and easily. So first of all, before I jump into the presentation proper, a little bit about myself. So I'm here today with my colleague Jelena from Informal Systems. We're a globally distributed organization, and we're core developers of Cosmos. What does that mean? We develop applications, tools, and services for improving dev velocity, testing, and confidence of applications for blockchains in general and for Cosmos blockchains especially. We contribute to infrastructure, so we're running validators, relayers, and we're also contributing to Rust implementations of Tendermint and the Hermes relayer. Finally, we're also core contributors now to the Cosmos Hub too, and that's the team that I'm a part of. Okay, so today's talk format. My session is going to consist of two parts, a talk part and more of like a hands-on demo workshop part. So part one, I'm going to be starting fairly basic with Cosmos, blockchains, how everything works, how the stack works. So proof-of-stake blockchains, Cosmos, the Cosmos ecosystem, going through the stack, Tendermint, the SDK, and the relayer, relaying packets with Hermes, our Rust relayer, and then Interchain security, of course. For part two, I'll be getting more into the why of Interchain security, why it's necessary, and why it's such an important feature. I'm going to be showing you how to launch custom app chains, which can benefit from the multi-billion-dollar market capitalization, and how you can leverage Interchain security to launch completely custom app logic with your own governance, your own tokenomics, and your own gas economics. I'm also going to be showing you a bit about how it works, so going into some details of the protocol. For the workshop part, I'll be showing a live demo of two participating chains. I'm going to be showing you how to debug and observe the system. I'll show you how to develop your own consumer chain. I'll be doing a code dive and then answering some questions. So let's get into it. Okay, so many of you are very highly technical. You've been in blockchain for a while, but others have not. So what is a blockchain? It's a series of blocks which contain state about the application. Okay? So over time, new blocks are published into the network, and each block contains some data about the state of the application. And it also contains a link to the previous block, a cryptographic hash. So in this case, in this example that you see now, we have the first block, Alice, has $5. The second block, Alice has $9, and we can see in the second block there is a link with an arrow to the previous block. So this is as simple as a blockchain gets, and what does it mean? It means you cannot go back in time and rewrite history once the blockchain has progressed sufficiently far. So what is proof of stake? Proof of stake is a mechanism for showing that you have some skin in the game that is going to allow you to participate in telling the blockchain what happens next. So there's two ways currently in the blockchain world, two popular ways to actually write new state into the system. Proof of work and proof of stake. And both of them require you to prove that you have something that others don't, which means you have skin in the game, and you're allowed to decide the next transition. So proof of stake is the mechanism that Cosmos uses. And what does it mean? So proof of stake uses the actual cryptocurrency itself as the voting mechanism. So the more stake you have, the more likely you are to be able to vote on the next transition of the system. What we see here in this image is a list of what's called validators, and this is the top 11 validators as of yesterday who were validating the Cosmos Hub chain. So we can see the list here, and the cumulative share of voting power. So voting power is derived from the number of tokens which are staked to that validator. So each of these is an organization, a company, or an individual, who can be anonymous or not, who has been delegated to by the community, by you, by individuals, by institutions, to have skin in the game and to decide what happens next in the blockchain. We can see that the cumulative share increases as we descend down the list. So for example, stake.fish has roughly 6% of the tokens delegated in the system. And one crucial thing about proof-of-stake chains is that you need a cohort of agreeing validators with a certain percentage of voting share to decide what happens next. So due to the way the Tendermint consensus protocol, which is the part of the system that decides, which coordinates these validators and decides what happens next, it's required to have 2/3 of the voting power, or 2/3 cumulative share, so 67%, to decide what happens next. So we see that that takes, in this case, significantly more than 11 validators, because here we have 48%. So we've talked about proof of stake, but what does it actually mean if you're developing? How can it help you think about blockchains in maybe like a higher level way and not worry about the details? So it really means it's a computer that you vote on. And because the state machines are completely arbitrary, albeit deterministic, you can think of a blockchain as really a global computer or a collection of global computers that are voted on. So it's like it's just like voting in an election. You vote for what happens on the computer. So the computer can be anything. It can be, maybe we'll see they're as powerful as, you can have as much computation on chain as you can on a MacBook nowadays. And in this slide, I show you the reality. So this is obviously simplified, this Alice dollars example, but here we're seeing the reality of the state on the chain when using a Tendermint system. So we can see we have the same thing here. This app state is like the application state, so Alice has $7. And here we have some changes in the validator set. So this is really, it's these changes in the validator set that happen block by block as different validators lose and gain tokens that decide who votes next on the next block. So over time, the voting set changes. And this is quite crucial for interchain security because it's exactly these changes which are transmitted cross-chain and allows the crucial features of interchain security, which are shared security and scalability, horizontal scalability. Okay, so we've talked about proof of stake, we've talked about blockchains, now Cosmos. So you're at a Cosmos hackathon. I'm guessing you know a lot, but maybe not everyone does. So Cosmos refers to a few things, but it's mainly talking about an ecosystem. So it's an ecosystem which is using Tendermint consensus. It's an ecosystem by and large that's using the Cosmos SDK, so the source development kit. And it's an ecosystem of many chains communicating through IBC, which is your inter-blockchain communication. So we can see here from this website Map of Zones, Cosmos, the many popular chains in the Cosmos network, by no means all of them, and each of these links is an IBC connection. So the brighter the link, the more application packets are being sent. So in this one, Cosmos Hub is the selected network, so we can see who is communicating with the Cosmos Hub. Okay, so now I'm going to go a bit into the stack. So we can see a layer of validators at the bottom, which are, as I said before, individuals, institutions, DAOs, and they are deciding what happens by running hardware, of course. So they can be doing this on their Raspberry Pi, although unlikely, or they could be doing it in cloud or in, I don't know, a back room somewhere. Above that, we have Tendermint, which is the consensus layer that organizes the validators. So it decides, it allows the validators to communicate in an ordered way to eventually come to an agreement, to come to a consensus. And the crucial thing about Tendermint is it's communicating with the SDK to learn the voting power of the validators to get this Byzantine fault tolerance that you probably heard about. Above Tendermint, we have the SDK. So this is your application layer. So this can be coded in Golang using the source development kit. You know, we can see even on top of this, although not pictured here, you have things like CosmWasm. There's many ways to kind of have this interaction between your application and Tendermint. And then finally on top, we have the IBC layer, inter-blockchain communication, which is what's giving you all the power to do the cross-chain applications that Cosmos is becoming so well known for and is doing so well in. So IBC lets you establish connections and channels with other chains, and it lets you do arbitrary communication between those chains, just like how you make a TCP connection when you connect to a website. So now I'm going to dive like a little bit into each layer of this stack to tell you like how each part works in more detail. So we have the Tendermint stack. We can see here each of these black disks, roughly corresponds to one of these black validator disks. And what we have here is 4 nodes, which are communicating via this represented with a hexagon P2P layer. So this is kind of the agreement layer. We can zoom in on this a little bit and see what's taking place in a 4 node. So a 4 node is the name of a group of processes which can be run on one machine or multiple. In theory, I think mostly they're run on a single machine, off in the cloud somewhere. And you have 3 components. So you have the actual application written with the SDK. This is doing your app logic. This is transferring money between accounts, etc. You have Tendermint core, which is the extremely high performance layer which is doing the consensus and answering queries. Tendermint core consists of an RPC receptor to take messages and add them to the mempool or answer queries. A P2P endpoint, which is going to allow the gossip protocols, which are needed for consensus, and then a signing part, which allows you to use cryptographic signatures to sign messages so that nobody else can act on your behalf without your permission. Okay, so that was Tendermint and the validators. Now we can go up slightly to Tendermint and the SDK. So you may have seen this diagram before or a similar one. And what this is showing is the connection between your state machine or application built with the SDK and your consensus layer, which is part of Tendermint core, which was that green rectangle we saw before. And the crucial part here is this ABCI, so Application Blockchain Interface. It's the name of a pattern of message passing between Tendermint and the SDK, which is going to bundle transactions. So it's going to bundle messages sent from members of the public into the mempool. It's going to order them, and it's going to send them, once agreed on, into the state machine to execute the next transition and make something happen on chain, right? So this is now a picture of ABCI. So what happens in a block? You receive, this is now, you can imagine this happening on one node, so this may be happening on a single piece of hardware. And this is done by each validator. So when a block is received by this validator, so a new block in the chain, the block's received, there's a call to begin block in the SDK, which is going to give your application a chance to do anything it might want to do on a regular basis, right? So not based on a particular transaction, but something based on, for example, time, timeouts, just general cleanup, that kind of thing. And then you have a series of deliver TX calls, which are going to take the transactions which are bundled into a block and submit them one by one in sequential synchronous order to the application to make changes on the state machine. Following this, you have an end block, which is similar to begin block, The difference is mblock needs to also send the new voting powers as decided by application logic to Tendermint to allow Tendermint to decide which validators are going to vote for the next block. Commit is basically the code that signals everything is finished. It's going to write things to disk. At that point, the block is concretely stuck forever, essentially. So what's so special about the Cosmos SDK, and why are people writing so many applications using it? Well, you may notice already if you've been doing it yourself for a while, but it's simple. It's not written in Haskell, it's written in Go. It's easy for people to understand. The code is straightforward. There's no reinventing the wheel. You don't necessarily even need to know about blockchains to use it because of this ABCI. You just handle transactions. And there's a lot of documentation. There's a massive community around it. It's modular, so it consists of a series of modules which you can include or not include as you wish. In practice, we see that many of these are included in most projects, staking module, for example, slashing. But in principle, you're free to do as you want with these, and we're seeing cool modules come out all the time, right? So interchain accounts was already talked about. There's things like this. And of course, interchain security. So it's customizable due to this modularity and simplicity. It's easy to get in there to hack things, change things, swap things in and out. So that's why Cosmos is so great, I guess. So just to give you an idea, to make that a bit more concrete, what are these modules that you may include? Here's a small list. This is by no means all of them, not even the default set. So you have auth-z, which is a module which lets you delegate specific actions to accounts so that other accounts can do actions on your behalf. Okay, so this is kind of like an equivalent example on Ethereum would be like you submit to a smart contract, and then after that, the smart contract has the ability to send money on your behalf. You have bank, which is the module that actually stores account balances. Distribution, which is the module which takes rewards from validators and from validation and sends them to validators. You have evidence. So evidence is a very important one, although hopefully you won't see it being used too much because it's dealing with bad behavior. So when a validator is included in the active set, but they're not actually doing work, so for example, it would be great for a validator if they could be included in the set and not actually pay any compute on AWS to do any work, right? But evidence prevents them from doing that because if they do that, they will be penalized for downtime. So that's the evidence module. We have governance. So governance is what's allowing all these DAOs, it's what's allowing proposals, it's what's allowing the chain to migrate in ways beyond the normal transactions programmed on chain. So governance is mostly using voting power to decide on major things like upgrades, like reverting transactions, this kind of thing. And crucially for interchain security, it's through governance that you allow what we call a provider chain, so the Cosmos Hub, to take on a new chain and give that chain security and scalability. We have the mint module, which is the module that creates new tokens from nothing and burns them. We have slashing, which interacts closely with staking and evidence, and is the module that's responsible for burning validator tokens when they do one of the misbehaviors described earlier. The staking module is what you will know if you've ever delegated. So when you do an action like delegate, redelegate, or undelegate to a validator, it's the staking module that handles that logic. It's the staking module that gives you your refund after the unbundling period has completed. And it's the staking module that changes the balances of the validators based on the number of delegations they have. Upgrade, I'm not personally actually too familiar with it. I'm guessing it's the one that does the chain version upgrades. Okay, so we've talked about the SDK and some of its modularity. Now let's get to IBC. So as I said before, IBC is very generic transportation protocol. And it lets you send packets one by one in sequential, so ordered or unordered order as you wish. And it requires what's known as a relayer. So chains do not actually open a network connection to each other. What they do is when a packet is sent, that packet is written to the block state, and then it's an external service called a relayer that observes this commitment of the packet and forwards it to the chain that the packet is addressed to. So the relayer is depicted with this red diamond. We can see the packet is not really sent, but is more committed to chain A. The relayer sees it and forwards it. So the relayer is just like Tendermint, just like to some extent the application layer, a piece that is really computationally expensive because you can quickly, the words on the tip of my tongue, you can quickly absorb all available bandwidth, like on CPU, also like I/O, network I/O on a relayer. So this is something that's really important to get good performance on. At Informal Systems, we have a team developing the Hermes relayer, which is a high-performance Rust implementation, which I hear is also becoming kind of the most popular in the ecosystem these days. So please check that out if you ever want to be doing some relaying. And don't forget, you can reap rewards and fees for relaying too. This is a small code snippet that shows you how you might set up Hermes. So you need to specify some keys to pay fees. No one works for free, right? Once you've done that, you can create a connection between two chains. So in this case, we're creating a connection from chain A to chain B. And we have this client field is the name of the type of light client used. So a light client is a piece of logic that runs on the relay node itself and also on chain that allows you to trust blocks when they come in. So you cannot, if you ask the network for a blockchain block, you need some way of knowing that it's one that's actually on the blockchain, right? But you don't want to do that by downloading the entire blockchain from the first block, because there's a block every 5 seconds, so this will take a while. So what a light client does is it can use like a binary search to bisect the list of blocks, starting from a trusted header, and this allows you to accept new headers, new packets, without downloading the whole chain. Once you've created a connection, which you can imagine is kind of, this is kind of like, on the internet it would be like someone has found a route for your packet. So this is like kind of like knowing the route for your packet and saying that route's okay. So both sides agree this is an okay route to use. And the channel is now the component that lets you communicate between different modules, different SDK modules, right? So you create a channel and you specify ports, and then in your application you can route ports to different modules, different message handlers. So you could have many channels between even two chains. In this way you can have different channels for different purposes, and different types of channels, so ordered and unordered channels too. And then we have Hermes start, which is going to actually start the relaying process and quickly absorb all your CPU, I imagine. Okay, so why was that interesting? Mostly to give anyone who's newer a kind of overview and an insight into why it matters that we're doing interchain security. So I said it once. Interchain security is going to give you a way to launch completely arbitrary, custom, and creative high-performance app chains safely, securely, and easily. So it addresses two goals, two problems which are kind of not addressed sufficiently by any existing solution in the ecosystem. So we have, let's say, two major problems we're solving. Sharding, which is this scalability concern. So sharding is a kind of term for breaking your application into multiple pieces so that concerns are separated and the actual computation can have more scalability. So if you shard your your application or your applications or your system of applications, this allows developers to develop on each piece by piece, and it allows you to utilize different hardware, even more importantly, to get more scalability. So why is this a problem? So we're seeing that on chains like the Cosmos Hub, we have a lot of people trying to make proposals, trying to get things running on the hub. But don't forget, every piece of code that's running on the hub is actually taking up some kind of CPU cost, right? So if there was a way to kind of share this computation among different hardware, among different data centers, that's a net win. And in this manner, if you do this successfully, you can scale unlimited. And it's horizontal scaling, so it's nearly unlimited. You may just need some coordination. Security, what else? We're seeing a big problem with security. As I said before, you need this validator set with some skin in the game to prevent an attack. So due to the way the voting, so Tendermint consensus works, it's possible to dictate what happens on the chain if you have 67% or more of the tokens or the cryptocurrency on chain. So this clearly is not, it doesn't matter if your chain market cap is billions of dollars, but if you're a new developer and you're trying to make a fun app or even a very serious, important economic application, it can be very hard to bootstrap this network in a fair way so that you don't have already this problem of the rich getting richer, and especially the problem of the low market cap, which might make you susceptible to institutional attackers with a few $100 million to spare to attack your chain. So Interchain Security is really tackling these two problems. So what are we getting? We're getting sharding with shared security. So we have one solution to solve two problems. I'm going to go more into why this is so important and some downsides and problems with the current approaches to solving this. So let's talk about sharding. So what is happening for, security actually. So what is happening right now is we have chains being created, and they're having a really hard time to fairly allocate these tokens, right? So a common way to do this is a stake drop or an airdrop, where they're taking a snapshot of another chain, and they're essentially they're dropping tokens in the genesis to people who already have a lot of tokens on other chains. So this is a rich get richer problem, and it's also a low security problem, right? We're also seeing, it's very difficult for people new to the space to get in on the action, let's say. We have these established ecosystems, these established communities and networks, these established connections between people who know each other, and they're mostly all interacting with the dominant established chains, right? So for example, the Cosmos Hub, Osmosis, Juno. This makes it very hard for people to get on board, and especially to get validators who are professional companies, professional DAOs, to actually take on their chain and do the work of validating their chain to run the chain. So what we're having here is an incentive alignment problem. There's no incentive necessarily for a validator to take on work on your chain. They're betting on your project, essentially. So shared security, interchain security is removing the need for validators to bet, because the design of the system means they will be validating on your chain, but you will be getting the security of the Cosmos Hub, and of course there's a cost for that security. You'll be giving some rewards or fees to the validators, so it's a win-win. You get security, the validators are getting rewards in the form of tokens. So let's see an example where this has gone wrong in the past. So the infamous Proposal 16 from Juno, there was a stake drop within the last couple of months. And if you've heard the story, it was gamed. There was an individual account who received an outsized number of tokens, which really was damaging for the economy. And there was a very contentious vote to decide how to deal with this situation, which resulted in, so this vote you see here is a vote to to basically undo that allocation of tokens to that individual. So you can see just by the number of no votes, this is a contentious issue which just completely disappears with interchain security. Okay, now, scaling. So, I'm just gonna take a break for a sec. Okay, so I've talked about security, now about scaling. Why does interchain security let you scale, and why is no existing solution sufficient? So as I said before, we have a lot of people trying to get computation on chain, and all of that computation is utilizing CPU, right? This cannot scale forever, clearly, and it's the reason for why, for example, Ethereum gas fees are so high. Ethereum's running thousands of smart contracts, and the reason gas fees are so high is because you're bidding up the price of computation. You need to bid for computation. So if we can horizontally scale to multiple machines, aside from coordination, you have unlimited scalability in this way. So yeah, we can see an example of why this is needed. There was a proposal to get smart contracts from CosmWasm onto the Cosmos Hub, and this, of course, was predicted to lead to the same situation as Ethereum, so it's going to bid up fees massively and just increase the workload for validators. And the proposal didn't go through, as you can see. So it's clear from both of these examples that the existing solutions are not sufficient. So we think we can do better. With interchain security, you get both of these. You get scalability and security. And so I have some examples. So the feature is about to release. We have a lot of people about to join. Just two of many examples. We have Quicksilver, which is a new liquid staking token, new liquid staking project. And they have said they are going to be using interchain security. In this way, they avoid the problem I mentioned earlier about bootstrapping a fresh validator set. And we have plans for a consumer chain. So a consumer chain for CosmWasm. So instead of having to take smart contracts onto the Cosmos Hub itself and utilize even more CPU, we can create an entirely new chain or chains running CosmWasm contracts, which can have their own economic models for how they take bids for gas and how they run smart contracts. So why are these guys signing up? Well, it's clear they get the security, they get the scalability, and they get the community of the Cosmos Hub. So I want to make very clear that interchain security is very much an infrastructure layer. It should be invisible for you, for users who are creating new apps, new blockchains. It doesn't restrict you. In fact, it frees you up. You can design whatever kind of tokenomics you like. You can design whatever kind of gas economics you like, whatever kind of auctioning you like, whatever kind of staking rewards you like, whatever kind of governance you like. So it should be a completely invisible layer. Okay, so let's see an example. We have our example with, this is a custom consumer chain. So this is imagining the scenario of someone coming, and they're not going to be using the defaults. They want to do everything themselves, right? We can see that this user, this developer, this organization has elected to have their own native token. Of course, you can do that. You don't need to use Atom. You can create your own token or tokens. Okay, so they've decided their gas model is going to be paying gas fees in their native token. They're going to have inflation, which is what we see already in practice in many chains. And how it works is, of course, as I said before, it doesn't come for free. They will do an airdrop to validators and delegators. So in this way, the validators are rewarded, and every individual who delegates to those validators are rewarded. They're going to have in-protocol actions such as voting, liquidity pooling, etc. So completely custom chain without this bootstrapping problem and with high scalability. There's also plans in the works with smart contracts. So we're going to be launching right after V1, so immediately, with a contract chains, so CosmWasm chains. The default here might be for users to pay gas fees in atoms. Okay, that makes things predictable. It gives a common market. It's connecting to the existing community. As before, hub delegators and validators are getting rewards for their work. And we're seeing that the fees can be sent directly to the community pool to help with governance, to decide the kind of progression of the distributed organization. So it's really a layer, Interchain security is really a layer that lets you be creative. It doesn't put restrictions on you. And we have many projects shipping soon, which are going to come with some custom defaults or allow you to, example, put smart contracts straight on there. Okay, so now I'm going to go a bit into the protocol and how it works. Just you guys are technical guys. I think you might find this interesting, and it might help you develop your own consumer chain. Okay, so I've said before that what this is allowing validators from the hub to validate on other chains and get rewards for that. So the way the protocol works is you have two chains running completely separately, or it's more like a spoke model. It happens that two chains are drawn here. So you have a provider chain, the Cosmos Hub, and you have one or more consumer chains which are sharing security from the hub via this way of sharing validator voting power between the chains via IBC. So in this way, we can see the two stacks here, and notice the validators are shared here. So I'd like to emphasize, this does not mean the validators must be running the two chains in the same place. They can be in data centers across the world. The only thing that's needed here is some cryptographic relation, right, to prove that the validators are the same, so some private key, ultimately. And how the protocol works is when validator voting power changes on the Cosmos Hub due to delegations, undelegations, slashing, the updates are shipped to the consumer chains, so broadcast to the consumer chains, and it's these updates which are received and stored on the consumer chain and transmitted to the own instance of tendermint of the consumer chain. So what's here is kind of an implementation detail, let's say. So this is the unbonding completions. This is important because you may have noticed if you've ever tried to undelegate, you have to wait a while. So you have to wait 3 weeks to get your tokens back once you undelegate. So this is intentional because it means you have skin in the game for a while, and it means you can be punished. It stops the situation of misbehavior and then undelegating and then not being punished for that misbehavior once it's detected, right? So that's what this unbonding period is for. And this is very important because it's the skin in the game on the provider chain, so on the Cosmos Hub, that's really powering the security of the consumer chains. So what this unbonding completion is about making sure you cannot completely unbond everything on the Cosmos Hub before you've also unbonded your voting power from the consumer chains. So in practice, this is an implementation detail. You won't see it because this unbonding time is going to be set, a day less than the unbonding time for the provider chain. So this is kind of implementation. Yeah, let's dive into this a little bit more. So when you bond tokens, you receive voting power, and it's consumer validators, so the same validator set, although different hardware, that's doing the voting and collecting rewards. So the rewards can be in the form of native tokens on the consumer chains, or atoms, or any combination you can think of. So the only thing that's important here is the incentive alignment. So how are you going to convince validators to validate on your chain? Presumably, they will be interested in some kind of reward. But this is really up to you to decide economically, and it's up to the community and the validators to accept your proposal and to accept it. So this leaves a lot of room for customization. And bad behavior on the consumer chains. So the security, the way the security works is the validators are going to be punished for, not only as it is now, for misbehaving on the provider chain, but they're also going to be prevented from misbehaving, so trying to confuse consensus or just having downtime and not validating on the consumer chain, because any kind of infraction or any kind of evidence from this evidence module that appears on the consumer chain or is submitted to consumer chain is transmitted via IBC to the provider chain, to the Cosmos hub. And it's there that the provider validators will lose their tokens if they misbehave. And yeah, so we have also, as I mentioned before, this unbonding to prevent this problem of unbonding after misbehaving but before being detected. So these three pieces are leveraging IBC. Okay, so this is another diagram showing more or less the same thing, but maybe with a bit more graphical detail. And you can see what's going on here with the unbonding. So when somebody unbonds on the hub, there is a packet sent to the consumer, and then the unbonding period must elapse on the consumer before it is then acknowledged back to the provider, and the provider can finish unbonding. So invisible in practice, but interesting if you're developing. Okay, so how do you deploy? How do you take this custom consumer chain and get it running? How do you bootstrap it? So as I mentioned, the only thing you need is this incentive alignment, so some sufficient rewards to get people interested in your product, in your chain. So the steps are really this simple. You design your chain, you write your chain, you test your chain, you submit a governance proposal to the Cosmos hub, and if the validators are interested, if they like your project, if they're happy with your reward scheme, they're going to accept it. And then it's up to the validator set to just literally just start the binaries and start validating a new chain on completely separate hardware. All communication is through IBC. This is, I would imagine, quite beneficial in many ways. You know, validators can be sizable organizations. They can have separate teams for separate chains. And so this gives you both organizational scalability and this hardware computational scalability. We have, as I mentioned, a few projects kind of bursting who can't wait to use this, and I can't wait to see them use it. For example, probably one of the most impactful ones that we're going to start with is this CosmWasm chain, or chains, which are going to be consumer chains who are kind of sharing security and getting scalability through interchain security, and sharing security from the hub, where you can run arbitrary smart contracts. And because this chain is freed up from dealing with anything it doesn't want to deal with, right? So this can be a completely specialized consumer chain for a single smart contract, a bunch of smart contracts, a smart contract market. This is really giving you a lot of freedom. So this integration with CosmWasm, I think, is going to be very interesting. So just to go into the diagram a bit, you may have a custom consumer chain. You have convinced the hub, either through some social networking, a good reward scheme, a sensible proposal, and a well-tested binary, to accept your proposal on chain. So vote, yeah, can maybe zoom in here a bit. So we have this CW20 consumer chain contract, consumer chain, and we can vote yes, and we can see the vote anytime, and I'll show you later, but this proposal will come included with a start time for the consumer, meaning the consumer on command is going to start running. Okay. Yeah, I would like to mention we have a team working on a tool for this. So we have a CLI tool in the works, which is going to make this whole process of starting smart contract chains much easier, because it will do everything for you. For example, validators who accept the proposal would like to know that the hash included in the proposal actually relates to a particular binary version, and that binary is compiled from a particular piece of source code, so they know what's going on, right? So we have tools that take care of all these steps, all this validation and checks, and make things very seamless. Okay, so that ends the talk portion of the session. Soon I'll be giving a workshop. I'm just going to take a few minutes break to catch my breath. The workshop is going to include a live demo. I'm going to show you how to observe and debug the system. Talk a bit more about developing your own consumer chain, so how to write the logic for that. I'll show you some snippets, some interesting parts of the code, which are going to be interesting if you're developing using this, and have some time for some questions. So to reiterate, Interchain security lets you launch high-performance app logic safely, securely, and easily. It's here and it's going to be awesome. Thank you. Clone this and have a look. Hello. I'm ready to start now with the more hands-on part of the session. So I'm just going to launch right into it. Hopefully some of you had a chance to clone the repo and have a look at the instructions and play with it yourself. Right now I'm going to get straight into that. So bear with me because now it's the live part. Yeah. Sorry, can you repeat?
Yeah, I have a question. Governance. You mentioned that like Prop 16 is a case of bad governance or trouble governance going crazy. My question is, I understand how interchain security uses secure the hub by a very secure environment. But my question is, it doesn't seem to get rid of the issue that decisions have to be made. So if that issue came up, someone would try to do something on how to avoid it on the governance. Someone has to vote somewhere, right? Like, votes can happen.
Yeah, so the question was, interchain security doesn't necessarily solve the problem of decisions still having to be made ultimately, right? So yeah, you're right. I mean, the point of it is it's an invisible layer. You can design your consumer governance however you want. It's complete freedom. You can write arbitrary logic to govern your consumer chain. So the question was, does the hub decide when to upgrade? I'm not sure if any concrete decision has been made. I don't know, basically. I think you can just have either. I don't see why I think you can just have either. Like you could submit a proposal which would make a commitment in the proposal, the initial chain proposal, that all upgrades are going to be made by the provider. Or you could, just have this a Boolean to say, oh, okay, if this Boolean is false, actually they'll be made on the consumer. Okay, so I like this question. So yeah, so it's very difficult to hear you, but I think I get the idea. So it's really, the question is like really about how it works when you have, conflicting or proposals happening both on consumer and provider. So this is something I suggest that people think about in creative ways. I know there's a team already who's working on this. So exciting to see what comes out of that. I don't have the answers. Like I said, interchain security is an open layer for you to do whatever you want. So it's okay? It's really hard to hear you with your mask. Yes. I think for V1, so we're doing a very short release cycle, so we're aiming for V1 like in the next couple of days. I think it's probably just on the provider, but there's no reason this can't be changed for V2, which is going to come out like probably in a couple of weeks. Provider. Yeah. Yes. Okay, thank you. So yeah, just to recap, the question was, in V1 of the project, who will be upgrading the chain? I think it's the provider. Yeah. Okay. So I'm going to now continue with the hands-on part of the session. Yeah, so hopefully you've had a chance to take a look at this link. I can show you roughly what that's all about. Yeah, so we have this README with some instructions how to get started in a hands-on way, how to see your own demo, how to install some binaries to get started with, started with your development. This repo includes 4 instructions, so it also includes a script to check you have all the prerequisites. There aren't many, it's just to download and install the binaries, check out the repo, need some utilities, Node if you want to start the Explorer. Okay, so I'll just get right into this. What I'm going to show you is is an instance of a provider chain and a consumer chain. And we'll see how the voting power changes are relayed and reflected on the consumer. So a simple demo. Okay, so we'll start the Explorer. Oh. Strange things are happening to my resolution. Okay, so. Okay, so we've hacked together this fixed chain explorer just to see, just give a nice interface to see a bit what's going on. And yeah, so we're going to have much similar to that diagram I showed earlier on. Let's see. Yeah, similar to, okay, we have Flickr. Okay, I don't know what's going on. Yeah, so very simple setup, one provider, one consumer, and we're going to see some changes reflected. You can follow along. Hopefully, maybe you already tried, so let's just see. We have some scripts. Let's launch the chains so I can show you a bit what's going on here. Okay. So this script is going to set up 2 nodes locally in these C and P, so consumer and provider directories. It creates key pairs and the proposal for the consumer binary. So this consumer has barely any logic. It's a blog post application. So if you've ever used Ignite CLI, it's going to mimic that very closely. So we have some simple steps. So some configuration. We're going to start with just some delegation to play with and the single validator. We init the provider. We add some keys. You can see that, okay. We generate the initial Genesis transactions to get a single validator going. Enable the endpoints. Start the provider. We create the consumer chain proposal. So you can see here like the binary hash, the spawn time. And we submit this proposal. We're just going to immediately vote yes to get this proposal to go through. So this is a chain, with tweaked parameters, so it's not like a 2-week voting process. We are going to init, once this vote has passed, we're going to init the consumer chain. We're going to add keys for it, add the Genesis account, copy in some Genesis state. So this part is a bit tricky, I would say. But for example, we have tools coming out to make this easier, including this, this tool that particularly handles the CosmWasm chain, consumer chain use case. So yeah, we're going to just make some tweaks here, and the final instruction is to start the consumer. So I'm sorry about the pixelation, it's a bit pixelated. But we can see here we have an explorer, so we can see the consumer now at height 20 and the provider at height 39. If we see what's going on in staking, we have the validator just with the name Fizz, 1,000 voting power. We can see this reflected also in the consumer. So the consumer, it kind of takes like very small, it just takes voting power, like voting power public key relations, right? So like you don't have the full staking module here. Okay, so that's all good, but can we actually see this change? Okay, so I forgot, we better relay. So that was just showing the initialization. So this voting power was exported in the init Genesis for the consumer, that's why it's showing on the consumer. But we should now start Hermes relayer, so this high performance Rust relayer, which is going to start transmitting packets between the 2 chains to carry out things like the validator power changes, carrying out. It's going to send any slashing requests, so for downtime or double signing. So wait a little bit here. Yeah, so we have a block time of a few seconds, right? So the handshake has a few steps. Each step requires at least a block. So we have just to wait a few blocks here. Yeah, so as I said, this is the consumer application here is a blog post application, so it's the simplest one you can get. I'll show you guys just after this part, like how you can just get in there and change the code straight away. Okay. Okay, so that's Hermes is now started. Let's see what we can, if we can see a change happen live in the voting power. So I've got this like delegate script, which is just going to take this initial account, which I gave a lot of tokens, going to query the operator address. And so this is the crucial thing here, right? This is delegating on the provider from a provider account to the provider delegator. So without interchain security, this is just going to change power on the provider. With interchain security, we see this power change transmitted also to the consumer, which is then forwarded to Tendermint on the consumer, right? So let's see if we can get this working. Fingers crossed. Okay, so let's see. Yeah, so this looks like transaction sent, okay. And I think we might get it. What I should have done is shown before and after, but yeah, we can already see it. So I've delegated 800,000 tokens here. Voting power is kind of derived from that with some scalar. It's like a million token factor. So now we have the voting power change, as expected on the provider and reflected also in the consumer. So just we can see that working again, just do the same thing again. So now we can see voting power 8,000 on the consumer. If we're lucky, we might catch it before. Okay, no, it's fast enough, it's already changed. So we've already seen the increase in power there. So that's it. For this demo, I'm not going to show things like slashing. If you slash, you could slash the consumer. This slash will be transmitted to the provider, be reflected in a change in validator power on the provider. And then that change as well would also funnel down again to the consumer. So, but yeah, simple demo. We have V1 releasing hopefully within days. And we're on a fast release cycle, so we should be able to see V2, V3 in the weeks to follow. So that's it for the live demo. I hope you guys can try that out. You can edit your own consumer chain to try that. I'll just show you quickly what the code looks like for that. So this is my workspace. Maybe if you're developing, you'd like a similar setup. So I have each of the dependencies cloned, so I can change and debug those more easily. Like for example, you can use in Golang, you can replace dependencies with a local copy, so you can more easily debug, right? So that's what's going on there. Looking at interchain security itself, we have two apps that are kind of the default apps. For the purposes of this demo, we're on the HackATOM branch. I've got this consumer app with a kind of like hello module. So if you've ever used Ignite CLI and followed the tutorial there, this shows you how to, it starts very simple, hello world, it goes through a blog post application, which is exactly what's here. So if you want to just immediately start writing custom consumer chains, like today, this is the place to start. You can just edit this hello module, clone this module, write arbitrary logic in here. So that's that. Okay, so I think that's it. I'm just going to check I haven't forgotten anything. Yeah, so here are some links. HackATOM to get started right away today. Ignite, I do recommend Ignite if you want to kind of get started with SDK development, because it does a lot of things for you. It can generate boilerplate for you. It's well written, etc. We have a consumer chain tool, which is in the works, which is this tool which takes care of running a new smart contract chain. We will also be releasing the incentivized testnet soon, so this is going to allow validators to receive like real rewards for carrying out certain actions in the testnet to get this thing tested really, really thoroughly. I think that I was going to do a code dive, but actually, I think better to leave it here. Thank you. Yeah. So just to finish, interchain security, high performance app logic, safely, securely, and easily. It's almost here, and it's going to be awesome. Thank you. Yeah. Thanks.
Working on Substrate IBC project now. I will explain my background briefly. I'm a full-stack developer with over 12 years of diverse experience in software, including embedded software, web application, big data, and IoT. I have been a blockchain technology believer since 2017, with initial blockchain development on Ethereum DApp and Hyperledger Fabric. I gained solid low-level blockchain knowledge and macro. IBC project now. I will explain my background briefly. I'm a full-stack developer with over 12 years of diverse experience in software, including embedded software, web application, big data, and IoT. I have been a blockchain technology believer since 2017, with initial blockchain development on Ethereum DApp and Hyperledger Fabric. I gained solid low-level blockchain knowledge and macro cross-chain project experience after joining Octopus Network in 2020, especially the education on Cosmos and Substrate blockchain. Today, we are going to explore the first solution to directly enable transfers of fungible token and encapsulated data between a Substrate blockchain and a Cosmos-based blockchain. Our solution supports a direct relationship between the Substrate and Cosmos chains with independent layers. Here's the agenda of the workshop. There are two parts in the workshop. Part 1 is Substrate IBC architecture introduction, which is the column PPT in front of you. Part 2 is code demo of Substrate IBC fungible token transfer. Here's the brief background on Substrate and Cosmos and their light comparison. For those unfamiliar, Substrate is a framework for modelizing runtimes in a blockchain. This concept was designed by Gavin Wood, founder of Parity Technologies, an organization cultivating the Proctor ecosystem. Separately, the Cosmos SDK is a framework for utilizing IBC, Tendermint, and other economic controls like governance, slashing, staking, etc. developed by Interchain Foundation and its partner. The Cosmos hubs are flexibly accepting this in different arrangements for Cosmos relationship. Both modular blockchain concepts are viable for similar use cases, especially when considering solutions for application-specific blockchains. There are some differences in between as well. One key feature of Substrate is Option Worker. Substrate software has an advantage in executing option activity in trusted manner through Option Worker. Option workers have special low latency relationship to a Substrate validator. And through this extended trusted and flexibility, we have enabled an IBC library and relayer. Here's the Option Worker activity diagram. The Option Worker already integrated in Substrate IBC project. Here's the fundamental logic of Option Worker. From here, the outside world uses JSON RPC to interact with Substrate node. All modification to state will be handled using transaction from Substrate node or from Option Worker to the runtime logic. Runtime logic has full read-write capability to runtime storage and write capability to Option Worker. Please note the runtime logic doesn't have the capability to read option storage because the data in option storage is not agreed by the blockchain network through consensus. Substrate node can read and write directly to option storage. Even though the node can read option data, there is no impact to the runtime logic, as the way by which a node writes to runtime logic through transaction, which needs to be agreed upon consensus. Option workers can read and write option storage directly. But can only read runtime storage directly. Option worker can submit transaction to update the state on the chain, which is runtime storage. Option worker can call external service to get corresponding data back and update the chain state or option storage. In Substrate IBC, some incoming packets were stored in option storage and will be queried by the relayer. Here's the Substrate IBC scope. The red box in the diagram represents the scope of the Substrate IBC project. The scope includes two parts, the substrate part and the relayer part. The substrate part includes development of Substrate IBC palette, BC Live Client in IBC RS, fungible token transfer in IBC RS, and the integration of Substrate IBC palette with IBC RS. The relayer part includes support for Substrate and development of Octopus XT, which communicates with Substrate IBC palette. The standards in IBC core, including ICS02 client, ICS03 connection, ICS04 channel and packet, ICS05 port, and ICS26 router. were all implemented in the first two milestones, upon which the most important IBC standard, ICS-20, is built. More IBC standards, like Interchain account, will be implemented in the Substrate IBC palette in the future. The Substrate IBC palette, a modular component of Substrate, provides IBC-related capabilities, including creating clients, connections, channels, etc. Substrate application developers can import this palette to utilize the capabilities above with minimal configuration or adaptations. The relayer and IBCRS was initially designed for Cosmos only, so there are some incompatibilities with Substrate. For example, they use proto-buffer for serialization. In Substrate, the serialization mechanism is scale codec. This results in some different label and format of the same event. For example, IBC event is from IBCRS, and event is from Substrate node itself. Both refers to the same thing. Here's the events from IBC channel handshakes. If you are new to IBC, reviewing the documents will show that it's not too different from standing up a VPN. The channelization and encapsulation of data is begun with an OOB agreement. Conceptually, this handshake sequence is very similar to the tunneling provided by a virtual private networks. This is necessary to sync with either far-end chain to verify the correct value and to bring up a channel between two network endpoints. Most of you are likely familiar with messages for managing the first steps in opening a channel. In Substrate log, channel open init, try acknowledgement and confirm messages can all be found with some details for debugging in the event log. Here, the revision client version describes a nonce for the revision number. This improves accountability and awareness for both parties to assure that the upgrades to the client on either side will increment here. Separately, revision high is a block number incrementing. Here's the IBC fungible token transfer flow. Here we can see the flow logic between two substrate channels using IBC, through the relayer and IBCRS when transferring fungible token after the channel is brought up. This design requires a relayer to stabilize the connection in most cases. Start from here. A user submits a transaction to chain A. After the transaction request is routed to IBCRS and get processed there, the write reaccess of on-chain data will be handled by IBC palette. Then IBC palette will emit and send packet event. The relayer detects the send packet event, then submits a receive packet transaction to chain B. The chain B handles the receive packet transaction request with similar routes previously, and emits an event write acknowledgement. The relayer detects the write acknowledgement event and submits an acknowledgement transaction to chain A. The diagram displays two IBCI's invocation flow, sending fungible token and receiving fungible token. The flow logic applies to most IBC transactions. Here's another example of IBC invocation flow, update client. Step 1, an update client transaction was submitted to deliver function in IBC palette. The deliver function is the most important dispatchable function in IBC palette. Step 2, the transaction is passed to IBCIS routing module. When processing the transaction, IBCIS calls a client reader interface to query the client state in step 3, which is implemented in IBC palette. This flow applies to most of the IBC standard transactions. That's all for the Substrate IBC architecture introduction. Please continue to watch the subsequent video for IBC token transfer demo. Thank you.
Hello everyone. Having a nice dinner? So, 어떻게 그 개발은 다들 순조롭게 잘 진행되고 계신가요? 네, 저희도 그 해카톰을 제가 이제 그 한 2번, 3번 정도 참여를 했었는데 항상 그렇게 순조로웠던 적은 없었던 것 같아요. 근데 그게 또 그 해카톰의 묘미인 것 같고 그 챌린지가 있을 텐데 그 경험 자체가 좋은 경험이 되는 것 같고 좋은 시간들을 보내시고 계신 것 같아서 좋은 것 같습니다. 저희 팀은 이제 2018년부터 코스모스에서 활동을 하는 비아베스트라는 팀으로 시작을 했고 현재는 올해 4월에 이제 크레센트라는 네트워크를 런칭하면서 이제 또 이쪽으로 스핀오프를 하게 됐습니다. 그래서 코스모스 기반의 그 블록체인 개발 그리고 디파이 개발 이쪽으로 저희가 그 집중돼 있는 팀이라고 보시면 될 것 같습니다. 그래서 오늘 워크숍에서는 저희가 하고 있는 비전에 대해서 좀 설명드리고 저희 네트워크의 유틸리티들에서 좀 설명을 드리고 그 다음에 무엇보다 이제 여러분들에게 좀 도움이 되는 뭐 코스모스 SDK 개발에 대한 내용이라든지 그 다음에 저희 블록체인 코드베이스에 대한 설명이라든지 그리고 이제 또 여러분들이 많이 궁금해하시는 이제 블록체인 개발자로서의 커리어에 대한 부분이라든지 지금 개발하고 계시는 프로젝트에서 막히는 부분들이 있을 때 그런 부분들 저희가 좀 듣고 좀 저희가 도와줄 수 있는 분들을 도와드리려고 그렇게 시간을 좀 배분하려고 합니다. 그래서 적극적으로 저희 이 버건디 티셔츠 입고 있으신 분들이 다 저희 팀원들이거든요. 그래서 편하게 보이시면 질문해 주시고 뭐 연락처도 따주시고 또 물어볼 거 있으면 물어보시고 괴롭혀 주시기 바랍니다. 그래서 좀 더 그 탑다운으로 저희가 좀 공유해 드리고 싶은 비전은 일단은 블록체인의 애플리케이션 중에 그 가장 큰 부분을 차지하고 있는 부분이 디파이입니다. 그래서 현재 트레드파이라고 하는 전통 금융 시장이 있고 그 전통 금융 시장의 다양한 문제를 해결하기 위해서 저희 디파이가 계속 나오고 있는데요. 그 CFI라고 하는 전통 금융 시장이 갖고 있는 문제점들을 나열해 보자면 일단은 institution centralized라는 것은 이제 금융기관들이 중심이 돼서 시장이 운영되기 때문에 그들의 이해 논리라든지 그들의 이득에 맞춰서 시스템이 운영되고 있다라는 문제점이 있습니다. 그래서 인디비주얼 그리고 소외된 계층들이 금융시장에 접근했을 때 많은 손해를 보게 되고 접근에서도 많은 문제들을 낳고 있습니다. 그리고 뭐 스티키 인프라스트럭처라는 거는 이제 금융기관이라는 게 되게 그 오랫동안 그 역사를 가지고 발전하면서 그 포지션이 이제 굳어지게 되고 그들은 이제 혁신이나 시장의 변화보다는 그 시장의 포지션을 안주하는 데 좀 에너지를 많이 쏟고 있고 그 힘이 그 역할을 하게 돼서 이 인더스트리 자체가 굉장히 굳어져 있는 형태를 가지고 있습니다. 저는 이제 10년 동안 증권사나 운용사에서 이제 퀀트 트레이딩을 하고 있었는데요. 제가 10년 동안 이제 그런 경험을 통해서 이노베이션 굉장히 느리고 보수적인 구조라든지 이런 것들이 많은 혁신을 막고 있는 그런 문제점을 가지고 있습니다. 그리고 이제 투자자 보호를 위해서 많은 레귤레이션이 일어나고 이 레귤레이션이 또 정치적인 목적을 가지고 그리고 이제 우리나라는 특히나 이제 그 금융기관들이 많은 은행들 특히 이제 정부의 영향을 많이 받게 되면서 이제 그 혁신이라든지 투자자 보호를 위한 것들보다는 이제 정치적인 논리로 많은 것들이 이루어지고 있으면서 거기서 생기는 문제들이 많이 발생하고 있습니다. 리지널 베리어스라는 거는 이제 그 금융시장이 국가별로 이렇게 그 분할돼서 형성이 되고 그 국제적으로 이제 배려 없이 넘나드는 그런 시장들이 형성이 잘 안 되고 있다는 점입니다. 인터넷을 통해서 많은 산업들이 국경을 많이 초월해서 운영되고 있는데 여전히 금융시장은 그것이 좀 어렵게 이루어지고 있습니다. 그래서 이런 여러 가지 문제로 인해서 이노베이션이 굉장히 슬로우한 문제를 가지고 있고요. 그 다음에 정보에 있어서도 상당히 클로즈 인포메이션이라는 거는 그 파워를 갖고 있는 금융기관들이 정보들을 독점하고 있고 일반인들이 접근하기 굉장히 어려운 그런 구조를 띠고 있습니다. 그리고 또한 이제 금융 서비스들이 몇몇 금융기관들로 인해서 센트럴라이즈 오퍼레이션을 가지고 있고 이게 중앙화된 운영으로 인해서 생기는 다양한 또 문제들을 야기하고 있습니다. 그래서 디파이는 이런 문제들을 풀고 있는데요. 이제 디센트럴라이즈 거버넌스라는 거는 네트워크의 운영에 있어서 탈중앙화된 소유권과 거버넌스를 통해서 좀 더 그 오너십이 탈중앙화되고 사용자들이 좀 더 그 목소리를 낼 수 있는 그런 구조로 가고 있습니다. 퍼미션리스의 특성을 통해서 어떤 금융시장에 접근하기 힘든 사람들도 편하게 접근할 수 있는 그런 특성을 가지고 있고 블록체인이 가지고 있는 또 좋은 특성인 트랜스페런시를 통해서 어떤 알고리즘으로 서비스가 운영되고 있는지, 서비스가 운영되고 있는 상태가 어떤지, 그 다음에 그 정보들이 투명하게 공개됨으로 인해서 이런 문제들도 해결을 하고 있고요. 트러스트리스라는 거는 이제 이 오퍼레이션이 탈중앙적으로 운영됨으로 인해서 이제 중앙화된 운영에서 벗어나서 사람들이 좀 더 신뢰를 담보로 하지 않고도 서비스를 사용할 수 있는 그런 장점을 가지고 있습니다. 보더리스라는 것도 좋은 특성인데 어떤 프로덕트가 나왔을 때 어떤 국경이 없이 전 세계에서 블록체인을 통해서 서비스를 사용할 수 있는 그런 장점이 있습니다. 그래서 이런 특징들을 통해서 많은 이노베이션들이 상당히 빠르게 돌아가고 있는데 Fast Iteration of Innovation입니다. 그래서 모든 코드들이 오픈소스가 되고 그 오픈소스를 참고해서 또 다른 그걸 기반으로 다른 이노베이션이 일어나고 그래서 다른 인더스트리와 다르게 블록체인은 모든 노하우가 투명하게 오픈되기 때문에 모두가 뭐 카피한다고 볼 수도 있지만 이게 이제 모두가 이노베이션을 같이 한다는 측면에서 이 이노베이션의 속도가 다른 인더스트리하고는 차원이 다른 속도를 가지고 있습니다. 블록체인의 이코시스템에 대해서도 좀 더 설명을 드리자면 기존에는 이더리움 모노폴리 프로블럼을 가지고 있었습니다. 이더리움이 시장의 마켓쉐어를 크게 가져가고 그럼으로 인해서 이더리움에서 많은 어플리케이션들이 발생되었었는데요. 이런 것들이 이제 퍼포먼스 이슈를 가져오고 또 이제 그 하나의 네트워크에 수많은 애플리케이션을 담다 보니까 거버넌스 이슈가 생기고 그 다음에 그 하나의 인프라스트럭처 안에서 수많은 애플리케이션이 운영되다 보니까 이런 이제 인프라스트럭처의 문제도 발생되기 시작했습니다. 그래서 지금은 좀 더 트렌드를 보자면 towards Internet of Blockchains라고 볼 수 있을 것 같습니다. 그래서 다양한 레이어 1들이 런칭을 하고 특히 코스모스에서는 IBC로 연결되어 있는 수많은 블록체인들이 탄생하면서 좀 더 많은 블록체인들이 상호 연결됨으로써 네트워크를 형성하는 그런 구조로 진화를 하고 있는 것이 현재 블록체인의 상태입니다. 이 문맥 안에서 코스모스 비전이 있는데요. 저희 코스모스에서는 Millions of Blockchains라는 비전을 가지고 있고 모든 애플리케이션이 특별한 커스터마이즈를 필요하게 되고 컨피그레이션이 다 다르기 때문에 하나의 블록체인에 많은 앱을 담을 수 없고 많은 앱들이 독자적인 블록체인을 가지고 운영을 하는 모델을 가지고 있습니다. 이걸로 인해서 소버레니티라는 인디펜던시의 장점을 가지게 되고 그 다음에 IBC 커넥션을 통해서 이 이코노미와 유틸리티가 연결되는 이런 특성을 가지고 있습니다. 그래서 현재는 EVM 기반의 레이어 1 블록체인과 IBC로 연결되는 코스모스 블록체인 이렇게 두 가지 세상으로 지금은 양분되고 있다고 보이고 있습니다. 그래서 현재는 디파이가 어느 곳에서 디파이를 런칭할 거냐라는 그 그 위치에 대한 문제, 이코시스템에 대한 문제는 그렇게 중요한 문제라고 생각되지 않고요. 그런 것들보다는 모든 블록체인이 연결되고 있기 때문에 프로덕트 중심의 프로토콜 블록체인이 기본적으로 중요한 어프로치가 되고 있다고 생각합니다. 코스모스 기반의 블록체인을 개발할 때는 여러 가지 옵션이 있습니다. 지금 저희 내부에 또 코즈마즘 기술이 있고, 그 다음에 EVM을 활용할 수 있는 기술이 존재하고, 그 다음에 코스모스 SDK를 활용한 앱체인이 또 있을 수 있습니다. 그 중에 크레센트는 현재 코스모스 SDK 네이티브 접근을 하고 있고요. 왜 코스모스 SDK 네이티브가 좋은가 하는 점에서는 일단은 커스터마이제이션 측면에서 이제 스마트 컨트랙 기반의 블록체인은 스마트 컨트랙을 통해서 애플리케이션 개발할 수는 있지만 이제 더 로우 레벨에서는 모든 것이 코스모스 SDK와 텐더민트로 이루어져 있습니다. 그래서 SDK를 다룰 수 있는 팀이 결국 울티메이트 커스터마이제이션을 할 수 있는 팀이기 때문에 SDK 엔지니어링을 잘 할 수 있느냐, 이게 이제 코스모스 블록체인을 얼마나 장기간 서스테이너블하게 개발하고 운영할 수 있느냐에 굉장히 중요한 요소라고 생각됩니다. 그리고 SDK 기반의 개발은 좀 더 세큐어하고 퍼포먼스 측면에서도 장점을 가지게 되고요. 그럼 이제 이 문맥 하에서 저희 크레센트 네트워크의 비전에 대해서 좀 설명드리겠습니다. 저희 지금 블록체인은 갈수록 이제 멀티 블록체인 환경이 되고 있고, 디파이가 다양한 상품들이 나오고 있는데, 디파이 투자라는 것이 굉장히 어려운 상황이 되고 있고, 다양한 블록체인에 펼쳐져 있기 때문에 이것을 리서치하고 투자하는 것이 굉장히 어려운 상황이고요. 그래서 저희가 이런 문제들을 풀기 위해서 저희 비전을 가지고 있습니다. 그래서 크립토 네이티브한 유저가 아니더라도 일반 투자자들이 쉽고 효율적으로 디파이 투자에 접근할 수 있고, 더욱더 이제 투명하고 트러스트리스한 프로세스로 디파이 투자를 할 수 있도록 저희가 플랫폼을 제공하는 것이 저희 비전입니다. 저희 크레센트에서는 멀티체인 디파이 프로덕트를 브리징하는 기술, 그래서 신세틱 토크나이징 하는 기술과 그 다음에 크레센트 덱스를 통해서 이 신세틱 토큰을 거래하는 유틸리티, 그리고 이런 포지션을 해칭하고 레버리징 할 수 있는 크레센트 부스트라는 기능, 이렇게 크게 세 가지 기능으로 나눠져 있습니다. 저희 크레센트 덱스는 특별한 특성을 가지고 있는데요. 하이브리드 덱스 특성은 fully on-chain 오더북과 AMM 기술이 합쳐져서 두 가지 장점을 같이 활용할 수 있는 그런 덱스입니다. Ranged Liquidity는 이제 predefined price range 안에서 리퀴디티를 증폭시킬 수 있는 그런 기능을 가지고 있습니다. 또한 저희가 오더북, 온체인 오더북 갖고 있기 때문에 마켓메이커 인센티브를 통해서 마켓메이커를 인센티바이즈 함으로써 오더북의 리퀴디티를 더 확보할 수 있는 그런 기능을 가지고 있습니다. 이런 기능들을 통해서 저희가 리퀴디티 프로바이딩에 있어서 효율성을 확보를 할 수 있습니다. 일반 AMM에서는 리퀴디티 프로바이딩이 굉장히 익스펜시브 하고요. 그 다음에 오더북 provides maximize freedom. 그래서 오더북은 가장 높은 프리덤을 유저들한테 줄 수 있는 그런 솔루션입니다. 또한 레인지 리퀴디티는 기존의 AMM의 에피션시를 크게 끌어올릴 수 있는 그런 기능입니다. 또한 저희는 저희의 비전 중에 하나는 중앙화된 거래소에서 문제가 되고 있는 문제들을 풀기 위해서 트레이딩의 페어니스에 많이 집중을 하고 있습니다. 그래서 일반 거래소 그리고 또 유니스왑이라던가 다른 대부분의 덱스에서도 가지고 있는 문제는 로우 레이턴시 컴페티션입니다. 그래서 프로페셔널 트레이더들이 좀 더 좋은 테크놀로지를 가지고 로우 레이턴시 기술을 사용해서 좀 더 이득을 많이 취하고 있고 일반 트레이더들이 손해를 보고 있는 문제들이 있습니다. 이런 문제들을 풀기 위해서 저희는 배치 익스큐션이라는 로직을 사용해서 이런 그 순번에 따른 문제점을 해결하려고 노력하고 있습니다. 그리고 저희 덱스의 또 특이한 점은 네이티브 토큰보다는 신세틱 토큰의 리퀴디티에 집중을 할 예정입니다. 그래서 이걸 통해서 그냥 신세틱 토큰을 사는 것만으로도 디파이에 투자할 수 있는 그런 환경을 제공하려고 하고 있습니다. 크레센트 부스트는 기본적으로 마켓 뉴트럴한 투자를 제공할 수 있는 기능을 가지고 있습니다. 그래서 토큰을 바로잉함으로써 해칭을 하고 그래서 마켓 뉴트럴 포지션을 가지게 되고 그 다음에 그 바로잉된 토큰을 추가 신세틱 토큰을 투자함으로써 파밍의 레버리지를 또 가져올 수 있습니다. 그래서 결과적으로는 스테이블 코인을 투자하고 인컴을 얻는 포지션과 유사한 그런 포지션을 가질 수 있게 하는 게 저희 크레센트 부스트의 기능입니다. 또한 포지션을 리밸런싱을 오토메이션 함으로써 리퀴데이션을 피할 수 있고 이렇게 리스크 매니지먼트를 할 수 있는 기능들을 내포하고 있습니다. 그럼 저희 그 코어 개발자분들이 좀 더 그 코스모스 SDK와 크레센트 코드베이스의 디테일한 부분들을 소개시켜 드리겠습니다. 감사합니다.
네, 안녕하세요. 반갑습니다. 네. Hi everyone. It's great to meet you all. I'm JB Kim, one of the core blockchain developers at Crescent Network. I'll be presenting about Cosmos SDK for beginners, and for about 15 to 20 minutes. And this session is for developers who are not really familiar with Cosmos SDK. But I apologize. This presentation will be delivered in Korean as well. So apologize for those people who don't know Korean and who are not who expect this presentation to be delivered in English. 네, 이제 크레센트 코어 개발팀에서 모듈 개발을 하고 있는 김준범이라고 합니다. 지금부터 약 20분 정도 이제 코스모스 SDK 이제 코스모스 SDK를 이해하기 위해서 필요한 기초적인 부분들을 좀 설명을 드리고자 하는데요. 이미 코스모스 SDK를 이용해서 체인을 운영 중에 있으신 분도 계시고 이미 능수능란하게 코스모스 SDK를 사용하고 있으신 분도 계시겠지만 본 자료는 이제 좀 SDK에 아직 익숙하지 않은 분들을 위해서 준비를 좀 해봤습니다. 그래서 지금부터 한 20분 정도가 이제 코스모스 SDK가 정확히 뭔지 그리고 개념 설명을 좀 드릴 거고요. 그리고 두 번째로는 그 SDK 모듈에는 어떤 모듈들이 존재하고 그 각각의 모듈들이 하는 기능들에 대해서 간략하게 좀 설명을 드릴 예정이고요. 그리고 세 번째로는 모듈 구조에 대해서 좀 설명을 드릴 예정이고요. 마지막으로 모듈 개발을 하기 위해서 어떤 과정들을 거치는지 좀 설명을 드려보겠습니다. 네, 일단 코스모스 SDK가 정확히 무엇인가? 이 코스모스 SDK는 현재 오픈소스로 운영이 되고 있고요. 고라는 언어로 프로그래밍 언어로 작성되어 있습니다. 그래서 코스모스 SDK를 정확히 이해를 하고자 하시는 분들은 기본적인 컴퓨터 프로그래밍 지식이 있어야 하고요. 고 언어에 대한 이해가 동반돼야 됩니다. 그리고 코스모스 SDK는 현재 한 번이라도 이제 기여한 사람의 기준으로 300명이 넘는 기여자가 있고요. 약 4,300의 스타 표시가 되어 있습니다. 네, 코스모스 SDK는 프레임워크이자 이제 소프트웨어 도구 모음집입니다. 어떤 도구들을 가지고 있냐면은 블록체인, 그러니까 지분 증명 방식의 블록체인을 좀 손쉽게 개발할 수 있도록 도와주는 도구를 이제 모아놓은 도구인데요. 이 도구들을 각각 모듈이라고 부릅니다. 그래서 저는 좀 그 코스모스에 익숙하지 않고 이제 블록체인에 좀 잘 모르시는 분들이 저에게 이제 코스모스 SDK가 뭐냐 좀 쉽게 설명해 달라라고 하면은 그 조립식 자동차, 뭐 조립식 레고를 만드는 약간 그런 식으로 표현을 합니다. 그래서 어렸을 때 한 번씩 다들 레고를 사보신 적이 있을 거예요. 그 조립식 자동차를 사면은 그 각각 미리 만들어진 그 부품들이 있거든요. 그래서 그 부품들을 조립 설명서에 따라서 하나하나 조립해 나가면은 이제 완성된 자동차를 볼 수 있는데요. 마치 이 미리 만들어진 부품들, 이 부품들을 코스모스 SDK에서는 모듈이라고 부릅니다. 그래서 이 지분 증명 방식의 블록체인을 만들 때 필요한 부품들, 이 모듈들을 이제 각각 커스텀하게 만들어서 블록체인을 만들 수 있는 거라고 보시면 되고요. 이 코스모스 SDK는 텐더민트라는 이제 엔진을 사용하고 있습니다. 이 합의 알고리즘이죠. 그래서 이 화면에 보시면은 맨 위에 스테이머신이라고 해서 이 코스모스 SDK를 이용해서 스테이머신 어플리케이션을 만드는 거고요. 그리고 그 아래쪽 보시면 합의 알고리즘과 네트워킹 레이어가 있는데 이 부분이 텐더민트 코어 영역입니다. 그래서 이 부분은 신경을 쓰지 않으셔도 되고 SDK를 개발할 때는 그 디폴트로 텐더민트 코어를 사용하고 있기 때문에 손쉽게 뭐 신경을 쓰지 않아도 블록체인을 만들 수 있습니다. 네, 그래서 말씀드렸다시피 그 코스모스 SDK는 그 컴포저블하다. 이제 뭐 원하는 모듈들을 가져다가 장착하고 뭐 빼고 커스텀하고 할 수 있게끔 구조가 잡혀져 있고요. 또 스마트 컨트랙트, 이더리움 쪽에서 뭐 스마트 컨트랙트를 개발하시다가 오신 분들은 좀 궁금해하실 수 있어요. 이제 코스모스 SDK 어플리케이션 개발하는 게 뭐가 다르냐 하면은 기본적인 아키텍처부터 좀 다릅니다. 그 이더리움 같은 경우는 스마트 컨트랙트를 개발할 때 이더리움 블록체인이 있죠. 그 안에 이제 가상 머신이 존재하는데 그 가상 머신이 이해할 수 있는 언어로 작성이 돼야 되고요. 그 가상 머신이 가진 제약사항들을 맞춰서 그 제약사항들에 따라서 스마트 컨트랙트를 작성하고 배포해야 됩니다. 그로 인해서 여러 가지 문제점들이 있는데요. 이 반면에 SDK 앱 개발은 이 전 페이지에서 보여드렸다시피 그 하나의 어플리케이션을 이제 코어 땅과 같이 만들기 때문에 이 코어와 긴밀한 통신이 가능하고요. 그리고 뭐 스마트 컨트랙트 같은 경우는 이제 한 가지 예로 들면 그 제가 배포한 스마트 컨트랙트가 아니더라도 이 이더리움 블록체인 내에서의 뭐 제한사항 그리고 어떤 서비스가 굉장히 유명해짐에 따라 뭐 트랜잭션이 많아지면 제 서비스, 제 스마트 컨트랙트가 아닌데도 불구하고 영향을 받습니다. 그래서 성능에 좀 제한이 있을 수 있다. 트랜잭션이 많아지면. 그리고 좀 더 유연하지 않다. 그래서 이제 애플리케이션 개발할 때는 자동화를 실행할 수 있는 코드를 삽입할 수가 있거든요. 그래서 스마트 컨트랙트에서는 안 되지만 이제 SDK 앱 개발에서는 이제 자동화를 시킬 수 있는 실행 코드까지도 삽입할 수 있다. 네, 그래서 첫 번째로 코스모스 이제 SDK를 최초로 이용해서 이제 런칭한 프로젝트가 이제 여기 계신 분들이 모두 아시는 코스모스 허브 이제 아톰이라는 코인을 가지고 있는 프로젝트고요. 이제 2019년도 5월 13일에 런칭을 했죠. 그 이외에도 이제 시간이 흘러서 지금 수많은 프로젝트들이 이 독립적인 코스모스 SDK를 이용해서 독립적인 체인을 운영하고 있고요. 저희 크레센트도 마찬가지로 디파이 영역에서 혁신을 일으키기 위해서 많은 개발과 연구와 이제 도전을 하고 있습니다. 네, 이제 SDK 모듈에 대해서 알아볼 텐데요. 어떤 모듈들이 존재하는지 그리고 각각의 모듈은 어떤 기능을 하는지 알아보겠습니다. 네, 이제 설명드렸듯이 이 모듈은 텐더민트 코어를 기반으로 다양한 모듈들이 있고요. 어스 모듈 같은 경우에는 이제 자산 이제 계정들이 어떤 계정들 이제 계정 타입들을 선언하는 부분이 있고요. 그래서 일반 베이스 어카운트나 베스팅이 있는 이제 어카운트나 그런 것들을 선언하고 인증하는, 그리고 트랜잭션을 인증할 때 필요한 기능을 담당하는 모듈입니다. 그리고 어스Z 같은 경우는 이제 한 계정이 다른 계정에 어떠한 그 특수한 행동만 할 수 있도록 뭐 메시지 샌드만 보낼 수 있게 한다던가 뭔가 델리게이트만 한다던가 뭐 그런 메시지를 제한할 수 있게끔 권한을 부여하고 뺏고 하는 이 기능을 가지고 있는 모듈이고요. 그리고 뱅크 모듈 같은 경우는 이제 코인을 전송할 때 필요한 기능을 가지고 있고, 크라이시스 모드 같은 경우에는 이제 특수한 상황에 블록체인이 이제 멈추게끔 하는 모듈을 가지고 있는데요. 보통 이제 인베리언트 체크라고 이제 변하면 안 되는 이제 값들, 예를 들어 인풋 값이 있는데 어떤 계산 로직을 수행한 후에 그 아웃풋 값이 이 오차 범위가 1% 미만이어야 되는데 만약에 넘어갔을 경우 굉장히 크리티컬한 버그로 이루어질 수 있다고 판단되면 이 크라이시스 모듈을 이용해서 이제 인베리언 체크를 함으로 인해서 블록체인이 멈추게끔 할 수 있습니다. 그리고 디스트리뷰션 모듈 같은 경우는 이제 이 지분 증명 방식의 블록체인에서 스테이킹이라는 행위를 하기 때문에 그 스테이킹을 함으로 인해서 리워드를 받습니다. 그때 이 리워드를 분배할 수 있는 기능을 담당하고 있고요. 그리고 페이 그런트 같은 경우에는 이 트랜잭션을 일으킬 때 트랜잭션 수수료를 대신 내줄 수 있게끔 하는 기능을 가지고 있습니다. 그리고 IBC 모듈은 뭐 코스모스의 핵심이죠. 예, 블록체인 간의 소통이 가능하게끔 하는 기능을 가지고 있는데요. SDK 모듈에서 빠져서 지금은 자체적인 저장소에서 관리가 되고 있습니다. 네, 그리고 거버넌스 모듈은요, 이 온체인에서 그 거버넌스를 그 운영이 되고 이 각각의 사람들이 그 투표를 함으로 인해서 투표를 하고, 그리고 투표가 완료되고 그 거버넌스 프로포절이 이제 끝날 때 그 투표를 합산해서 결과를 알려주는 기능을 가지고 있고, 민트 모듈 같은 경우에는 이제 어떤 새로운 코인을 발행하고 이제 없애는 번지키는 기능을 가지고 있고요. 그 슬래싱 모듈 같은 경우는 검증인들이 이제 어떠한 악의적인 행동을 했을 때 뭐 블록을 생성하지 못하거나 그리고 뭐 이중 서명을 하거나 같은 행위를 했을 때 자산을 삭감하는, 슬래싱한다고 표현하거든요. 그래서 페널티를 부여하는 기능을 담고 있는 모듈입니다. 그리고 스테이킹은 이제 뭐 지분 증명 방식의 블록체인에 익숙하신 분들은 아시겠지만 뭐 스테이킹 위임하고 그리고 특정 위임을 해제하고 뭐 이런 부분들 기능을 담고 있는 거고요. 업그레이드는 뭐 업그레이드 할 때 필요한 모듈들, 그리고 파람스 같은 경우는 각 모듈들에서 이제 글로벌 파라미터를 이제 정의를 하는데요. 이는 거버넌스 프로포절로 이제 수정하고 뭐 추가하고 뭐 업데이트도 하고 하는 걸 할 수 있거든요. 그 부분을 담당하고 있습니다. 네, 이제 모듈 구조에 대해서 본격적으로 알아볼 텐데요. 모듈 구조는 먼저 프로토라는 파일이 있습니다. 이 프로토 파일은 프로토콜 버퍼스라는 거의 약어인데요. 그래서 프로토콜 버퍼는 이제 크로스 플랫폼을 지원하면서 이 데이터 포맷이거든요. 그래서 XML이나 뭐 JSON을 다뤄보신 분들은 아시겠지만 속도가 좀 느립니다. 그래서 이 프로토콜 버퍼를 사용하면 좀 작고 굉장히 빠르거든요. 그래서 구글에서 개발을 했습니다. 그리고 이 프로토콜 버퍼의 특징이 이제 이런 .프로토라는 파일들을 메시지를 정의를 하면 수많은 프로그래밍 언어에 맞게끔 빌드를 할 수가 있습니다. 그래서 이 한 번 정의를 해놓으면 고 언어로도 되고 자바스크립트 언어도 되고 파이썬, 뭐 C++ 언어에 맞게끔 그 프로토 컴파일러로 빌드를 할 수 있습니다. 그리고 X라는 폴더가 있는데요. 이 X라는 폴더 안에 제가 전에 코스모스 SDK 모듈들에 대해서 설명을 드렸잖아요. 그 모듈들이 다 존재합니다. 그래서 그 모듈에 지금 오른쪽에 이미지를 보시면 디스트리뷰션 모듈을 제가 한번 열어봤는데요. 그 안에 다양한 패키지들이 있습니다. 그래서 클라이언트 패키지가 있고 키퍼, 시뮬레이션, 스펙, 타입스 뭐 이렇게 각각의 패키지들이 있는데 이 각각의 패키지들이 어떤 기능을 담고 있는지 한번 알아보겠습니다. 클라이언트 패키지 같은 경우에는 그 개발자분들이 익숙하신 그 터미널 상에서 그 CLI, 커맨드 라인 인터페이스로 뭐 블록체인과 소통할 수 있는 트랜잭션을 날리고 정보를 쿼리하는 부분들을 담당하고 있는데요. 그 부분이 이제 그 부분의 구현을 담고 있는 패키지라고 보시면 됩니다. 그리고 키퍼는 이제 그 모듈 개발에서의 핵심인데요. 그 블록체인의 상태 관리를 해주는 부분입니다. 그래서 이 상태 관리는 이 키퍼마다, 이 모듈마다 다 각각 있어야 하고요. 그래서 스토어에 뭔가를 접근해서 그 데이터, 이 상태를 읽고 쓰고 뭐 업데이트 시키고 딜리트하고 그리고 데이터를 이터레이션을 돌면서 각각 가져올 수 있게끔 하는 역할을 하고 있습니다. 그래서 오른쪽에 보시면 기본적인 구조는 이제 키퍼 안에 뭐 제네시스 키퍼, 메시지 서버, 뭐 gRPC 쿼리 이런 식으로 되어 있는데 모듈의 특성에 맞게끔 이제 각각의 폴더가 좀 더 파일이 많아질 수 있습니다. 키퍼를 정의할 때는 기본적으로 키퍼.co라는 곳에서 정의를 하는데요. 이 키퍼 타입 정의할 때 이제 각각 스토어를 이제 관리를 하잖아요. 그 관리를 할 때 접근을 제한할 수 있게끔 각각의 스토어 키라는 걸 가집니다. 이거는 보통 모듈의 이름을 따라가는데요. 그래서 그 스토어 키가 있으면 이제 키로 사용을 해서 이제 그 접근을 하게끔 할 수 있게끔 하는 역할을 하고요. 그 코덱이라는 거는 그 어떤 구조체를 인코딩하고 디코딩하는 역할을 해주는 파라미터고요. 그리고 이 키퍼에서 뭐 예를 들어 디스트리뷰션 모듈의 키퍼에서 그 뭐 어카운트 키퍼를 사용하고 싶다, 뭐 어스 키퍼를 사용하고 싶다, 그 계정 정보가 필요하니까요. 그럴 때 여기서 키퍼를 이제 선언을 해주고 그 선언한 그 모듈에 있는 함수를 사용하는 것을 직접 선언을 해줘야 됩니다. 네, 그 스토어에 이제 제가 접근을 할 때 뭐 게터가 있고 세터가 있고 뭐 이터레이터가 있고 딜리트가 있고를 말씀드렸는데 지금 화면에 보시는 것과 같이 오른쪽에 이게 디스트리뷰션 모듈의 그 스토어에 접근하는 함수거든요. 그래서 다양한 게터와 세터 그리고 이터레이터가 있고 딜리트도 있습니다. 그리고 스펙 패키지는요, 기술 문서를 정의하는 곳입니다. 이 블록체인 프로젝트는 기본적으로 대부분이 오픈 소스로 운영이 되기 때문에 같이 일을 하는 사람이 이제 같이 오프사이트에서 일을 할 수도 있고 웬만하면 다 그 탈중앙적으로 좀 다른 전 세계에 있는 뭐 개발자들과 같이 일을 하기 때문에 이 기술 문서가 잘 정의가 되어야 되는데요. 그래서 그 각각의 모듈이 어떤 기능을 가지고 있고 뭐 어떤 이해를 해야 되고 새로운 개발자가 왔을 때 그리고 상태는 어떤 상태가 있는지 뭐 구조체를 정의를 해줘야 됩니다. 네, 그때 지금 사용하는 패키지고요. 타입스 패키지 같은 경우는 이제 첫 번째 페이지에서 제가 프로토를 설명드렸잖아요. 그때 프로토 메시지를 정의를 하면 이제 빌드를 하게 되는데요. 컴파일러로 그 빌드를 하면 이 화면에 보시는 것과 같이 pb.co라는 이제 그 자동으로 생성된 파일이 존재합니다. 그러면 이 자동으로 생성 파일에 따라서 뭐 메시지에 대한 정의를 해야 되고 그리고 또 파라미터에 대한 정의를 하고 뭐 제네시스에 대한 정의를 해야 됩니다. 그래서 그 pb.co가 그 만들어준 구조체에 따라서 SDK 모듈에서 구현해야 되는 필요한 코드를 이제 그 빨간 줄이 가거든요. 그래서 그 빨간 줄에 맞춰서 구현을 하시면 됩니다. 그리고 마지막으로 ABCI 쪽은요, 사용을 해도 되고 안 해도 됩니다. 이 옵셔널한 부분인데 그 모듈의 특성에 맞게 사용을 하는 부분이고 그 제가 초반에 그 스마트 컨트랙트랑 SDK 개발이 어떻게 다른지에 대해서 드린 부분 중에 그 자동화를 해서 뭔가 실행할 수 있는 코드를 삽입할 수 있다라는 부분이 이 부분에 넣을 수가 있어요. 그래서 블록이 생성될 때 최초로 뭐 비긴 블로커에서 이제 코드를 삽입할 수가 있고 다음 블록이 생성되기 전 그리고 블록이 이제 딱 마지막 블록 해시가 나오기 전 엔드 블로커에서 이제 어떤 코드를 삽입해서 실행시킬 수도 있습니다. 그럼 이제 마지막으로 그 모듈을 개발할 때 어떤 과정을 거치는지에 대해서 좀 알아볼 텐데요. 팀마다 조금씩 다르겠지만 저희는 이런 프로세스를 가지고 있습니다. 모듈에 대한 당연한 얘기겠지만 어떤 모듈을 개발해야 할지에 대해서 브레인스토밍을 하고 그 디자인을 합니다. 그래서 그 디자인한 모듈 그 개념을 통해서 그 기술 문서를 작성을 하고요. 그래서 기술 문서 안에는 뭐 구조체는 어떻게 할 것이며, 뭐 키는 어떻게 관리를 할 거고, 스토어에는 어떤 식으로 접근을 해야 되고, 뭐 쿼리나 트랜잭션은 어떤 게 필요한지 이런 거에 대해서 좀 정의를 먼저 하고요. 그 다음에 본격적으로 코드를 작성하기 시작합니다. 그래서 모듈에 필요한 그 골격이 필요하거든요. 그래서 보일러플레이트를 작성한다고 하는데, 그 모듈에 필요한 보일러플레이트를 작성하고 이제 프로토 파일에 메시지를 정의를 한 다음에 빌드를 해서 그 아까 전에 그 타입스 패키지에서 이제 필요한 부분들을 채워 나갑니다. 그리고 키퍼에서 이제 스토어에 접근할 수 있는 getter, setter, 뭐 delete, iterator 같은 이제 함수를 정의를 하고, 뭐 메시지를 트랜잭션 메시지는 어떤 게 있어야 되는지 그런 부분들의 로직을 구현을 하고요. 그 마지막으로 앱.9에서 그 모듈에 이제 필요한 그 연결을 다 해주면 이제 POC 단계의 모듈이 완료가 됩니다. 그리고 나서 이제 내부적인 어느 정도의 좀 그 피어 리뷰를 진행을 한 후에 유닛 테스트와 통합 테스트 그리고 시뮬레이션 테스트를 과정을 거친 다음에 다큐멘테이션에 조금 시간을 쓰는데요. 네, 이런 과정을 통해서 하나의 모듈이 개발이 됩니다. 네, 지금까지 그 코스모스 SDK 기초적인 부분을 좀 말씀을 드렸는데요. 그 코스모스 SDK가 무엇인지, 그리고 SDK 모듈에는 어떤 것들이 있고 그 각 모듈들이 하는 역할에 대해서 말씀을 드렸고, 그리고 모듈의 구조, 그리고 모듈을 개발할 때 어떤 과정이 필요한지에 대해서 말씀드렸습니다. 이 짧은 시간 동안 최대한 압축해서 많은 내용을 좀 전달드리려고 했는데 아무래도 좀 부족한 시간이라고 생각이 들고요. 제가 전달드린 내용에서 뭐 궁금하신 부분이 있거나 좀 더 뭐 현재 해가톰에서 SDK를 이용해서 개발하신 분이 계시면 조금 조언이 필요하거나 뭐 좀 도움이 필요하다 싶으신 분들은 저한테 찾아오셔서 뭐 문의해 주시면 제가 성심성의껏 제가 아는 부분에 대해서 가르쳐 드리겠습니다. 네, 감사합니다.
네, 안녕하세요. 저도 크레센트에서 코어 개발하고 있는 변동삼이라고 하고요. 저는 이제 실제 크레센트에서 어떤 식으로 코드가 작성돼 있고 모듈들이 어떻게 연동돼서 돌아가는지 좀 더 딥하게 알아보려고 합니다. 우선 간략히 설명을 드리고 이제 크레센트에 있는 코어 모듈들의 각각의 특징과 플로우를 좀 알아볼 거고요. 그 다음에 코스모스 SDK를 어떻게 커스터마이징해서 사용하고 있는지 그런 패턴들에 대해서 설명드리겠습니다. 우선 크레센트 코어는 현재 최신 버전은 버전 2.1.1 사용하고 있고요. 코스모스 버전은 0.45 버전을 사용하고 있습니다. 그래서 해당 링크들에서 닥스나 스웨거 이런 것들 참고해 보실 수 있고요. 저희 GitHub 사진입니다. 저희는 테스트 커버리지를 최대한 높게 유지하려고 하고 있고 관심 있으시면 한 번씩 코드 구경하시면 좋을 것 같습니다. 그래서 저희 크레센트의 모듈 구조를 먼저 도표로 그려봤는데요. 대표적으로 이런 모듈들이 있고 우측에 있는 이제 코스모스 SDK에 있는 주요 모듈들과도 긴밀하게 연동되어 돌아가고 있습니다. 대표적으로 이제 민트 모듈에서는 이제 인플레이션을 담당하고요. 그 코스모스 SDK에도 민트 모듈이 있는데 저희는 컨스탄트 인플레이션을 구현을 하기 위해서 별도의 민트 모듈을 구현해서 사용하고 있고요. 그 다음에 버젠 모듈에서는 이제 민트에서 인플레이션 된 양들을 이제 필요에 맞게 배정을 해주고 집행을 하는 그런 역할을 하고 있습니다. 그 다음에 리퀴티 모듈에서는 저희 덱스에 대한 내용을 담고 있고요. 파밍 모듈에서는 이제 리퀴티 프로바이더들한테 인센티브를 주는 역할을 담당하고 있습니다. 또한 리퀴드 스테이킹 모듈에서는 저희는 특이하게 크리하고 비크리라는 토큰이 있는데요. 이제 크리를 스테이킹하고도 비크리를 받아서 좀 더 리퀴드한 활용을 할 수 있는 역할을 하고 있는 모듈이고요. 클레임 모듈은 이제 저희가 에어드랍을 진행했는데 특정 액션을 수행하고 이제 그 에어드랍을 클레임에서 가져갈 수 있도록 하는 역할을 하고 있습니다. 그래서 민트 모듈 같은 경우엔 말씀드렸다시피 저희는 컨스탄트 인플레이션을 적용하고 있기 때문에 매년 인플레이션 돼야 되는 양이 정해져 있습니다. 그래서 그렇게 인플레이션이 발생된 거는 이제 버젯 모듈을 통해서 여러 모듈들로 배정이 돼서 이용이 되게 되고요. 민트 모듈의 파라미터를 살펴보시면 일단 민트 디놈 같은 경우엔 저희는 크리라는 디놈을 사용하고 있습니다. 그래서 크리 디놈으로 민트가 발생하고 민트 풀 어드레스라는 모듈 어카운트로 이제 민트된 코인들이 모이게 됩니다. 그리고 블록 타임 스레시홀드는 뒤에서 좀 더 자세히 설명드리겠고요. 이 인플레이션을 어떻게 정의하냐에 따라서 이제 민트가 발생할 텐데 먼저 스타트 타임과 엔드 타임을 정의하고 그 기간 동안 얼마만큼의 인플레이션 민트가 발생할 건지 정의를 할 수 있습니다. 이게 현재 크레센트 메인넷의 이제 민트 모듈 파라미터를 본 건데요. 인플레이션 스케줄 쪽을 보시면은 저희가 총 10년에 대한 인플레이션을 미리 정의를 해놨습니다. 1년 단위로 그 1년 동안에 발행돼야 되는 어마운트가 정의되어 있다고 보시면 되고요. 저희가 블록 인플레이션을 계산하는 과정에 있어서는 이제 인플레이션마다 그 연도의 스케줄 어마운트가 있고 시작 타임과 엔드 타임이 있을 겁니다. 근데 이게 1년 동안 이 양을 민트를 해주기 위해서는 블록 타임이 매 블록 이제 좀 변동이 있을 텐데 그래서 블록 타임에 맞춰서 그 블록 타임에 해당하는 양만큼만 저희가 민트를 해줘야 되는 문제가 있습니다. 그래서 저희는 이 기간 동안을 인플레이션 스케줄 어마운트를 나눠가지고 블록 타임을 곱한 다음에 제공을 해주게 되고요. 여기서 블록 타임 스레시홀드는 만약에 지금 현재 블록 타임 스레시홀드는 10초로 설정이 되어 있는데 만약에 블록 타임이 체인에 문제가 생겨서 뭐 2시간이 걸렸다. 그렇다고 2시간만큼의 인플레이션을 해주게 되면 조금 안 좋은 영향을 줄 수가 있습니다. 또한 밸리데이터들이 악의적인 마음으로 블록 타임을 조작하는 이슈가 생길 수도 있는데 그럴 때 악의적으로 인플레이션이 과도하게 되는 걸 막기 위해서 저희가 미니멈 펑션을 적용해서 최대한 한 블록에 최대 10초까지만 그에 해당하는 양이 인플레이션 될 수 있도록 코드를 작성해 두었습니다. 그래서 위에 수식과 동일하게 아래 코드가 적혀져 있는 내용 참고해 보실 수 있고요. 이렇게 블록 인플레이션이 이제 양수로 뜨면은 저희가 이제 민티드 코인을 민트를 해가지고 민트 풀로 전송하는 코드 로직입니다. 그 다음은 버젯 모듈인데요. 방금 민트 모듈에서 인플레이션 된 양들을 이제 버젯 모듈을 통해서 각각 목적에 맞게 여러 모듈들로 흩어지게 됩니다. 뭐 대표적으로 이제 SDK에 있는 fee 컬렉터라는 곳으로 먼저 보내게 되는데요. 이곳에서는 이제 스테이킹 리워드랑 커뮤니티 풀로 배분되게 되는 목적입니다. 그 다음에 이제 파밍 쪽으로도 파밍 인센티브에 해당하는 배정이 이루어지고 추후에는 이제 마켓 메이커와 부스트 인센티브를 위한 배정도 예정되어 있습니다. 현재 버젯의 에폭 블록은 한 블록으로 설정되어 있어서 매 블록 이 버젯 얼로케이션이 일어나게 되고요. 버젯의 정의는 이름과 그리고 얼마만큼의 레이스로 버젯을 집행할 건지 레이트 그리고 어느 어드레스에서 돈을 줄 건지 소스 어드레스와 어떤 어드레스를 줄 건지 데스티네이션 어드레스 그리고 이 버젯의 시작 타임과 엔드 타임을 정의하고 있습니다. 그래서 현재 크레센트 버젯 파라미터를 살펴보시면은 첫 번째 버젯을 보시면은 이제 스테이킹 리워드랑 커뮤니티 펀드 목적으로 배정을 하고 있는데요. 여기 약 8% 정도를 이제 소스 어드레스를 보시면은 아까 정의했던 민트 풀 어드레스인 걸 확인하실 수 있습니다. 그래서 민트에서 발생한 양의 8.7%가 이제 데스티네이션 피 컬렉터로 이동하게 돼서 피 컬렉터는 코스모스 SDK의 로직 하에 스테이킹 리워드와 커뮤니티 풀로 배정되게 됩니다. 그 다음에 이제 에코시스템 인센티브라는 곳으로 꽤 많은 양이 배정이 되는데요. 여기 데스티네이션 어드레스를 보시면 QA로 끝나는 어드레스인 걸 보실 수 있습니다. 그리고 다음 버젯 플랜들을 보시면은 아까 보냈던 QA 어드레스에서 데스티네이션 어드레스를 각기 다르게 3개의 별도 플랜으로 또 재배정하고 있습니다. 이건 저희가 인센티브를 리퀴티 프로바이더를 위한 인센티브 그리고 마켓 메이커를 위한 인센티브 부스트를 위한 인센티브로 이렇게 각각 다른 모듈 어카운트를 선언을 해서 배정하고 있는 모습을 확인하실 수 있습니다. 그럼 이 모듈 어카운트를 어떻게 정의를 해서 사용하는가 하면은 일반적으로 코스모스 SDK는 20바이트짜리 어카운트 길이를 디폴트로 사용을 하고 있습니다. 하지만 이런 버젯에 대한 많은 양들이 하나의 어카운트에 담겨져 있으면 그만큼 그 어카운트의 프라이빗 키가 만약에 해커에 의해 노출됐을 시 그게 한 번에 다 털릴 수 있기 때문에 20바이트는 상대적으로 좀 더 취약하다고 보실 수 있습니다. 기존 SDK 모듈에서 모듈 어카운트에 어드레스를 도출하는 방식을 보시면은 이 어드레스 해시라는 걸 사용하는데 여기서 보시면 해시된 결과를 트렁케이티드 사이즈 20바이트로 잘라서 사용을 하고 있습니다. 이렇게 되면 좀 더 유추하기 쉬워지는 어드레스가 됨으로써 그거에 매칭된 프라이빗 키를 찾을 확률이 더 높아지게 되고요. 그래서 저희는 모듈 펑션을 사용을 해가지고 32바이트의 어드레스도 도출을 해서 사용할 수 있게 펑션을 만들어 놓고 보시면 어드레스 길이가 조금씩 다른 걸 보실 수 있는데요. 좀 더 긴 어드레스가 이제 저희가 새로 정의한 모듈 어카운트들이라고 보시면 됩니다. 그래서 스웨거에서도 이 어드레스를 디라이브해서 사용을 하실 수 있고요. 아까 보여드렸던 민트 풀이라던가 아니면 피 컬렉터 그리고 인센티브 모듈 어카운트 같은 거를 이런 식으로 도출을 해서 저희가 버젯 플랜에 넣어서 활용을 하고 있습니다. 그 다음에 리퀴디티 모듈인데요. 리퀴디티 모듈은 이제 저희 크레센트의 덱스를 담당한다고 보시면 되겠습니다. 저희 크레센트의 덱스는 풀을 먼저 만들기 전에 페어를 먼저 선언을 하게 되는데요. 페어에는 이제 베이스 코인과 쿼트 코인 이런 식으로 구성이 되게 됩니다. 그 다음에 해당 페어에 대해서 풀을 만들게 되고 여기에 이제 리퀴디티 프로바이더들이 디파짓을 하면서 AMM에 참여를 할 수 있게 됩니다. 저희가 페어를 먼저 정의한 이유는 이 오더북을 사용하기 위함인데요. 이제 한 페어당 한 오더북이 있다고 이해하시면 될 것 같습니다. 그래서 저희는 하이브리드 덱스인데요. 일반적으로 AMM 오토메이티드 마켓 메이커가 생긴 이유가 이제 마켓 메이커가 블록체인에 붙기가 힘들어서 생긴 거였는데 저희는 이제 오더북 시스템으로서 여기에 오더를 낼 수 있다 보니까 기존 AMM과 더불어 트레디셔널 마켓 메이커들도 여기에 마켓 메이킹을 참여할 수 있게 됩니다. 물론 다른 트레이더들도 이 오더북에 거래를 참여할 수 있고요. 그래서 이런 식으로 하이브리드 덱스 형태가 저희의 특징이라고 보시면 되겠습니다. 그래서 저희 크레센트 덱스의 오더북 현재 상황이고요. 물론 저희도 유니스왑처럼 이런 심플한 스왑 인터페이스도 같이 제공을 하고 있습니다. 이거는 이제 오더를 내는 메시지인데요. 마지막에 보시면 오더 라이프 스팬이라고 있는데 이 라이프 스팬을 정의함으로써 이제 오더가 바로 사라지는 게 아니고 오더북에 유지되면서 오더북이 계속 돌아갈 수 있게 하는 옵션을 주고 있습니다. 그 다음 저희의 가장 큰 특징은 이제 멀티플 풀이 하나의 오더북에 개입을 한다는 건데요. 이제 AMM이 풀이 먼저 오더북에 오더를 깔게 되는데 이게 하나의 풀이 아니라 여러 풀들이 깔 수 있게 됩니다. 그럼 어떻게 하나의 페어당 하나의 풀이 아니고 여러 개의 풀이 가능하냐라고 말씀하시면은 저희는 이제 레인지드 풀을 지원을 하는데요. 일반 베이직 풀 같은 경우에는 프라이스가 제로에서부터 무한대까지 이렇게 쭉 넓게 리퀴디티를 깔게 됩니다. 대신 이제 저희가 레인지드 풀을 프라이스 레인지를 정의를 해서 여기에 리퀴디티를 넣게 되면은 그 제한된 레인지 안에 리퀴디티가 쌓이기 때문에 좀 더 캐피탈 이피선시가 성립되게 되고요. 이 베이직 풀과 레인지드 풀이 같이 있게 됨으로써 이런 형태를 띠게 됩니다. 뭐 예를 들어 USDC 그래비티 브릿지랑 USDC 악셀라 페어 같은 경우엔 이런 레인지드 풀로 형성이 되어 있는데 이럼으로써 이 레인지 안에서만 주로 거래가 일어나다 보니까 좀 더 효율적으로 리퀴디티를 사용을 할 수 있게 됩니다. 그 다음에 이제 트랜잭션 라이프 사이클에 대해서 설명드릴 건데요. 보통 이제 유저가 트랜잭션을 브로드캐스트 하게 되면은 체크 TX라는 걸 통해서 유효한 TX인지 판정을 하고 이게 유효하다면은 각 노드들의 멤플에 먼저 쌓이게 됩니다. 그리고 이제 밸리데이터가 프로포자를 하고 비긴 블록 그리고 메시지, 엔드 블록 형태 차례로 수행이 되게 되는데요. 결국 이 멤플의 선착순 그 오더링에 따라서 메시지가 처리된다고 보실 수 있습니다. 그래서 일반적인 SDK 모듈들의 형태로 만약에 리퀴디티 덱스를 구현을 했다면은 오더의 순번이 있을 거고 그 오더가 매 오더별로 수압이 체결되게 됩니다. 그럼 매 오더별로 이 리퀴디티를 사용을 하고 프라이스가 변경되고 스테이트가 변화되고 그 결과는 다음 오더에 영향을 주고 선착순으로 먼저 들어온 오더가 더 우위를 가질 수밖에 없습니다. 근데 저희가 사용하는 배치 시스템 같은 경우는 각 오더가 메시지 레벨에서 처리되지 않고 배치를 위해서 스토어만 합니다. 그래서 오더의 순서는 의미가 없어지게 됩니다. 이렇게 모여진 오더들은 엔드 블록에서 배치 익스큐션을 통해서 한 번에 매칭하고 수압을 좀 더 페어하게 진행을 할 수 있게 됩니다. 그래서 이제 맨풀의 오더링은 상관없이 저희가 좀 더 공정한 매칭을 할 수 있게 되는 구조를 이 배치 시스템을 통해서 진행을 하였고요. 아까 보여드렸던 오더를 날리는 메시지 타입인데 이 오더를 날리게 되면은 결국 이런 형태로 스테이트에 저장이 되고 이게 이제 배치에서 매칭이 일어나게 됩니다. 그래서 오더를 처리하는 메시지 서버 로직을 보시면은 결국 오더를 set 오더를 하는 것 외에는 별다른 로직이 없습니다. 근데 밑에 보시면은 consume 가스라는 로직이 보이는데 이거는 저희가 메시지 레벨에서 모든 걸 처리하지 않고 배치 엔드 블록 쪽에서 처리를 하다 보니까 유저는 가스에 대한 비용을 메시지 처리단에 대한 가스만 부과를 하고 있거든요. 그래서 엔드 블록에 대한 연산은 밸리데이터가 그 가스를 받지 못하고 일을 하게 됩니다. 그래서 저희는 가스를 배치에서 일어나는 연산량의 평균값을 컨슘 가스로 미리 부과를 하는 방식으로 좀 더 형평성 있게 오더를 처리할 수 있게 작성을 해 두었습니다. 그래서 배치 시스템 같은 경우에 엔드 블록에서 이제 배치 사이즈에 따라서 매번 익스큐션이 되는데요. 현재 배치 사이즈는 1로 매블록 배치가 일어나고 있습니다. 그래서 그리고 이 배치가 끝나고 방금 보여드린 오더 스테이츠들이 바로 지워지지 않는데요. 저희는 그 다음 블록에 비긴 블록에서 이것들을 지우고 있습니다. 그 이유는 오더 스테이츠를 이제 조회를 해봐야 되는데 그 블록에서 바로 지워버리면은 쿼리가 불가능하게 됩니다. 반면 다음 블록에서 지우게 되면은 예를 들어 100번째 블록에서 배치가 일어났는데 101번째 블록에서 저희가 지우게 되고 유저는 100번째 블록에 대한 스테이트를 조회를 하면은 그 과거의 오더 스테이트까지 조회가 가능하기 때문에 만약에 이렇게 지우지 않고 저희가 계속 누적했더라면 오더가 계속 쌓여서 블록체인의 사이즈가 너무 비대해질 수밖에 없는데 이걸 저희는 다음 블록에 지워서 프루닝이 안 된 노드에 쿼리를 할 수 있는 형태로 제공을 하고 있습니다. 그 다음은 파밍 모듈인데요. 방금 이제 리퀴디티 모듈에서 풀을 만들고 많은 LP들이 이제 이 풀에 리퀴디티를 제공하면서 참여했을 텐데 그 LP들에게 리워드를 주기 위한 모듈이라고 보시면 됩니다. 그래서 아까 버젠 모듈에서 파밍 인센티브를 위한 플랜을 보셨을 텐데 거기서 집행된 자금이 이제 이 풀코인을 파밍 모듈에 디파짓 한 거에 비례해서 저희가 리워드를 제공을 하고 있습니다. 그래서 먼저 파밍 플랜을 정의를 하게 되는데요. 여기에는 이제 add, modify, delete를 할 수 있는 저희가 커스텀 프로포절 타입을 정의를 하고 사용을 하고 있습니다. 그래서 add, modify, delete를 제공을 하고 있고요. 일반적인 코스모스 SDK의 여러 프로포절 타입들 중 하나로 저희가 퍼블릭 파밍 플랜이라는 프로포절 타입을 사용을 할 수 있게 되고요. 이 말은 즉슨 이제 저희가 파밍 플랜을 거버넌스를 통해서 정의를 할 수 있게 되는 겁니다. 이렇게 거버넌스를 통해서 제공하는 파밍 플랜을 퍼블릭 파밍 플랜이라고 하고 이거 말고도 이제 프라이빗 파밍 플랜이라고 해서 공적 자금이 아닌 개인 자금을 파밍을 통해서 리워드를 주고 싶다 하면은 그것 또한 가능하도록 제공을 하고 있습니다. 저희 크레센트 허브의 크레센트 네트워크의 이제 파밍 파라미터를 보시게 되면은 먼저 에폭 어마운트를 보실 수 있습니다. 이거는 이제 매 에폭마다 얼만큼의 이 코인이 이 스테이커들한테 디스트리뷰션 될 건지를 정의를 하고 있고요. 그 다음에 스테이킹 코인 웨이츠라고 해서 어떤 코인들에게 이 에폭 어마운트를 어떤 비중으로 배분을 할 것인지를 정의를 하고 있습니다. 그래서 지금까지 이 정도의 코인이 디스트리뷰션 된 거를 확인하실 수 있고요. 두 번째 파밍 플랜은 아까 말씀드렸던 프라이빗 파인 플랜인데 이 같은 경우에는 이제 그래비티 브릿지가 자기의 그래비티 토큰을 이 그래브 비크리 풀에 풀코인을 디파짓한 유저들한테 인센티브를 주기 위해서 프라이빗 파밍 플랜으로 정의를 해서 지금 리워드가 같이 나가고 있는 상태입니다. 아까 디라이브 어드레스 설명해 드렸는데 만약에 여러 이제 풀코인들이 스테이킹이 될 텐데 이게 하나의 모듈 어카운트에 모이게 되면은 그 한 모듈에 큰 자금이 모이고 그 위험성이 더 커지게 됩니다. 그래서 저희는 스테이킹 코인 디놈별로 이 리저브 어드레스를 동적으로 각각 다르게 만들어서 거기에 각각 모여서 처리될 수 있게 사용을 하고 있는데요. 그래서 아래 보이시는 스테이킹 리저브 어카운트 펑션을 보시면 디놈을 받아서 어드레스를 도출하게 됩니다. 그리고 프라이빗 파밍 플랜의 풀 어드레스까지 동적으로 만들어서 제공을 하고 저곳에 이제 자금을 집행을 하면은 그게 파밍 플랜대로 리워드가 나가게 되는 구조라고 보시면 됩니다. 파밍은 일단 풀코인을 가지고 있는 유저가 언팜을 할 수 있게 되는데요. 이게 바로 팜이 되는 게 아니라 저희는 큐 구조를 한 에포 길이만큼 받고 있습니다. 현재 한 에포 길이는 하루 24시간으로 잡고 있는데요. 저희가 큐를 가지는 이유가 만약에 UTC 00시에 에폭이 넘어가는데 00시 1초 전에 팜을 했다. 근데 1초만 팜을 하고도 하루 에폭에 리워드를 받아가는 그런 체리피킹이 가능할 수 있기 때문에 그거를 방지하고자 저희는 하루에 한 에폭의 큐 상태를 거친 다음에 그 다음부터 이제 매 에폭마다 리워드를 받을 수 있게 설계를 하였습니다. 또한 저희는 F1 디스트리뷰션이라는 컨셉을 사용을 하였는데요. 만약에 보시면은 이 에폭이 흐름에 따라서 이제 리워드가 얼마씩 내려갈지 계산을 할 수 있습니다. 근데 매 에폭마다 이 사람한테 얼마, 저 사람한테 얼마를 계산해서 블록체인에 들고 있게 되면은 파머가 적으면 문제가 없겠지만 만약에 파머가 10만 명이 넘어간다. 그러면은 매번 10만 명의 리워드를 계산해서 기록을 해야 되는 버든이 생기게 됩니다. 그래서 F1 로직을 사용을 하게 되면 결국 각 에폭마다 얼마만큼의 리워드가 나가야 되는지 그거를 히스토리컬하게 저장을 해놓습니다. 그 저장된 유닛, 그러니까 한 스테이킹 코인 한 개에 대한 리워드를 저장을 해놓고 이제 팜이 시작한 날부터 끝날 날까지의 그 레인지만 알면은 그 아까 저장해놨던 히스토리컬한 유닛 리워드를 통해서 이거를 계산할 수 있게 됩니다. 그러면 이제 리워드를 매번 블록체인에 매 에폭마다 저장할 필요 없이 이 사람이 쿼리를 해보거나 아니면 언팜을 할 때만 이 범위에 대해서만 리워드를 그때마다 계산을 할 수 있기 때문에 좀 더 효율적으로 블록체인에서 파밍 모듈을 구현을 할 수 있습니다. 그래서 캘큘레이션 리워드 부분의 코드를 보시면은 먼저 히스토리컬 리워드를 스타트 에폭부터 엔드 에폭까지를 가져옵니다. 그 다음에 이 두 개를 뺀 diff를 구하게 되고요. 이 diff에다가 이제 결국 얼마만큼의 스테이킹 어마운트가 있느냐를 곱해가지고 이 리워드를 간단하게 도출해낼 수 있습니다. 그래서 저희가 10만 명의 파머가 있고 100개의 풀코인이 있을 때를 시뮬레이션 했을 때 마이크로 세컨드 단위로 이 연산이 끝날 수 있다는 것을 시뮬레이션을 통해 확인을 하였습니다. 네, 파밍 모듈의 파라미터 보실 수 있고요. 아까 리퀴디티 모듈에서 가스를 미리 부과했던 것처럼 파밍 모듈에서도 이제 큐 메커니즘이 들어가기 때문에 딜레이드 가스 피를 일부 걷고 있습니다. 그 다음에 리퀴드 스테이킹 모듈인데요. 리퀴드 스테이킹은 기본적으로 일반 스테이킹 모듈을 사용했다면은 크리를 스테이킹하고 이게 스테이킹 모듈에 묶여버리게 됩니다. 그러면 이제 묶어놓고 리워드를 받을 수 있지만 그 자유도가 떨어지게 되죠. 근데 리퀴드 스테이킹 모듈을 사용을 하면은 크리를 넣으면은 비크리를 저희가 민트해서 주게 됩니다. 그래서 이 민트된 비크리는 마음대로 스왑하고 전송하고 사용을 할 수 있게 됩니다. 그럼 이 비크리는 어떤 역할을 하느냐? 만약에 X만큼의 크리를 디파짓하고 비크리를 일부 받았어요. 그리고 시간이 좀 흐른 다음에 다시 이 비크리를 번하면은 내가 디파짓했던 X 크리만큼 이상으로 Y만큼의 스테이킹 리워드가 이제 베어링된 양만큼을 추가적으로 받을 수 있게 됩니다. 그래서 예를 들어 빅크리를 1년 동안 가지고 있었다 하면은 현재 기준 APR 31%의 리워드를 단지 빅크리를 들고만 있어도 획득할 수 있는 겁니다. 리퀴드 스테이킹에는 이제 LSV라는 리퀴드 스테이킹 밸리데이터를 정의를 하고 사용하고 있는데요. 이거는 이제 거버넌스를 통해서 저희가 좀 능력이 좋은 밸리데이터들을 이제 거버넌스를 통해서 선정을 하고 걔네한테 이제 저희가 나눠서 리퀴드 스테이킹을 하게 됩니다. 현재 기준으로 12명의 리퀴드 밸리데이터들이 나와 있는 모습을 보실 수 있고요. 만약에 현재 민트 레이시 0.9라고 가정을 해봅시다. 그러면은 30크리를 리퀴드 스테이킹 하게 되면은 먼저 27비크리를 민트를 받게 됩니다. 이거는 민트 레이스를 곱한 양만큼을 받게 되는 거고요. 그럼 여기에 이 역할을 대행해줄 프록시 어카운트가 있습니다. 프록시 어카운트가 아까 설명드렸던 리퀴드 스테이킹 밸리데이터들한테 각각 나눠서 30크리를 3분의 1씩 나눠가지고 델리게이트를 하게 됩니다. 델리게이트를 했으면 리워드가 쌓이겠죠. 그래서 시간의 흐름에 따라서 이 프록시 어카운트에 리워드가 계속 쌓이게 될 겁니다. 이거를 매번 리워드를 뽑아서 쓸 수도 있지만 너무 비효율적이기 때문에 리워드 트리거랑 리밸런싱 트리거를 저희가 가지고 있는데요. 이 트리거 이상만큼의 리워드가 쌓이게 되면은 이제 리워드를 위드로 해서 LSV들한테 다시 리스테이크를 하게 되고, 만약에 LSV에 변동이 생겼다 하면 리밸런싱하는 기능도 가지고 있게 됩니다. 그래서 이 크리의 넷 어마운트가 리워드와 함께 커짐에 따라서 민트 레이스는 낮아지게 되고 비크리를 번하면 받을 수 있는 크리의 양도 늘어나게 됩니다. 그럼 시간이 흘러서 민트 레이시 0.8이 됐다고 가정을 해봅시다. 아까 받았던 27 비크리를 다시 번을 요청을 하면은 유저는 총 33.75 크리를 받을 수 있게 됩니다. 이 로직을 보면은 이제 LSV들한테 동일하게 또 나눠서 언델레이 게이트를 요청을 하는데요. 이 언델레이 게이트는 언본딩 피리오드 현재 기준 2주 정도의 시간이 걸리는데, 이 2주 후에 스테이커한테 돌아갈 수 있도록 언본딩 델리게이션 오브젝트를 수정을 해서 바로 스테이커가 언본딩한 효과를 누릴 수 있도록 하고 있습니다. 그 다음에 이렇게 비크리를 통해서 스테이킹에 간접적으로 참여를 했는데, 스테이킹 리워드를 받을 목적도 있지만 거버넌스를 참여하는 목적도 있을 수 있습니다. 그래서 일반 스테이킹 모듈 같은 경우에 이제 참여한 스테이킹 양만큼 보팅 파워를 받게 되는데, 저희도 동일하게 보팅 파워를 가질 수 있도록 리퀴드 거버넌스라는 개념을 도입을 했습니다. 그래서 비크리의 밸런스 혹은 비크리를 포함하는 풀코인의 밸런스, 또 이 비크리의 파밍 포지션, 또 이 비크리의 풀코인을 파밍한 포지션에 대해서 저희가 동일하게 크리 가치만큼의 보팅 파워를 계산을 해서 적용을 해주고 있습니다. 여기서 보시면은 이제 풀코인에 대한 보팅 파워와 파밍 포지션에 대한 보팅 파워를 계산하기 위해서 리퀴디티 모듈과 파밍 모듈에서 가져오고 있고요. 이제 거버넌스 모듈에서 보팅 파워를 계산할 때 리퀴드 스테이킹 모듈의 훅을 통해서 각 보터가 얼마만큼의 보팅 파워를 들고 있는지 요청을 하고 그 값을 전달해서 거버넌스 모듈에서 그대로 그만큼의 보팅 파워를 인정받을 수 있게 됩니다. 만약에 일반적인 거버넌스 같은 경우에 밸리데이터가 yes라고 만약에 보팅을 했고, 그 밸리데이터한테 델리게이션한 델리게이터가 no라고 보팅을 했으면은 이게 오버라이트 돼서 그 델리게이터가 더 우선시 되는 이 보팅 파워를 적용을 시킬 수 있습니다. 이와 같은 로직으로 일반 스테이킹의 스테이킹 보팅 파워를 오버라이트 하는 것처럼 저희는 리퀴드 거버넌스의 보팅 파워도 이렇게 오버라이트를 해줌으로써 저희 리퀴드 거버넌스 구현을 하였습니다. 그래서 이건 일반 거버넌스 부분의 텔리 로직인데요. 보시면은 보팅 파워를 이제 오버라이트 하기 위해서 밸리데이터의 보팅 파워에서 델리게이터의 보팅 파워를 제한하는 모습을 보실 수 있습니다. 그럼 이 리퀴드 거버넌스에 대한 부분은 저희가 정의한 set liquid staking voting powers라는 이 훅을 통해서 리퀴드 스테이킹 모듈에서 보팅 파워를 계산해서 거버넌스 모듈로 전달을 하게 됩니다. 그래서 이 additional 보팅 파워스라는 오브젝트를 정의해서 저희 리퀴드 스테이킹 모듈 말고도 다른 모듈에서 이 자유도 높은 보팅 파워를 후킹해서 쓸 수 있도록 구현을 해놨고요. 이 additional 보팅 파워 같은 경우에는 특정 보터가 어떤 밸리데이터한테 얼만큼의 보팅 파워를 행사하고 있는지에 대한 스트럭트입니다. 아까 리퀴드 스테이킹 보시면은 여러 LSV한테 나눠가지고 델리게이션을 하게 되는데요. 그래서 리퀴드 스테이킹을 했다면 그 리퀴드 스테이킹 밸리데이터들한테 균등하게 배분된 보팅 파워를 이제 행사할 수 있게 됩니다. 그래서 이런 식으로 훅을 호출해서 동일한 아까 델리게이션 부분을 오버레이트 한 것처럼 이 애디셔널 보팅 파워도 밸리데이터의 보팅 파워에서 디덕션을 시켜서 동일하게 적용을 받을 수 있습니다. 방금 이 거버넌스 모듈을 저희가 이 훅을 추가하기 위해 일부 커스터마이징 했는데요. 이런 식으로 앱을 개발하다 보면은 코스모스 SDK를 조금 커스터마이징 할 필요성이 가끔씩 생깁니다. 말씀드린 거버넌스 케이스가 있었고 스테이킹 모듈 같은 경우도 저희가 일부 수정을 하였는데 일반적인 순전 스테이킹 모듈 같은 경우는 베스팅이 되어 있는 어카운트도 델리게이션을 하고 리워드를 받을 수 있습니다. 하지만 저희는 크레센트의 정책상 이 부분을 막기 위해서 베스팅 어마운트는 델리게이션을 못하도록 저희가 수정을 하였고요. 또 뱅크 모듈 같은 경우에는 아까 많은 모듈 어카운트들이 있었는데요. 보통의 모듈 어카운트는 M 레벨에서 미리 이 어카운트가 모듈 어카운트라고 블록드 어드레스로 지정을 하게 됩니다. 모듈 어카운트에 다른 사람이 돈을 샌드를 하게 되면은 그 로직이 깨질 수가 있는데요. 이거를 막을 수 있어야 되는데 M 레벨에서 미리 선언하지 않고 아까 저희 파밍 모듈 같은 경우처럼 여러 모듈 어카운트를 동적으로 생성하는 케이스에 이 블록드 어드레스를 적용시키기 위해서 이 해당 인터페이스를 추가하였습니다. 그래서 이렇게 커스터마이징한 코스모스 SDK 레파지토리를 고 모드에서 리플레이스하는 형태로 사용을 하고 있습니다. 네, 여기까지 크레센트 모듈 코드를 살펴보았고요. 다음은 이제 저희가 디파이 디벨로퍼 저희 채용하고 있으니까 많은 관심 부탁드립니다. 감사합니다.